So far what we have seen how a database is created. We as a data engineer were creating database for Imarticus where certain tables needs to be created and certain relationship needs to be maintained. Now first of all, so far what we have seen, how does a DDL commands works, what are the different DDL commands, and now over here we have created one table known as students table based on the data types which we can use in SQL and the constraints which were there. When we were studying about the constraints, now what are constraints? Constraints are nothing but the rules and limitations which you can implement on the type of data which you need to store into your tables or into your database as such. But when we were studying constraints, the two of the major important constraints which we are going to revisit and understand in a more elaborative manner is primary key and foreign key. Now, what is an importance of a primary key and foreign key in a table? Why primary key foreign key relationships are so important and how it can help you to maintain the flow of data in a proper manner. Let's try to understand that today, and let's see how both of them would be able to create a relation for the same. And when a relation is created, what are the necessary requirements which needs to be maintained when a database structure is being created with a relational database management system. So let's study and talk upon the first important constraint amongst the primary key and foreign key, nothing but a primary key. Now if you can see, this was a table which we created, and let me just create another basic one for the same. So imagine that I had a table which we created over here named as students table. So the table was named as students and it has certain columns, or I can call it as fields or attributes within it. So what were the columns? If you can see over here, there was student ID, student name, age, city, phone number and gender. So let me create that. Let's say student ID, student name, age, city, gender and phone number. So these were the columns which we created into the students table. Now what is a primary key? Which column do we think so a primary key could be created? Over here when we created a table, we created students ID as a primary key. Now what was a key requisite of a primary key? Let's understand that in detail. Why? Because when we create a relation, the primary key understanding is very important. So first of all, if I want to talk upon a primary key, now primary means one and necessity or an important key into my table or into my database management system. So when I talk upon primary key is a combination of something called as not null, which means it cannot consist of null values, plus unique, which means if the values are filled, all needs to be what? Unique. Now not null means it's mandatory, and unique means each value should be different from the another. So primary key is a combination of not null and unique. And why do you think so? Primary key is created into a table. A primary key add uniqueness. It adds uniqueness. What is the meaning of adding uniqueness? That it makes sure that each record into the table is different from the rest. So that is how uniqueness is required over here, and primary key will help you to get that particular aspect. Now one of the major thing which you all need to focus is only one column can act as a primary key. Now there could be many columns or many attributes or many fields into your table which can behave like not null and unique, which can add uniqueness, but there should always be one primary key into your table. Now let's see how. The database which I have to create is an Imarticus database, and in that so far I have created one table named as students. With this students table, there were certain attributes such as student ID, student name, age, city, gender, phone number. I created student ID as a primary key. I have given my reasons earlier, but let me talk about it more detailed. So what is that? Student ID. Now student ID of a student. Imagine me joining as a student in Imarticus. So let's say my ID is 101. Let's say my ID is 101. My name is Jagrati. So my name is being stored over here. Let's say my age is 25. So it's being stored over here. City states as Mumbai. Gender is female. Just understand it. It's Mumbai. And the phone number, I give some random number over here. That's being passed. Imagine there is one more student who is coming into the Imarticus database and her name is also Jagrati. Let's say her name is also Jagrati. Her age is 27. She is belonging from Pune and the gender over here is female and her number is something different. Imagine that. Now, she can't get the number which I have, which means I being a ID or I being a student, I have got a number as 101 and I am one entry. Now, this is another entry and this number or this student is getting an ID of 102. If you can see, 101 and 102 both are different from each other. Now, what is the meaning of that? That means this student and this student is different from each other. Each record is different even though the name seems to be what? Same. That is one point. So primary key helps you to add distinctiveness or uniqueness into your table. Now you will always say that why can't a phone number be a primary key? Obviously, phone number can also add uniqueness into the table. Each student or each individual can have phone number which is different from the another one. That could be possible. So why I am just thinking of student ID as a primary key? First of all, my first assumption over here, whenever I have to choose any column to be a primary key into your table or into my table or any of the table as such, is it should always follow a rule of not null. Now, not null means I know that each student who enroll into the organization or into the student database is going to have some or the other enrollment number or unique ID which is there. Now imagine today I am going on Amazon and I have created one ID on the basis of one email ID. Tomorrow I have that ID generated. I have that customer ID generated for them. Let's say I am trying to create another account with the same mail. It will give you error. Why? Because that same mail has been used, has been utilized. They will say that customer ID is generated for this particular mail. You have to use that customer ID. So as you can see, each customer is going to have different IDs. So similarly, when new student join, each student is going to have different student ID over here. So not null, which means each of the student is definitely going to have ID. There is no students without ID. Not null is being satisfied. Now I cannot keep student name. Why? Because I know student names can be kept mandatory, but they cannot be unique. Why? Because as you can see in my table, Jagrati and Jagrati, there are two students with the same name and that's ideally possible. None of us is having distinct name from the another one. There would be n number of students or there would be n number of people with same name. So not null as a constraint could be satisfied with student name but unique could not be able to. Why? Because none of the individual is having unique name from the another one. So that column acting as a primary key is ruled out. Student ID is still into the list. Now let's talk about age. Imagine my age is 25. The other student who is sitting beside me is 27. Now there is one more student who enrolled and his or her age is also 25. Now it's not following the rule of uniqueness because none of us is being having or none of us is being consisting of unique age from the another one. So that not null could be possible but unique could not be possible over here. City, same reason. Now multiple people or multiple students can belong from the same city over here. So it could be not null but uniqueness would be ruled out. Now gender, as you know, male and female, these are the two criterias. That gender could only be male, it could be only female. We cannot have uniqueness over here. phone number is still into the list in order to act as a primary key, because each individual I know is going to enroll from a different phone number. But what if student is not having any number? He will keep it blank at certain instances. He will keep it empty, or some of the students might repeat phone number of individuals. That could be possible, but that is at a very odd instances. But phone number might not be a mandatory part to be there at certain instances. Why? Because some of the students might not have a phone number or a contact detail, and that might be kept as blank. There are possibilities in future to be that way. So what I could do is, I have two columns which can act as a primary key for me. One, just a second, one is student ID and one is phone number. I know when I'll create a different table, definitely there will be student ID preceded, which means if I want to allocate some course, I will allocate on the basis of student ID which is generated, not particularly on the basis of phone number. Now, if I want to generate or if I want to create the score sheet of that particular individual, definitely I will use student ID at a very rare, very particular instance instead of phone number. So, I can think of this column as a primary key. Why? Because I can create relations with this key from the another table. I can make it as a primary key, but as you know that only one column can act as a primary key over here. So I can keep it unique plus not null, which means I can add two constraints over here and make it one. But as per the rule of primary key, it should be one column in the table which is there. So if I want to add uniqueness to each row or each record over here, I'll definitely choose a student ID. So each student ID is referring that each student is a different record from the another one, and that's why I have chosen student ID as a primary key. Now there are many instances where you can choose phone number as a primary key in order to create relation. There can be mail IDs as such, or there can be other instances or other columns which might act as a primary key. Now you have to further inspect your data very clearly, very effectively, and then make sure that which column to act as a primary key. Why? Because primary is important and it is always going to be one in a table, and over here my student ID is going to act as a primary key. Now, why a primary key is created? Now, always everyone has a question, and I have answered the question that primary key makes sure that each entry is different from the another one, which means it adds uniqueness or distinctness to your record set or to your data set, which makes sure that records are different from each another. And that was about the primary key which we created. So, I hope you understand what is a primary key. You can create one primary key in your table, but unique and not null constraints could be added to n number of columns into your table. But you have to be sure when you're applying constraints that when to apply and what to apply over here. Now, why do you think so? A primary key is created, and what is the purpose of a foreign key related to the primary key? Let's understand that. Now, one more thing to discuss about over here is whichever table has a primary key associated with it, it is also known as a parent table. Parent table. Now, what is the meaning of parent table? Parent table is a main table from where the information could be related. But there could be multiple tables where multiple primary keys, means there are 4 tables. So the 4 tables can have 4 primary keys, each in one of the tables. So which table should act as a parent table? Which table should act as a child table? Let us understand that as well over here. So I hope we are clear till here, and I'll be erasing this detail because I'll be requiring it for the further go, and I'll help you understand that why I'm erasing it. So I've kept it empty. This is what we have created so far. Now let me talk upon a foreign key. So let me talk upon a foreign key. Now, what is the meaning of the word foreign? You must be knowing. Foreign means someone from outside. Yes. So foreign key is a key which comes from another table, or which helps you to make relation with the another table. That is a foreign key. So foreign key is used to create relations. Now foreign key. What is a foreign key? Foreign key is a foreign key is an attribute. Now you must be knowing what is the meaning of attribute. Attribute means nothing but a column name. So a foreign key is an attribute or a set of attribute. Now what is the meaning of set of attribute? Set of attribute means multiple columns. So foreign key is an attribute or set of attributes which helps to create references, References means a relation, references within the tables. So this references would be created within the table. Just a second. Within the table to maintain. Now this word is very important. To maintain. To maintain what? To maintain a word, which is very important in terms of foreign key. That is nothing but referential integrity. That is the meaning of what? Referential integrity. So foreign key is used to maintain a term known as referential integrity. And whenever you're talking about a foreign key, whenever an interviewer is asking you about foreign key, the word known as referential integrity should always be a part of your answer. This is a necessary keyword which needs to be mentioned and which needs to be explained into your foreign key ka definition. Now, I'll explain you in detail what is the meaning of referential integrity, why it is important, and how that helps you to maintain the data flow very effectively. So, as I said, a foreign key is an attribute or set of attribute, which means you can have one foreign key, you can have multiple foreign keys in a table, which create references within the table to maintain referential integrity. Now, as I have said, there is a word known as referential integrity, but what is the meaning of integrity? What do you understand by something called as integrity? Let's try to understand that. So, let me first make you understand something called as data integrity. Now, imagine there is a product. Imagine today I want to buy a phone. And I'm buying a phone of Samsung. Let's say I'm buying a phone of Samsung Flip 5. I want to buy a phone over here. Now, if I want to buy a phone, it's not like I'll go to one particular website and then buy it at random. No. I do a lot of checks at different websites, and then and only then I'm going to buy. According to Indian mentality, that wherever I feel so, okay, this price is less, this is my good cost, and this is where I'm going to buy. So imagine that my product which needs to be bought is what? Is Samsung Flip 5. And I go to 3 different stores. First, I visit Amazon. Everyone's favorite site, Amazon. Now when I go to Amazon, the cost of this phone is, let's say, 190,000. Imagine. Now it's a rough estimation, it's not an actual cost. So let's say the phone cost is 90,000. Now definitely I'll not go on Amazon directly, put it in cart and buy it out. I'll go and check on Flipkart. Correct? Now you want to get a good deal, so you will definitely go on Flipkart. And on Flipkart it is showing me, let's say, 89,000. So I feel so, okay, 89,000 is lesser than 90,000. Let me buy from Flipkart over here. So I can think of buying from there. Now imagine that tomorrow I don't think so, like Flipkart and Amazon where I'll buy. I'll just inspect once in Chroma. So there is a Chroma showroom near me. And I went over there and there was a discount offer at that particular time and the phone is costing me around 85,000. So if you can see, the phone brand is Samsung Flip 5 and at Amazon it is costing me 90,000, Flipkart 89,000 and Chroma 85,000. So do you think so the cost is same throughout? No. The cost is changing for different sites. For different databases the costs are changing. So here when I talk upon integrity, the word integrity, just a second. The word integrity means same throughout. Just a second, let me change the color. Yeah. The word integrity over here means same throughout. Means the value of the data should be what? Same. There should not be any discrepancy in terms of value matching. So if you can see Samsung Flip 5, in this database it's 90,000, Flipkart 89,000, Chroma 85,000. So it's not same throughout, which means there is no integrity into the databases. And definitely the databases are two different platforms and that might not have integrity over here. But when it will be into integrity, let's say it was 90,000, it was 90,000 over here and it is 90,000 over here. If that was the reason or if that was the case, the data would follow an integrity. Now, I hope you are clear with what is the meaning of integrity. Now, integrity means the value should be same. I am not going to do a data integrity concept, but I am going to make sure that you understand what is the meaning of referential integrity. For that, you need to know the term known as integrity. So, integrity is nothing but same throughout. So, as we have done so far, so with this outcome, I can say yes, my data is into integrity. But let's talk upon the main term over here. What is the meaning of referential integrity and how it will be helpful? Imagine now a student who has enrolled as per my data engineering part, he or she would be allocated with a course. Now let's create another table known as course. So I've created over here and let me create a very small table. I just created here itself so that you will all see. So I'll create a very small table over here known as course. Now in this, let us have some names. So this table is what? Course table. And here I have a course ID. I have ID of the student and I have the course name in which the student has enrolled. Let's say this is the data which I have. Now I want to say that this table and this table is related to each other, which means the student who has enrolled, that student would be allocated with the course. That kind of information I want to give. First, when I am creating a table, let's say this is a table which I have created and course ID and course name is a column which I have. If I want to join this two table or say that there is a relation between two tables, I need some common column between them. But you can see there is no column with the same name. So can I have a common column between them? It doesn't seem it's possible. Why? Because the name is not same. But it doesn't matter, the name needs to be same. The thing that matters is when a relation is created, that is the data type and the column or the data definition needs to be what? Same. So if you can see your ID and your student ID. Now what is this course table? It will consist of course ID, the student who is doing the course and the name of the course. So if I want to join these two tables on the basis of student ID and course ID, student ID and ID from the course table, I could possibly do. But imagine that when a course table was created, this is not a foreign. So I am giving it as varchar. Let's say it's varchar. ID is a primary key, being integer, okay? And here the name of the student is a varchar. I want to study what? I want to study a foreign key. Where did I create a foreign key? I know that the student ID of this table and ID of this table needs to reference or needs to create relation. But did I have created any foreign key to make a relation? No. Now why do you think so it's important? Now keep this pointer in note that references. Now this is a note which you all need to remember, that is references or relations. References or relations within the tables, which means when I have created references or relations within the table would be between a primary key, I am writing a short form as primary key, and foreign key, which means whenever I am referring a table or I am creating relations, it needs to be maintained between one primary key and one foreign key. That is one of the major requisite over here. Here I know that this table has a primary key. I know that this table has a foreign key. But where is the foreign key? I don't see anywhere. I can see two primary keys which are there. Now remember one point as well. In order to reference to another table or relate to another table, a column or any of the column can act as a foreign key. Now foreign key doesn't have that requisite that it needs to be not null and unique. It can be repeated, it can be having null values as well. So my foreign key can have those concepts. So here it is a primary key, but I want to create a relation, so I will make it as a foreign key just to create a relation. Just in order to create a relation, I am going to make it as a foreign key. So just observe that how the relation is being created and how the referential integrity is maintained. So I will say that this table is having a foreign key known as ID, which is going to refer to this table, which means it is going to look for students table, and then and only then the data in this table is going to be filled. So I will create a relation in such a way, just a second, in such a way that this table is referred to this, and you can see this table is referring to this table. I've just given one demo arrow over here that this table is referring over here. So foreign key is what? Foreign key is my this column ID, which is taking references. So foreign key is an attribute or set of attribute which helps you to create references, means referring from the another table or within another table which is there. So a relation needs always be created between a foreign key and a primary key. I hope it's clear with you all that how a relation is being maintained. Now what is that relation called and how we can justify this relation, how this reference will help you to maintain referential integrity, that's what we are going to study over here. So as you can see that there is a relation created between one foreign key and a primary key. And you can see foreign, which means coming from outside. This relation is coming from a different table over here. So this is a relation created. Now what is there? A table where you have a foreign key is known as referencing table. Now, what is the meaning of referencing table? Referencing means referring table, which means this table is going to take references or some kind of checks from the students table. Unless and until the checks are being made, no entry is going to be filled into the course table. Now what kind of checks? Let's try to understand that as well. So this is known as referencing table, and in the relation which is created, a table which consists of a foreign key is known as a child table. And one primary key can relate to multiple foreign keys, which means multiple tables can be related to that one particular key which is there. So if you can see, a relation is being created. So this is a child table. Now this is a referencing table because this table is going to refer something from this table. So a table where a primary key there in the relation is known as a parent table. It's a parent table, and it is also known as popularly referenced table. Now what is the meaning of referenced table? Which means this table is being referred, this table is being utilized to fill something in another table. So that is the meaning of referenced table. So I have a relation between a referencing table which is referring and the reference table which is letting it to refer, which means letting it to look. Now, as I have shown you some technical word, let me help you to understand it in a more detail. Now imagine this is the relation which is being created, and I'm trying to fill in the details over here. Let me add the details over here. And I say the student ID is 101. The name of the student is Raj. The age is 24. Let's say city is Mumbai, gender is male, and the phone number is something. Now let's say I give as 102. So these are the students who have enrolled, and let me give the name as Rashi, and the age is 25. Here she belongs from Pune. The gender is female, and she has some number which is there. Now let's say I add 103, and here the name is, let's say, Joy, now 24, and he is belonging from Bangalore. The gender is male, and the phone number is something over here. And let's say there is another student who has enrolled, 104, and let's say I give name as Eric. The age is 25. He belongs from Mumbai, and the gender is male, and here I give some random number over here. So here you can see these are the students who have enrolled, which means who have inquired for some or the other courses which are being sold into the Imarticus part. So their data entries are being created. So each student has a different or a unique number which is known as a student ID, which is acting as a primary key. Now all the students definitely who have enrolled is not going to take the course. They are not going to be the part of the course. Now 4 of the students came an inquiry, and the details were created into the Imarticus ka student database. The students have enrolled. But course enrollment is not done by all of them. Let's say I have course as C1. It is being done by 102. And the course name which they are doing is what? SQL, which is correct according to the relation. Why? Because this table, when the data is being entered, is referring. What is the meaning of referring? Means it is looking out. Is it correct or incorrect? So here you can see ID to ID, this reference is being created. So 102 and 102 over here. Is there an ID match? Yes. So reference is being created. So when 102 course allotment is done, it is definitely saying yes, you have been a part of the students, and then you can get a course. SQL is being done. Let's say I give C3 as a course to 108 and Python. This entry is going to have an error. It is not going to be entered. Why? Because you can see reference between ID and ID is created. What does ID say? 102, 102 match is being found. 108, when it is trying to enter, then it is referring to students table, which means looking or checking or validating with the students table. 108 as an ID is not there. Obviously 108 ID is not there. How come that student is doing course? It could not be possible. And when you try to enter this entry, it's not going to show any outcome. It is definitely going to show error. Why? Because the entry of the child table is not matching with the parent table. This is a major important of references or relations which are created between two tables with the help of a foreign key and a primary key. Why it is called as referencing? Because every time it is having something, it is referring to the main table where a primary key is there. It is also known the parent table at that particular instance, and it is checking the integrity. If you can see 102, 102 fine, but 108 and no 108, there is no same value, so there is no integrity. So when you create reference and when you try to check is the value same, in order to maintain referential integrity, here it's not being maintained. So referential integrity over here would be ruled out and it is going to give me an error. This is the meaning of referential integrity. What does it say is that when a foreign key table is referencing to a parent table or a child table, it will try to refer or it will try to maintain the integrity, that is the same element based on the relations or the relational column which is being used. The table which is taking referencing is your course table and the table which is being referred is your parent table, and both of them are helping us to get a referential integrity maintained, and this is how the data flow would be kept the same. So as you can see that I have created a reference between a foreign key from my course table and a primary key from my parent table, that's my student table. Now parent table being my main table from where the foreign key is going to take referencing, which means refer something in order to fill. Now as you can see that when I was trying to fill 102, it was able to be filled in. That student is getting allocated with the course. So referential integrity is maintained. But when I tried to fill in the course details for 108 as a student, and that student is not being matched from the base table or the reference table or my parent table which is there, so that integrity was not being maintained and that kind of record is not being entered. If the relationship between primary key and foreign key would not have been created, 108 as a course could be added into my data and that can cause some data discrepancy. How? That 108 as a student is not available, then how come that student is doing a course if that referential integrity was not being maintained? So this is how referential integrity or the references between primary key and foreign key is important. Now I wanted to show you a little detailness about those references which are being created and how the data flow would be maintained when we try to insert some data, when we try to update some data, or when we try to delete some or the other elements over here. Let's try to understand that in detail, that how this referencing is going to deal with a parent table and with a child table. So imagine that there are two types of tables which I have. The very first over here is my referenced table. Now you all must be knowing my referenced table over here is nothing but my parent table. And there is something called as a referencing table. Now what is a referencing table over here? The table which is referring some value, that is a child table which I have. And I wanted to show you that how the referential integrity is maintained and what are the new key aspects which are added between these references when are those created. So imagine that I have a data and I'm trying to insert some value. Now what is the meaning of inserting a value? Adding a data points over here. So where I am adding a data points is reference table. That is my parent table. Now which one is my parent table? If you can see, this one is my parent table over here. Now imagine there is one more student who has enrolled and the ID is created as 105, and let me write the name of that student is, let's say, Raj again. And here you can see age is 24, he is belonging from Mumbai, gender is female, and some number is 992. So phone number is different, but if you can see, rest of the detail seems to be same. So these are not two duplicate entries because of the ID, it has made it as unique. So when I try to insert any data into my reference table, that is my parent table, it is not showing any errors to me. Why? Because n number of students can enroll or n number of students can at least log in or registered into the student database. For an example, let's say you go on Amazon. It's not mandated that you have an account on Amazon, then you have to order as such. Many people can just create the account, be the customer of the Amazon database, but might not buy anything as such. So here also n number of students can come, inquire, create their data entries, but it's not mandated that all the students are going to be allocated with the course. So here if you can see, when I'm inserting data, which means I'm adding data into the reference table, it is not going to cause any issue. So I can say no problem means no issues, or I can also call it as no violation. Now what is the meaning of no violation? No violation means that the data is not going to have any of the problem when the data is being inserted. So n number of records can come and be inserted into my parent table, that is my reference table. Now let's talk upon update. Now imagine that I'm going over here and I'm updating some data. Now what I'm updating? Imagine the ID which I gave for one particular student, I don't want that ID to be followed. I want it to update. So let's say when I gave ID as 103, I want to update this as 106, which means the student ID. Now this update is with respect to the integrity constraint. Now integrity is maintained by IDs and IDs. So here if you can see 106, the ID is being updated. Is there any issue caused over here for me? No, because there is no such record into my child table, that is into my referencing table. So there is no such violation. But what if I go and update the ID of 102, which is Rashi, and I update it as 109? Obviously, some integrity constraint would be hampering over here. What it could be? As you can see on my screen, now 102 has changed to 109. But is 102 changed over here? No. So what does this specify? That when 102 is doing course, but in my students table, can you see that 102 is doing course or 102 as a student has been enrolled? No. You cannot see that 102 as a student being enrolled. So does the integrity is maintained or is it same throughout? No. Why? Because 102 as a student is no longer into my database. How come he or she is doing the course? Which means 102 over here needs to be validated or needs to be changed at the same time, or may not this update is possible. So what is this called over here? If you can see, when I did updation, let me repeat it again, that this is the student, these are the students. Let's say I say 103 that is Joy's ID, I want to change from 103 to 106. I've changed it and there was no problem. Why? Because it's not available into my child table. That's fine. But when I go to Rashi, that is 102 as an ID, I'm not going to change anything. If anything else changes, it's fine. But ID and ID change, that is not fine. So 102 as an ID, I'm changing to 109. Which means 102 as a student is no longer there into my system. It has changed to 109. But if you can see my course table, that student is still doing a course. Can you think that 102 as a student is no longer into my system? How come that person is doing a course? That's hampering my integrity rule. That's hampering my referential part. So this kind of update or maintaining the relation and updating a data into my reference table when the data is also available into my referencing table may cause violation. Now why did I say may cause? Because when I did 106 there was no limitation or there was no violation, there was no problem for the database. But when I did 102, as it was a part of my child table, the reference was maintained, it was causing a problem. So what can we do to avoid that kind of problems? So there are solutions for the same as well. But when I am doing update, as I said, it may cause problem, may cause what? Problems or violations. Let me write it in a proper term, that is violation. What does it mean? That means when I'm trying to update at one particular part that is into my parent table and the same integrity part is available into my child table, this update would cause an error. It will give you restriction. So what you can do to avoid that? One thing which you can do is cascade. So they have rules known as cascade. Now what is the meaning of cascade? Cascade means all at once. Means it will happen simultaneously. Now if I go over here and talk upon cascade, let me talk. That is, if I am updating 102, which is also a part of my child table 102, if I am updating it to 109, if the value which is updated at parent table is available into my child table, that also gets updated at the same time. So 109. Now the integrity is maintained, there is no violation into the rule. So in order to avoid the violation, we can do this task. That is, we can update the data over here with the cascade. Means if it is updated in the parent table, the same value if found in the child table would also be updated. That's the meaning of cascade. One of the solution to avoid this violation, just a second. Yes. So if I go further over here, so cascade is one of the solution which we can add, or we can add something as set null. Now set null as an option is something which is not so much valid, not so much used, but it's one of the option which you can use to avoid this violation of the rule. How? If you go over here and imagine that I'm updating 102 to 109 and 102 is available into my child table. In order for doing this, I can set this value as null, which means the value at that particular position into the child table would be set as null. Now no one has said that foreign key cannot consist of null. My foreign key can be null, unique, or null, repeated, or can be not null. There is no such restriction that foreign key is supposed to be not null and unique. No. But if you see over here, this option is not a valid option or a good option. Why? Because it's just a foreign key to create relation. But for the actual table, it is acting as a primary key. Can primary key be null? No. So this option might not be a fruitful option over here. So set null as an option, which means if a value is updated in the parent table, if the value is available in the child table, at that position the value will be set as null. But if you can see in our case, primary key was the base table column for that particular value, and it cannot be setting it as null. And setting any value as null is not one of the good option which we have. So this is there, and the default option which is no action, or I can call it as restrict. Just a second. Or the default option which we have, which is no action, means nothing will happen, or one of the major one, that is restrict. Restrict means it will restrict the approach, which means it will give you error, and that's by default available, which means if you don't say that you want to cascade, if you don't say that you want to set null, then if the value which is updated in the parent table is available into the child table, that updation would be restricted. It will throw you an error that updation is not possible because of the referential integrity being maintained between both the tables. And this is how you can avoid the may cause violation rule when the update is happening from a parent table to a child table. So this was about the update, and then let's talk about something called as delete. Now what is the meaning of delete? Obviously, if I want to delete some row, delete some record, how it could be possibly there? Imagine that student 105 has cancelled the admission, has never took a course, and I just eliminate his record from my students table. Is it going to hamper anything for my child table? No, there is not going to be any hampering part over here. But if I go and eliminate 102's entry, obviously it is going to hamper. Why? Because 102 as a student is no longer part of my database, but she is doing a course, and that's not possible because the student is not there, the student entry is gone, then how come she is doing a course? So that is also going to cause a violation, which means if the information in the parent table is available and it's being deleted, which is also being part of child table, this is going to cause a violation over here for us. So this also, just a second, yeah. So this also is going to cause violation. So this is also going to be may cause violation. Now what can I do to avoid this? The same rules over here which are being implemented. That is cascade, set null, and no option. Now what is the meaning of cascade over here? Now cascade means if the student entry is eliminated from the parent table and the same student is available in the child table, it will also eliminate it at the same time. That is the meaning of cascade. Then set null, as you can see, that if the student entry is eliminated from the parent table and the same student is available in the child table, that value or that position will be set as null, which is not ideally good choice. And then I can have something called as no action and restrict. I'll show this with a practical example that how does cascade works and how does restrict works. We will be creating the database which we are creating as a data engineer for Imarticus, and I'll show you all those options over here. So when a referential integrity is maintained, in order to avoid this issues, this is how we can try to use more options into your referencing. So this was all about the parent table referencing, which is being there, that is a reference table. Now obviously I am going to insert data into my child table as well, because that also needs to be filled. So what kind of rules or what kind of limitations I can do set over there? So let me change the color over here, and obviously I will be inserting some data into my child table. So I go and I try to insert some data. Now what I'm inserting C2 over here, that is a course 2, and 102 which is there, I'm inserting 104. Is it possible for me to insert? Yes, C2 is my Python, so I've inserted that over here. Imagine that I insert C1 for 1110. and then I'm giving the course name as SQL. Do you think so? C1 will be allocated to a student ID named as 1110. Will it be? The answer is no. Why? Because there is a referential integrity, and when 1010 is being entered, it's not there into the student base. So how come that student is getting the course? First enroll and then the course would be allocated. That's what you know. That this is an issue which can be cause. So can n number of records be inserted into my child table? No. There is a referential integrity being maintained, which means only those rows will be entered which are a part of my parent table. N number of rows or any IDs cannot be inserted over here. So this is also going to may cause violation. And we will see all of them with a practical example for the same. So this is also may cause violations. And then let's try to update. Obviously, update if I am updating something over here, which means let's say if I am updating 104 to 105 and 105 as a student is not available into my table, obviously we have to do something. So this is not going to update. So 105 student entry, don't you think so? It will not be created. Cascade would not happen. So 105 only would be created. Rest all entries would be empty. You can do restrict. You can do restrict over there. That is when you try to update into the child table and it's there a part of my parent table. I can restrict that the update in the child table would not be possible. So this is also going to cause violation for us. So when you try to update the data based on the references, that is also going to cause violations. So may cause what? Violations. Violations over here. Just a second. Yeah. So that is one issue which you can see. And let's talk upon delete in terms of referencing table. Now the student has done with the course. The student has completed the course. Do you think so that course detail meets the requirement of that student? No. So 104 has done with the course. Is it a problem to eliminate? No. There is not going to be any problem if I delete n number of rows from the child table even though they are part of my parent table. So delete is not going to have any problem. You can delete all the rows or n number of rows from your child table. So no problem, I can say, just a second. Yes, so it will say no problem or no violation which is being caused. So no problem or no violations. Now this all the things which we have seen theoretically, let's try to understand things on a practical point of view as well, where you'll get to see how does a cascade work, what are the references which are applied, and how those restrict, no action and all those things will be actually taken care of into the relational databases to maintain the referential integrity over here. I hope you have understood the part about reference table and a referencing table and how a reference is being created between them. Let's see with a practical example by creating actually this references between the table of students and course, and let's see whatever we have discussed theoretically, is it practically implemented or not. So this was about a foreign key with respect to referenced and referencing table, and these are some issues which could be created when we try to insert data while maintaining the referential integrity, and there are certain solutions for them, that is cascade, set null, no action or restrict. So if you can see on my screen, when I talk about foreign key, so foreign key has 4 reference options. One is cascade, one is set null, one is no action, and then there is something called as restrict. So cascade, if a row from the parent table is deleted or updated, the values matching to the child table rows in the child table automatically gets delete or update, which means if you're deleting or updating the values from the parent table, if the matching row is found into the child table, it will also be deleted or updated. Then there is something called as set null. If the row from the parent table is deleted or updated and the same value available into the foreign key column, now it's in the foreign key, not in the entire table, only the foreign key column will be set as null. Now restrict, if a row from the parent table has matching row in the child table, MySQL is going to reject, which means that is not going to happen. No update, no delete is going to happen over here. So let us try and see how a course table is created, how a reference between both the table is created as we saw on the screen on the whiteboard. So here I am creating course table. So course table, I'm just giving a comment over here. So how do I create? If you can see on my screen, just a second. So I'll do create, as you know the syntax, create table. Create table what? I'm creating a table known as course. And in this course table, as you can see, this is how the syntax follows. Create table, table name. And you have to give a parenthesis where or a round bracket in order to add the names of the columns. What is the names of the columns which I have? The very first is course ID. And I'm going to give it as a varchar. You can give anything, so I'm giving it as varchar. Now you all know what is varchar. Varchar is a data into a string element where it will consist data of a variable character. I give it as 4. So 4 is the character, which means the maximum size it can consist of character is 4 over here, and I want it to be mandate. So I write it as not null, which means I want all the course IDs to be there whenever a new data is being inserted, comma. Now I'm creating an ID. Now remember, when you're creating references from a parent table to a child table, now my parent table is my students table, my child table is my course table, which means child table, that is a course table, is going to refer from my students table on the basis of what? IDs as a referencing column, as a relational part. And for that, in order to create that, you have to make sure, even though the column names are not same, but the data type is same. That is one of the mandate check which we have to do. The data type needs to be what? Same, even though the column names are not same. It doesn't matter that the column names are same. So I'll write int over here, and I will make it as a primary key. There is no such issue that a column which is acting as a foreign key cannot be a primary key. That foreign key relation is only for the references, nothing else. So primary key, and after that I give that column as a course name, and I give it as varchar, and I give it as character as 20, 10, whatever I want. So I'm giving it as 20. And I want it to be not null again, so I want this to be mandate over here. Now how can I create a foreign key? So foreign keys are not created in this manner, that primary key and just you write over here as foreign key. No, if you write in this particular manner, obviously it's not going to make any help or any issues or any reference or relation over here. The foreign key is created at the end. So here you can see after comma, I write something called as foreign key. So here you can see foreign key is being created. So there is an error. Now what is this error? You can see statement is incomplete, expecting an identifier. Now foreign key, you want to create foreign key which column or which part of your table. So which attribute you want to act as a foreign key. So I want ID to be acting as a foreign key. It is just for reference, not for a temporary purpose. The nature of ID is still a primary key. It's an integer, but just to create the relation or the referential integrity maintenance, this is acting as a foreign key. So ID over here, and then where it is going to refer. So this table is referencing, the references. What? Students table. Now you have to check the name. You can see the name of the table which I have is students. So students table, which column it is referring is student ID. As you know, this is a child table from where the foreign key is coming, and you have to give the references. So where it is referencing students tables, students ID. As you saw on the board, the same relation is being created over here. So as you can see, just a second. As you can see, this is how I created a relation. So this is a referencing table which is referring to a students table, and that is being maintained. So if I don't pass any restrictions or any rules, it is going to restrict all the update and delete part. But I am writing on delete, which means when data from a parent table is deleted, I want, if it is possibly available into the child table, that should also delete. So on delete cascade, and I write on update, I can write restrict. So I've given restrict means on delete it should cascade, means if it is deleted from the parent table, if it is also available in the child table, that should be deleted, and on update it should restrict. And this is where my query ends, and you can see there is a reference created, and I just have to do control enter, and you can see the row is being affected. If I go and refresh my table, go into the course 1, and here you can see a foreign key is created, and if I click on that, you can see foreign key, and it is targeting to what? The referencing to what? Student ID. On update it is going to restrict, and on delete it is going to cascade. And this is how, with respect to code, you can create a foreign key, and you can create the referential integrity between your two tables. So as you saw now, with respect to the theoretical aspect, that what is referential integrity, how a reference being created between the two tables with the code, as well as how the reference would be maintained. Definitely, when we proceed further, when we try to insert, update and delete into this particular data, we will be seeing that how these references are actually molding and actually helping us to store a relevant data, and the data redundancy issue which was there, which means the data discrepancy which was there earlier would be avoided by maintaining the referential integrity. So if I want to talk upon the primary key and foreign key which we studied over here, you can see primary key versus foreign key. Now this is one of the most important question asked, and this is one of the most important topic which people wants to know and wants to understand in detail, that why do we need a foreign key and why do we need a primary key. I hope I solved your questions. I hope I solved and gave answers for all of them, but I would like to show you the difference between both of them. So primary key, it must contain unique values. As you saw, that primary key is a combination of not null and unique, which means all the elements should be distinct from the another, which means each record entry should show different element or a different value. So it must contain unique, but it's not a case in foreign key. You can have duplicated entries as well. In the further part, we will be creating more tables, we will be creating more references, and in that I definitely show you that foreign key can contain duplicate entries for the same. Now, it cannot contain null values. Yes, it's sure that your primary key cannot contain a null value. Here, in foreign key, it can contain a null value. As you saw, one of the rule, one of the restriction, one of the references, that when the value is deleted from the parent table, if it is available into the child table, set it as null, which means it does accept null value into it. So there is no such restriction or there is no such rule that foreign key is going to be unique and not null. It can be unique and not null. It can be repeated and null as well. So it can contain null values. A database can have only one primary key, which means in your table you can have one primary key. And a database can have more than one foreign keys, which means in a table you can have multiple foreign keys as such. A primary key is used to identify, which means when I want to identify that each record is different or unique from the another one. In order to add that distinctiveness or the uniqueness, primary key is used, and it is used to make relation between the two tables. Foreign key is not just for a temporary purpose or not just for creating purpose. It is helping you to maintain the relation, the references between the two tables when the data is being entered, and it assures that a good set of data being entered without any discrepancies over here. So as you can see, this was a primary key and foreign key, and these are the two major keys which are asked the most when we talk upon the relational database management system, or we talk upon the relational databases. So I hope you understand what is a foreign key, what is a primary key, and how both of them can create relation with each other. In the further part, we are going to understand that how more relations would be created, how multiple foreign keys would be created, and how the data insertion or the referencing relations which we saw theoretically would be implemented practically, and how does cascade and all works. So I hope we are clear with this concept. So as we have discussed about primary key, foreign key, and what is referential integrity and why it is supposed to be maintained within a relational database management system. So according to me, being a data engineer, we were designing a database where multiple tables were created as a rough summary, and we were trying to create a relation so that this table is related to that particular table. As we now know what is a primary key and a foreign key, let's try to relate this table and let's try to replicate those same things practically, and let's understand how does the other commands are going to work for the same. So if I show you that this is a rough structure which we created initially, now let's try to create the relationships from scratch again. So let me erase this off. Just a second. Yes. Here. So these are the four structures or four tables which I would like to create in order to maintain the relations or in order to maintain a data for Imarticus. Now as said, Imarticus came to me and where they want to store the students' data into a relational database management system. So I, being a data engineer, I am designing a database for them. And I thought of that my data would not be stored in one table, it will be spread across in four tables. The very first is students, then there is course, then there is course info, and then there is course. So I've created those four tables, and let me create relationships between them over here. So if you can see here, the relationships or the references between the table in order to maintain the referential integrity. Now all of us knows that what is referential integrity and why it is important. So we need one primary key and one foreign key in order to create the same. So in the students table, we decided that my student ID is going to act as a primary key. In my course table over here, the student ID is again acting as a primary key, which means each student is getting a unique course. Which means each student is getting a course over here. And here you can see the course ID, course name, fees and description. So here the course ID which I would be creating further is a primary key over here. And in this course, the student ID is going to act as a primary key over here. Now, I am not thinking to add primary key over here. So let me release it off so far. So this is where in the students table, where the students base would be stored, such as an ID, name, age, and so on. In course table, the course details, which means which student has been allocated to what particular course would be stored. And then we have course info. That is the base course information, that what is the course name, what is the course title, what is the fee which the course has, and what kind of benefits this course do provide. So there is a description for the same. And then there is a scores table which will be related. So there are primary keys. Let's create a relation. Now first I am connecting a student's table with the course table, which means if the student is enrolled into the class, then or enrolled into the institute, then and only then he or she is able to be applicable for the course. So here there is a primary key and there is a primary key again. Now in order to create a relation, which column would be used? Student ID from the students table and ID from the course table. But I need a foreign key. As I said, primary key, which is a based key of one table, can act as a foreign key. now can behave like a foreign key over here. So ID is acting as a foreign key, and as said, foreign keys are not particularly unique and not null. It can be or it cannot be as well, and it is supposed to be multiple into a table. So here there is a primary key foreign key relation which we created, and let me relate this table. So now foreign key is helpful in maintaining referential integrity. So foreign key goes to refer the primary key, which is that the course table takes references, means refers to the students table in order to fill in the details, in order to maintain the referential integrity. So that is one relation which we create. Now I want to create relation between course and course info. Now course info has base course information. Let's say this institute is providing 5 courses over here. So C1, C2, C3, C4, C5. So each course information is different from the another. So there are 5 courses, and amongst these 5 courses only the data is going to be available into the course tables. So here this course ID, which is again going to be repeated, is going to act as a foreign key, which means the course numbers, the course IDs which will be used C1, C2, C3 are going to take references from the course table, course info table, which means if the courses are available, then and only then it will be applicable to the students in the course. So this is how we have created a relation. So one primary, one foreign key and one primary key. And then scores table. Now what is the scores table? In this scores table, primary key of course. Now I cannot relate scores table with the students table. Why? IDs are there, student ID is a match, but why I can't relate? Now not all students have enrolled for the course, so I cannot get scores for all of them. Definitely the students who are a part of course, they would be applicable to get scores. So here the foreign key is the student ID. Now this key will refer. Refer means this will relate. Relate to which table? Course table's ID. Why? Because if I want to fill in the scores, the student should be doing the course. That's what I want. So you can see there is one primary key and one foreign key relation. So this is a reference or the relational database which we had created so far, and let's try to replicate the same practically and see how those relations are working. Now I'll show that how foreign key could be added after all the tables are created. It's not necessary or mandatory that foreign key needs to be created when you create a table. It could be added after the creation of tables. So we will be seeing that aspect as well. So if you can see, this is the relation or this is the reference or this are the relational integrity which I need to maintain into the table, and the data filling or the data manipulations, that is insert, update and delete, which we will be doing in the later stage, would be on those 4 tables, and I'll show step by step that how does an organization or how does the data get stored into this kind of tables and how we should maintain the flow of data which is there. So this is how the reference is being created. Let's try to create it practically. So I'll go on my code file. This is where I created. Now I'll create a course info table. So here if you can see, create course info table. So I'll be creating that table over here, that is course info table. And let me do a full screen. Zoom in a bit. Now course info table. What should I write? Create table. Obviously you all must be knowing the syntax of creating a table. So create table. When I say create and a table, it is definitely going to create a table. I say course info. So course underscore info is what the table name is. And in this, I would like to check what are the requirements over here. So I have decided in the course table, there will be course ID, course name, fees, and the description which is there. So let me add in. Now course ID over here is going to be varchar. Now it depends on me that what I want to keep. But I'll try to match the course IDs which are available over here. Let's say again, I write 4. Let me see. So here you can see course ID varchar 4, and that's what the data type should match if the relation needs to be created. Why? Because as you can see, the course ID from the course info table and course ID from the course table are creating a relation. And this is my primary key. I'm not giving any auto increment element because auto increment is only in the integers, not into your varchar. So primary key, that is the first column which is created. I want the course name. Now course name, what is the course name which I require? So as per this course name, I can add anything. Let me add varchar as 30. And I want the course name to be mandatory, not null. And here if you can see, I can add fees, that how much is the fees being paid. I can add it as an integer, big int, small int, however I want. So I've added as an integer over here. And if you want a decimal to be added, so I can add decimal. Decimal is a data type which takes floating elements, floating values. So I can take, let's say, 8 values. Out of this 2 are decimal. I'll try to fill in and show you that how does the data gets filled over here. So I have written this. So fees that are in decimals which are there. Let me write this 10, 2. And obviously I want fields to be there, so not null. I cannot add unique because 2 of the courses can have same fees, so it's fine. And then I have description. And I give a data type as text. You all know that we have seen those data types when we understood that how does a create table happen, and in the create table the data types are must. That is that is SQL will ask you that what kind of data needs to be stored in what kind of columns. So here we have kept it. Here I have did a semicolon. If you can see carefully, there is no foreign key, primary key constraint, no foreign key and relation being created over here. The foreign key is into course table. That would be referencing to my course info table. But I cannot make the changes so far in the course table because it's already created. So here you can see I created a course info table. And I would like to create course table. So create course table. So let me see that what are the requisites which are there required. Student ID, module and the marks. So let me write create table. What is the table name? Course. And in this I want student ID. Student ID, it is supposed to be an integer. Yes, I have not null, which means I want the student ID to be there. I have not implemented unique. Why? Because one student can give one course or one mocks multiple number of times, and every time the scores are being populated and it is being stored into the database. So I cannot keep the student ID is going to be unique because one student can give 10 mocks or 10 particular marks could be given to each of the student. So here I have written not null. I have not even added unique over here. So course student ID, then what is there? What do we require? Module. Module, that which module the mocks are being conducted of or which module scores are being reflected over here. So this is varchar and the varchar would be 30. Let's say I can give a bigger module as well. And I give, let's say, not null. And here in this, after varchar in this, I'll give scores. Scores, which is an integer, or it could be decimal as well. So I've added it as integer, that it will be a fixed score or a finite score which is there. And Let me add like not null, and I am not adding unique because 2 or 3 students can have same score. So I've kept it as not null, and I've kept it as default as well. But let me try to modify this column ahead with the help of alter. So this is their scores in not null, which is being mentioned, and this is a table being created. I didn't create any foreign key primary key relation. Let us add it from scratch later when the table is pre-created, and if you want to relate the table with the another table, how you would be doing. So there are 4 tables created into my database by me, and these are the 4 tables where the information will be stored for the Imarticus students in order to maintain the databases. So we have created the tables so far, and now we will be proceeding further in understanding that how does an alter works. If you have not given the relationships earlier when the tables were created, how you can add it at the later end, and then we'll see that how does the insert and updation and deletion operations happen, and the rules which we understood with related to the reference table and the referencing table. Let's try to understand with a practical example that are they actually true or not. So this is how we have just created the tables. Now the structure is being created so far. Let's modify the structure with the help of the rest of the commands, and then let's proceed further with the next part. So, as we have briefly understood about the create statement with respect to creating a database as well as creating a table, now let's talk and understand something about alter. Now, what is an alter? Now, when I talk about alter as a statement, what does alter do? Now, many people think that alter is going to alter my data which is being stored into the values or the data which is being stored into the rows, but not as such. Alter is a part of DDL commands, and whenever I talk upon DDL commands, as said, they work on definition, that is a structure, that is a layout. So nothing with respect to the values would be taken into consideration, but yes, the data is going to make changes, or the model is going to make changes, or my SQL server is going to make changes. But what kind of changes are those? Those changes are structural changes. So let's understand alter module in detail with some practical examples with the database which we have created, and let's see that how does an alteration works. So when I talk upon alter as a command, it is one of the most essential command in the MySQL server, as it also helps us to maintain data integrity, which also manages the database schema according to the requirements. Wherever necessary structural changes are required, that could be easily done with the help of alter. Now, alter statement is used to change the structure of an existing table. Now, what kind of structural changes do you think so could be added? Is with respect to adding a new column, modifying the existing one, or making new necessary changes into the same. So it can also add, delete, modify, and drop columns, change the data type of a particular column, create indexes as such, or even add another primary key to a table. So those all things could be taken care of with the help of alter. However, alter offers significant flexibility, so we have to use it very wisely. That even if slight alterations are not happening or not giving us a proper result, that might hamper our result set. And alter is a part of DDL command, so definitely it's auto committed in nature. Now, what does the auto committed means? Which means that whatever changes we are doing, they are permanently there. We cannot undo or we cannot roll back the changes which were there earlier. So overall, alter is powerful tool for developers, as it plays a very critical role in maintaining the optimizing database systems. So where you can use alter, we can use modify the table structure with the help of alter table command, and there are certain breakdowns with certain examples as such. The very first is adding a new column. Now imagine a database is being created and certain columns were not being a part of the database or the tables which was being created, and definitely I need to add more columns, and at that time I can take a feature of adding a new column with respect to alter. So if there is a need to store additional information such as employee's phone number, we can use the alter command to add a new column instead of creating a new table. Using alter add multiple columns can also be added, which means with the help of alter, I can add multiple columns at once. Now, what is the meaning of altering syntax, adding a column? You can see there's a syntax available onto your screen, which we will be seeing later on with the help of a practical example. The alter table. Now remember, whenever you're using DDL commands, you have to mention that what is the changes which you are doing. Alter, you cannot say alter and the table name directly. You're altering a table, that is a database object. So you have to write alter table, table name, and then what is the functionality which you want to add. If you add a keyword known as add, which will help you to add a new column. So add column name, data type, and the constraints. It's as you can see, constraints are written in square bracket, which means they are not mandatory. And you can see a sample query which I have written, alter table employees, add column phone number with a varchar of 50. So that's what alter is. Similar to alter, it's not like always in order to add a new column. I can also modify the existing one. What does it mean? Imagine that a table is being given, and I gave the name of the column such as email ID. And in this email ID, I wanted to add a default, but I forgot to add a default. What I want to do is I want to maintain all the columns as it is, but I just want to change the data type or the constraints which were added, or to add a new constraint which were there. So modify means make changes. Using modify, we can change the data type. Now remember, you can only change the data type and the constraints. You cannot modify or you cannot change the name of the column. Here, modify will only take care of adding adding a new data type or adding a new constraints or modifying the existing ones, not modifying the column name. So if an example, we can use modify to change the length of the first name column from varchar 50 to varchar 100. Here you can see. So the syntax still remains the same. It's very similar to the add wala part. So alter table, table name, modify column name which is there, and whatever is the new modification which you want to add for the existing column which is there. So modify uses or works for an existing column. So query, alter table employees, modify column, first name, varchar 100, and I can give another constraint which is not null. Here you can see dropping a column. Imagine there are 10 to 50 columns there into my table, and not all of them are important. Certain of them could be created by mistake, or certain of them are not required to be there into the table, again capturing some space. So I want to drop certain columns. Now many people say that you have drop command separately. Then why you are using drop into alter? Now drop into alter will help me to drop a column. Now column is a part of structure and it cannot be directly dropped or eliminated with the help of drop statement. You have to take help of alter in order to drop a column. So for instance, if a column is no longer needed, it can be removed using drop. Syntax, if you can see, alter table, table name, and drop. If you write drop, it's fine. But if you mention drop column, it becomes more applicable. So drop column and the column name. So query, if you see, alter table employees, drop column and the birth date. So if I want to drop birth date as a column, I can easily drop it. So disadvantages of dropping a column. First is data loss. Obviously, it's a part of your DDL statement. So you cannot get back the data which has gone. So it loses the data, that is permanently removes all the columns in that, all the data in that particular column. Effect dependent objects. Obviously, if I have created a relation between two tables and if I'm dropping one column, definitely if it is related to some other table, it can affect the relation and that error could be seen. Rollback complication. Now, when you drop a particular column, you cannot undo, which means you cannot roll back as the statements are permanently stored. So that is one of the complications which drop column can face. Now, it comes to rename a column. Now, as we saw modify, in modify, we changed the data type and we were changing the column name, which were there. We were changing the data type and we were changing the column constraints, not the data type particularly or not the data name particularly. But what if I want to change the data name or the column name over here? So we can change the column name or rename the column which is there known as change column. So there is a constraint or there is a keyword known as change column, which will help me to change the name of the column entirely. Now this change will not only change your column name, but also changes the column definition. I'll show you with a practical example the same. So we can rename a column of a table by using the change column keyword with alter table. So syntax, alter table, table name, change column, the older column name to the new column definition which you want to add. And there is a sample query, that is city I want to change to location with certain data types. So these are the parts which we can use in terms of alter. So let's see that how all of them could be practically implemented. So if you go on the database, you all must be remembering this database which we created, the Imarticus one, where the references were created by us, where certain references are yet not created, that is the course and course info and scores and the course table. Let's try to create those references also with respect to alter, and let's try to see more changes with respect to alter as a statement. So alter to implement changes in the structural part of the database, which means it will help me to implement the changes to the structure of the database or the database object. So the very first thing which we are going to see is add. So what does it do? It adds a column and a constraint in a table. So it can add a column or it can add a constraint. Let's see both of them over here. Now, imagine that I have a students table. If you see, select star from students. That's a table which we have created. So if you can see, there is student ID, name, age, city, phone number and gender. What if I want to add? So let me write this in there, like adding a column. So what if I want to add a particular column named as address? So where should I add? So in order to add, I'll start with the syntax known as alter. Now I cannot say alter students, because if I do like this, it becomes practically wrong with respect to the definition. Here you can see students is not valid at this position. So alter table students. Maybe people will be thinking, okay, I have not completed the pattern, because of that there is an error. So if I write add, no need to mention column. It knows that when you are using add as a keyword, it is doing a column addition. If you want something extra, then you mention. But for a column, no need to mention column as such. So add what? Let me say that I want to add address as a column. Address, obviously I cannot add it directly like this. I have to mention the data type. As it's a fixed database schema, so it requires the data type to be mentioned. And I write address. Let's say the address needs to be varchar, and I give it as 100, which is there. So here you can see alter students, add address varchar. The syntax is complete, but there is still an error. Why? Because it's not accepting alter and the column name or the table name directly. You have to mention that which object are you altering. Alter table. And if you can see, once I put up the table, the error is gone. But when I remove the table, the error is still existing. So here if you do alter table, and it is going to run and execute my query, which is alter table students. And you can see it's affected. So if I see select star from table, there is address as a column added. But you can see all the columns which are being added are at the end. So when I run this query, you can see address is being added, but where does it looks like? It's there at the end, because I didn't mention the position where I want to add. But what if I will mention the position that I want to add after this or after that? For that, I'll be using second, that is alter adding a column after, let's say, city. So I want to add a column after city, which is there. So let's say I write alter table and then the student. So this syntax remains the same for all the altering commands. But if I write like this, it is going to make changes. And here if you can see alter table students, but what did I mention that what we have to do in terms of changes? No. So it is simply executing the code but doing nothing. So alter table, what I want to do is add. I know that when I write add, it is adding or talking about columns. So I want to add a column named as email. You all must be knowing emails are required for the students to be there. And I write it as varchar, with varchar as 100. And if the email is not there, I want to mention that default not available. That if the student didn't mention the email, instead of keeping and storing the result as blank, I can give a constraint, that is rule, that don't store it blank. Instead of blank, replace it with nothing called as not available. So which is there, but I want to add after what? City. Now remember, after adding this entire thing, if you run and execute, the column would be added, but definitely at the end. The email column would be created, but at the end. In order to SQL, I have to specify something called as after. Now what does after says? That I want to add this column, that is for sure, but after which column? So I have to add it after which? City column. So when I run and execute the code, and when I see now, you can see after city, there is email as a column generated. If I don't write the keyword known as after, it is going to be adding the column by default at the end. So this is how you can add a column at a specific position, which you can do. Now many people will ask, can I do it for before? No, because before as a keyword is not suitable in MySQL, but it's not like you cannot do it before, you can. Just that the keyword over here is not suitable. So here you can see it's not suitable. You expecting that it should end instead of writing what? Before. So before is not acceptable, but after you can definitely do into your SQL servers, MySQL servers particularly. So this is how we saw that how we can add a new column into your table. But what if I want to add a relation? That is adding a foreign key. Now one of the most important concept which people say that, ma'am, when I have created a table, let's say I've created a table earlier, but I didn't add a foreign key constraint, I didn't created a relation, I forgot to create a relation, how I can create? After that, should I delete the table? Should I drop the table and create it again? Should I eliminate all the information now which is stored and should I enter it again? No need. You have to just use alter in order to add the referential integrity which you forgot to add in the earlier part. So if you can see, we added a relation of course table referencing to students table on the basis of what? ID from the course and student ID from the students. Now let's say I want to create this relation where in the course table there is one more foreign key. As you can see, the course table is pre-created and there was one foreign key earlier. But if I want to add one more foreign key in order to create the referential integrity, could I be able to add? Yes, because a table can have multiple foreign keys. And that key is referencing to the course information, which means the courses which are available into the institute, it will first refer to that. And if the course name is not available, then it will not be able to allocating it to the students. So that is what the referential integrity part will come over here. But if you can see in the database which I have, the course table has only one foreign key. And this foreign key is targeting the students table on the basis of student ID. I didn't had another foreign key which targets to course info table. So I will be creating it one. So what I have to do is alter and I'll write table. Obviously, I'm going to alter a database object, so I'll mention alter table. So which table I have to mention is course. So if you can see, course table is being added. So alter table course, and then what I wanted to do is add. But when I just write add, it is thinking of to add a column. But do you think so I want to add a column? No. I want to add a constraint, and that constraint is nothing but foreign key. So I will mention something called as constraint. That add what? Add a constraint. Now which constraint do you think so is required? Can you see? Incomplete the statement. If I just write this and when I execute, it's showing me error. A statement is incomplete. It is expecting check, foreign key, primary key and unique as a constraint. So add constraint what? I want to add a foreign key. But before going to addition, you have to name that constraint. If you can see over here, we didn't give a name, but by default, the system has created a name. That is course 1 IBFK1. So here I can write any name. Any name to the foreign key relation could be given. Add constraint FK1. What I have to do? I have to add a foreign key. So in the course table, I want to add a foreign key, which is what? Course ID. So add a foreign key, course ID, which goes and refers. So references, what? It refers to which table? Course info. Which means if the course information is available, then and only then this course could be allocated to that particular individual. So course info, and which column from the course info? That is nothing but course ID. So this is how, and you can see the reference is being created. Now let me explain you this code again and understand it in detail. So if you can see the database which we created, in this there was only one foreign key and primary key relation created. The table of course was created but it consists of one foreign key. If I want to add another foreign key, I'm using the alter table command in order to something called as add. Now what does it do? If you can see, when I talk upon add, it is doing alter table course add. If I just mention add, it will think of it as a column, but it's a constraint. So add what? Constraint. Now the constraint will definitely have some name, because without name the constraints would not be called. There are certain constraints which consist of names. So here you can see foreign key 1. And what is this constraint? It's a foreign key. Now the name could be anything. I have given it FK1. If you want to write something else, you can write it something else. So foreign key, which column from the course table is acting as a foreign key? Course ID. So here you can see the course ID from this table refers to the ID to the course info table in order to give only those courses which are available into the institute. So if you can see, course ID is my foreign key, which references, which means it goes to the parent table. And what is my parent table over here? That is course info, which has course ID, which is used for relation. And this is how it is being created. If I go and execute it, it will be done. Now, what are the certain instances where this execution is not going to happen and how to avoid it? First of all, the two columns where the referential integrity is being created need to maintain a same data type. Now, what does it mean? Now, if you see course ID in the course table, what's the course ID? Varchar as 4. And if you see course ID in the course info table, let me show you. In the course info table, it's varchar 4. It doesn't matter that a constraint is given or not, but the data type should match over here. And you can see it is matching. And this is being created. If I refresh, you can see the FK1 which we created. So what does it do? FK1, course info, course ID and course ID. On update, I have not passed anything such as cascade, set null and so on. So what does it do? By default, on update restrict, on delete restrict, which means on update also it will restrict, it will throw out an error. On delete also it is going to restrict and throw out an error for us. So this is how a foreign key constraint could be added. Now I want to add one more foreign key which is there. That is the scores table is going to relate with the course table on the basis of student ID and ID. So let me create that relation. Now everyone must be understood that. So here I am adding a foreign key with requirements. Now how does it looks? That is, I want to add that cascade, set null and options. So here if you can see alter table, and which table I am going to alter is scores, because in that a foreign key is being created. So alter table which scores, and in this I want to add what? Add a constraint. Now I've added a constraint over here, and I'll give constraint name as SC1, that is score table 1. I can give any name, whichever I like of my choice. Just be careful with the spaces. So what I want foreign key to be created in my scores table, which would be nothing but the student ID. So student ID over here acts as a foreign key because it will go and refer to the course table for the student's marks. Let's say, and what does it do? It references course table, that is scores table, on behalf of what? On behalf of ID. So this is there. Now the major challenges come. That is, if I don't pass anything, it is going to restrict, which means whenever I try to do changes, whenever I try to do modification, that will not be acceptable. But if I want on delete cascade, on delete restrict. So on delete, which means if I want to delete anything, it will take it as cascade. And I can write on update, which is restrict. So I can choose which criteria, which condition I want, or which keyword is required, or which requirement is there. So I create this. This is being created. You can refresh it, and it's available into which table for me? The scores table. Just a second. Scores table. And in this, you can see a foreign key being created. And you can see SC_1. So this is how a foreign key is being created by some references such as on delete cascade and on delete restrict. So this was all about the add as an operation with respect to adding a new column into your table. So I hope you have understood about add. Now we will understand and think about, or we will talk about modify. So as you can see that we saw with add, now let's talk upon modify. Now what does modify do? It modifies the column definition, which means modify, change. Don't change the name but change the definition. So it modifies the column definition but doesn't change the column name. This is one thing which you all have to keep in mind, that modify as a keyword with alter is not going to change the column name. It is just going to make the changes with respect to column definition. Now let's see how. Imagine that I do select star from students as a table. This is the table. Now I can do describe in order to see that what all information is being provided or what all data types are being used. In this is an integer, varchar, age, city, email, phone number, gender, and then there is something called as address. And you can see, is there any default, not default, and not. So in the students table, I don't think so any column modifications are required. But let's say I go in select star from scores. I go over here, and in this you can see these are 3 columns, and I write describe scores. So I want to describe what scores. You can see student ID. It is acting as a primary key. Sorry, it is acting as a foreign key. So there is a keyword known as mul. Here, module varchar 30. Now, scores integer and then there is no one. Now, what if I want to change that? If the module is not given, then give a default value. If the scores are not given, then give a default value. So, here, let's try to understand that. So, if I write select, sorry, if I want to use modification, so modify, with respect to modifying the column by adding a constraint. Now you can add a constraint over here. You can do alter table. So you can do alter table, and in that alter table, which table you want to modify? Let's say I'll do scores. And then in the score, I will be doing modify. Modify what? What do you want to modify? I want to modify which column over here, which is nothing but module. So module as a column needs to be modified. That is, it needs to be changed with respect to what? With respect to not the name but the column definition. Let's say I give varchar as 50 and I write it as default. And if the module is not available for that particular students, then I want to write it as soft skills. Which means if none of the student has mentioned the modules, that means it's a soft skill module. So that's what I wanted to do. And if I do this, you can see all the commands which I'm executing are correctly affected, and that's why there is no error arising. If there is any error, I'll definitely try to solve it. So you can see this has been modified, and if I do describe scores as a table, and if you can see here, earlier there was no default value which was there. So module varchar yes, soft skill is there as a default. So this is how we have added a modified column or a modified column definition over here. Let me take one more example with respect to the students table itself. So in the students table, let's say I want to change the address ka data type from address varchar to text. So I'm modifying the existing data type, not the table name, not the column name, just the existing type of data. So modifying existing column definition. Just the definition needs to be modified. And how will I do it? For that, I'll do modify. Modify what? But I cannot write modify directly, so I have to mention what? Alter table. What is the table name? Known as scores. And in this, I'll do what? Modify. What I want to modify over here is nothing but the column named as address. Now, I will not give any of the previous available things. I'll give that modify address, and in this, I'll say that it needs what? A text to be added. And when I execute it, you can see, oh sorry, not in scores but in students. It's there, and I have modified it as text. So if you see describe students, you can see these modifications are happening. And in this, the data type is what? Text. And data type as text consists of null value. So null is yes. So here you can see this is how you modify. Now after modifying it, if I do it again, let's say if I add default, that is no address found. If I want to give default over here, if I execute this code, you can see in default, in your text as a data type, the default element is not particularly used so widely. So you have to change the data type to either to char or varchar in order to be beneficial with default as a data type. But here you can see with text, this is not a feasible approach. So I can change it to varchar and I can change it to varchar 200. So here you can see this would be changing and describe. Earlier it was text, but it has changed to varchar 200 null, yes. And here you can see no address found as a default, which means if any of the student failed to fill in the address details for the same, it's not going to give us error or blanks. It will mention that no address is being found over here. So this is how modify as a statement works. Now let's proceed further and let's understand how does change column works and what is the difference between modify and change column. As you can see that we have understood the modify statement, let's try to understand the change column statement and how it is different from the modify statement which is there. Now, as you can see, the describe of my table, let's say describe what students. The code is written, let me execute this one only. So in this describe student, let's say I want to change this column name from phone to contact, which means I want to change it from phone as such to contact. So if I want to change it from phone to contact, I have to change the column name. But the definition didn't require to be changed. But when I just want to change the column name only, it's not feasible approach into my SQL. I have to change the column name as well as the definition, which means I have to replace an entire column with the newer column as such. So here, it's not only the name which will be changed, the definition could also be changed. So how, let's see, the changing the column name happens. So third, which is nothing but change column, which is nothing but changing the column from phone to contact. That is, I want to change the column name from phone to contact. So how I will change, if you can see, alter table students. Alter table students. Now remember, modify can change the column definition and the constraints, but change column is definitely going to change your column name with respect to the column definitions. So when I do change column, you have to mention this. Change column how? You have to write the existing column name. What is the existing column name which I have is phone? And what is the new name which I want to give? That is what? Contact. So the existing column name is phone and the new column name which I want to provide is contact. And when I try to make the changes, I cannot do only this. Why? Because if you see there is an error, the statement is incomplete. It doesn't require only the name. It requires the data type as well. You cannot say that I'll just change the column name, but let it take the existing data type. That's not possible. You have to write the data type or the column definition which is there. So let's say I write it as begint. So here if you can see, when I execute it, it has been changed, and when I see the table, here you can see it was earlier phone, but it is now as contact. So these are the changes which we can see into our table. So all those changes are structural changes which are there. Column 4 which is there, and let's say I have my table known as select star from, let's say, from scores. So here you can see student ID, module, and the scores as a column being available. Now let's say I want to change the module to topic. So how will I change the name over here? I have to do alter table. I don't have to change definition. I want to change the name. But definitely if I want to change the name, I have to mention the previous name and a new name with a new column definition. So alter table. What is the table name? Scores. Where I will write change column, which is there, and change column to what? First, I have to write the existing column name, which is module, and then I have to change it to topic or concept or whatever it is. So, topic, and then I have to mention the data type. Let's say I'll write varchar as 50, and I will give a default. Now, if the value is missing into that column, don't keep it missing. I want the default to be there as soft skills. If you remember, we have added the same over here. So soft skills we saw, and when we execute, it is done. So if you see the scores table, instead of module, now it has something called as topic. So this is how change column works. Now many people say that modify and change column are the same commands which we can use in alter. No, both are the two different commands, both are doing two different operations. So when I talk upon modify, if you can see, modify is modifying the existing column definition, but doesn't change the column name. Whereas change column, it doesn't modify the definition only, but it changes the name of the column, which means it will try to replace an entire column with something called as a new column or a new attribute with respect to its name, with respect to its column definition. Why column definition becomes mandatory? Let's say for an example, there was email as a column and email was varchar. You want to change from email to phone number. Obviously, email being varchar and phone number being an integer. You cannot say that change email to phone. The data type might cause discrepancy, and that's the reason why they don't only require the name change but also require the column definition change. So here you can see changes the column entirely, that is column name as well as its definition would be changed. So this was the difference between modify and change column for the same. So let's say we have seen a lot of them. What if someone says that I want to drop a column, which means the column is not that important into my data set. So dropping a column. Imagine that I have that student tables, select star from students. And I know that student ID is important, very important, because there is a referential integrity. Name of the student, yes, it's important when I want to find the details. Age, yes. City, yes. Email, yes. Contact, yes. Gender and address, somewhat I'm dicey. But address, I definitely don't want it. I don't want address to be there stored into my table, because every time I try to insert, it will ask me for address. Yeah, definitely, I can keep it as unique, or I can keep it as empty without any constraint. So it can accept null, but I don't want that column to be unnecessarily there into my table. So if any column needs to be dropped, you can use alter statement for the same, which means eliminating a column. Now, many people say that when you're trying to eliminate a column or remove a column or get rid of that column from your existing table, you will use drop. So, here you cannot write drop column. You cannot write drop column students dot address. This is one of the wrong criteria which is being mentioned over here. And many people, when it is asked into interview, can you try and show me how does a column would be dropped from a table, do this approach, and that's when they go wrong. Their basics are not clear. What does it say? That a structural changes are required. The structural alterations are required. So here there is an alteration happening. That is, one part of the structure is being altered, it's being removed, it's being eliminated. And for that, you cannot use a direct statement of drop. You can see drop is not valid at this position. Expecting, it is expecting alter to be there. You can see alter, analyze, and something it is expecting before the statement is being written. So this is the wrong way to do it. So what I will do is alter table, and what is the table name? Students. So you have to alter it with this particular part. Alter table students, and what you have to do, drop. So if you just mention drop, it will understand that the column needs to be dropped. So drop address. No need to give any column definition. Why? Because dropping, it is trying to eliminate all of them over here. So drop address, it can directly drop address as a column. So when you see the table, you can see address as a column is not there. If I try to execute this code again, it will throw me an error. Cannot drop because it's not there. So can drop address, check for the column or the key exist. This column doesn't exist into my table, and definitely I cannot drop it off. So once it is gone, it's gone. You cannot run this statement a number of times. This is what I wanted to show. So if you want to drop a column, so you'll mention drop column. If you want to drop a constraint which you created, let's say FK1 which we created, so you will write drop constraint. So both the things, it can drop a column, it can drop a constraint with the help of something called as alter. So this was dropping a particular column or the drop keyword into your alter. So it's used to remove the column from the table. And then comes something called as rename. Renaming the table. So it is trying to rename the table. Now, here in my tables, there is referential integrity being maintained, which means one table is related to another table. So there are some or the other relations created between the tables. So when I try to rename a table name, it will cause me errors. Why? Because that table is being referenced somewhere, so that relation would be hampered. So if the relations are not there, and if I want to change the table name, which is there, if you can see in my Imarticus database, we have one table. We have one table which is there, which is without hassle. So in this, we have one table which was created without hassle. That is, I took it somewhere from the CSV file and I loaded it over here. So it is a table which is created without hassle, and I want to change the name. Now it is having a name of advertising, but I want to mention that advertising details or advertisement, or let's say marketing, something like that, or sales, something like that. I want to change the name. I don't want the advertising as a name to be there into my table. So how will I change the name of the table? That is rename. So if I first show you, select star from which table? Advertising. And if I execute, you can see these are the columns which are there. Now let's say I don't want this, my unknown column. I don't want this column. So what I will do is alter table. Alter table what? Alter table advertising. And my unknown column, which means if the column name is blank, this column name would be given. So I want drop column. So I can write drop column. What? My unknown column. So if it tries to drop, you can see in the advertising table, it has been eliminated. So that column is gone. Now what I want to do is I want to rename. So this is a data which is being stored in advertisement table, and I want to rename. So in order to rename, what I can do is alter table, and table name is advertising. Rename, which means I have to rename. Rename to, which means rename it to what? So I will write rename to what? if you can see, it will ask me, okay, what you want to rename, expecting a new table name. You can see statement is incomplete. It is expecting a new table name to be there. So what is a new table name which I want? Advertise. So advertisement is a name which I want to give to this table, not advertising. So here, if you can see, I just have to refresh and you can see from advertising, it has changed to advertisement. So if I do select star from the previous name, which was advertising, if I execute this code, it is throwing me an error. Table Imarticus database dot advertising doesn't exist. Why? Because this table name has completely changed. So if I write select star from advertisement, the new table name, you can see this is an information which is being shown. So in order to rename the table, you can use the rename command over here. So we saw that how does alter will help you to make the alterations with respect to the structure. Now, what kind of alterations you can do with respect to your table which you have created? It could be adding a column, it could be modifying the existing column without changing the column name, just changing the column definition and the constraints. Then we saw how do we change a column entirely. Now, what is the meaning of entirely? Entirely means the column name as well as its definition. Then we saw that how do we drop a column, which means if a column is available into my table and I don't want that column, I want it to be eliminated from my table, then I can use something called as drop column with alter. And if I want to change the name of the table with some new name from the existing name, I can use something called as rename to with the help of alter in order to make those changes. So this is how alter as a statement works. Now it's not that only alteration with respect to a table is being possible. You can alter the other database objects as well. But as we were seeing the DDL statements, we saw that how does an alter statement works in terms of altering the structure for a table which is being created. So that's all with respect to alter. I hope you understood the same. Hello all. Now today we are going to study some new topic related to SQL. As we have studied a lot of topics of SQL, right from creating a table to querying the table or getting the data as per the requirement with the help of clauses. Now what are we going to study next? The next topic which we are going to study is nothing but joins. But what are those joins? Why do we use joins and why joins are so popular in use when it comes to SQL query? Let's try to understand the same. Now, when I talk upon joins, what do you understand join by an English term? So, join means joining something. What is the meaning of joining? Obviously, connecting something over here. So, what are we going to connect over here? We are going to connect data. But data from where? My data is stored in multiple tables. As you have seen earlier that it's not necessary that I store all the data in one table. I can store data in multiple tables. But what if I want to get all the tables information in one query? What could be the possible scenario? At what instances we can use joins? Let's try to understand the same. So before explaining you the concept into very detail into its technicality, let me also ask you some question. Now this question will purely be dependent on how joins are actually useful and why do we use joins in the industry. So if you can see on my screen, I have a question for you all. Now what's the question? The question is extract the order details of the customer. Now what is the question which is being asked over here? That is, I need to extract the order details of the customer. On the basis of customer name, definitely I want to know the name of the customer, the quantity they have ordered and the price of each quantity which they have ordered. So if you just understand the question and read out the question over here, extract the order details. Definitely I need to get the order details of the data which I have. So for that, don't you think so? I have an order details table over here. As you can see on the screen, there is an order details table which shows me data related to the orders placed by the customer. But it's not only the order details which are being asked, it is also asking the name of the customer as per the question. So, on the basis of customer name, quantity and price each. Now, the data which I require into the output of the query is not possibly available in one table. How? Let me show you over here. So, if you can see, this is a table and this is my what table? A customers table for me. And this is nothing but my orders table for me. Now, there are many customers which have placed the order. Imagine that this is the smallest representation of an Amazon database. You all must be a customer for Amazon database. Let's say today I go into Amazon, I log into the account and I have created my customer detail, my customer ID. Definitely, my customer entry would be a unique entity for the Amazon data into the customers table. But me as a customer, don't you think so I can place n number of orders which are there? The answer is yes, I can do place n number of orders. But not all customers are going to place the orders. If you know the simplistic logic over here, that customers could be there, but the orders would be only placed by those customers who are part of the customer database, which means who are the customers of Amazon can only place the order over here. If you're not a customer, you must be remembering that they will ask you to sign in before placing the order. Why? Because they want your customer detail to be tracked. So similarly, this is a small representation of an e-commerce platform where they have customers and there are some orders placed by them. I want to know in the outcome, I wanted to show to the client in the outcome that this many customers have placed the order, or this many customers from whichever customers you have into the database have placed the order, so that the client will understand, okay, how many customers are actually interested to place order, how many orders were placed in a duration of month, year and so on. But let's not go into the complexity over here. We just have a simple question to solve, that I want to know which customers have placed order. So if I go by the question, if I just do select star from customer, you know the query, that select star from customer will try to select all the data from the customers table. So if it is selecting all the data from customer table, do you think so it's a valid answer for my question which is being asked over here? The answer would be no, right? Why? Because not every customer who are part of the Amazon database or in the e-commerce database is going to place the order. Imagine there are such customers who just create an account but never placed an order. Should I say that this many customers have placed the order over here? And can I take those names also who have not placed any order in that particular e-commerce database? The answer is no. So what I can do is I can go and see another table which makes relatability with the customers table in order to placement of order. Now what is a table? I have orders table. So if I do select star from orders, does it solve my question? Yeah, somewhat. It does solve my question. It gives me the answer, yes, this many customers have placed the order. But if you can read out the question which I have given over here, you can understand it more detailedly, that on the basis of customer name. But do I have customer name over here into the orders table? The answer is no. I have ID of the customer, I have order ID, I have quantity ordered by the same, and I have price of each element which was there. But I don't have the name of the customer which has placed the order. I just have an ID. So what should I do? My question is asking me to extract some details which is not possibly available into one table. It is spread out into multiple tables. So when I have data spread across multiple tables and I want to bring them together in order to show into one query, I'll use a concept known as joins. So joins are used to combine. As I said, joins is an English term which helps me, which is the meaning of combination, or I can say as connecting. So over here, what it is doing, if I write a question that what are joins? Just a second, yeah. So here if you can see, what are joins? So what are joins over here? joins are used to combine data. So as an English name over here for joins, let me make it a little bold so it looks better. Yeah. So if you can say joins are used to combine. The simple meaning or the English meaning of joins is combination, combining. So joins are used to combine, definitely yes. Now many people will have a myth that we are only going to combine two tables. The answer is no. Minimum to minimum it requires two tables, but you can combine as many tables as you want. So joins are used to combine two or more than two tables. So whenever a question is asked to you in an interview, what are joins? First, explain the meaning of joins, and in that explanation, you should always mention that joins are used to combine two or more than two tables. So joins are used to combine two or more than two tables. Two or more than two tables based on a common field. What does it mean? Don't you think so? When I'm combining two tables, I'm not randomly combining it, right? I will combine only those entries which are matching into the another, or there is something in common with respect to combination. So if you see in the question, do I need all customers detail? No. I need only those customers which have placed the order. So how will I get to know there is a common field between them? What is a common field? The common field over here acts as ID. If you can see, the ID in customers table and the ID in orders table can use to combine or to connect the two tables together. So, joins are used to combine two or more tables, but there is one requirement that they require a common field to connect. So, joins are used to combine two or more tables based on a common field between them. So we are going to use a common field between them. So these are joins. This is the definition for what is joins. So I hope you understood what is join over here. But let's try to understand the nature or why joins are used. If you have seen in the example, the answer is very clear. Imagine your data which you wanted to fetch. Imagine the result of the query which you require is not available in one table. As per the question which I have given to you earlier, I want the details of the customer, their name, orders, quantity ordered as well as price each for those customers who have placed the orders. But the question over here is my data or the query result which I require is not available in one table. It's available in more than one table. So when I want the result of the query which is available in more than one table, I need to use a concept known as joins. So there is also one of the question which is asked many a times into interview, that why do we use joins? The usage of joins is when we want to get a query which is not available in one table, which is spread across multiple tables. So in order to get the result of the query from multiple tables, we use a concept known as joins. So this is why we use joins. So I hope we are clear with the theoretical explanation of what are joins, why do we use joins over here. Let's try to understand the syntax, that how do we write joins over here, or what is a way of joining two tables over here. So as you know, why joins are used? Joins are used to get data from multiple tables. Now, let me also show you the syntax for the same, that what will be the syntax of writing joins. Now, what is the meaning of syntax? A general representation or a writing pattern of the joins. So, what do? We write select. You all know that we are going to query the data. What is the meaning of query? Ask the data from the database. In order to ask, the very common statement we use especially is, in order to extract the data, is nothing but select. So your query is going to start with select. So we have written select. Now you will write the column list, whatever column list you want. Now what is the meaning of column list? column 1, column 2, column 3, column 4, column 5, and so on. It depends on you that what columns you wanted to show into the outcome. Then from where do we want? Obviously, if the select is coming, select cannot be individually written. It will definitely ask you from. That you're selecting columns, fine, but from where are you selecting the same? So here we will write a table name. But in joins, as I said, minimum to minimum you require 2 tables, and maximum of the time you can use n number of tables over here. So minimum to minimum 2. So how can I write only 1 table? So I'll name it as table 1. And what type of join do I require? So I'll write a space that whatever type of join I require, I'll mention the same over here. I want inner, so I'll write inner. I want left, so I'll write left. I want right, so I'll write right. So I will mention the type of join which I want. Then I'll write table 2. I can write this, or else I can write dash, and definitely I'll write a keyword known as join so that you understand that this is mentioning the type of join which you use. And I'll write something as table 2. So table 2 is written over here, that I will take the table 2 over here. And definitely, as I said, I'm going to combine 2 or more tables. But don't you think so? There will be some common field which is required between them. So I'm combining table 1. I'm combining table 2 on the basis of what? So there come a word known as on. On means on what basis or on what commonality I'm combining the 2 tables or the considerate tables over here. So I'll write on, and here comes the joining condition. Now what is the joining condition? Which column from table 1 I do require over here? So table 1 dot column name is equals to table 2. So which column from table 2 will be considered over here? So that will be checked over here. So something from table 1 and something from table 2 you are going to consider over here in order to combine the same. So this is what the syntax of join is. Now many people will still say, we have studied entity relationship, we have studied referential integrity, we have studied foreign key, primary key. Is foreign key, primary key and joins the same? The answer is no. Why it is not same? If you remember the foreign key and primary key concept which we have said. Now what is a primary key? Primary key adds uniqueness to a table. It is a column which is not null and unique. So what is a primary key over here? In the customers table, definitely I have a primary key known as what? ID. So here my ID acts as a primary key. Definitely each customer is going to get a unique ID over here. So primary key is my customers table ID. Now what's a foreign key over here? In the next table, orders table, can I make ID as a primary key? No. A customer can place n number of orders. Definitely an order ID can act as a primary key, but I'm not focused upon creating a primary key over here. I'm focused upon creating a foreign key which takes reference from the customers table. So I have created a foreign key over here, and my foreign key is what? This ID. So primary key and foreign key is being created. Should I create a referential integrity over here? The answer is yes. I'll create a referential integrity. What is the meaning of referential integrity? When a table is referred from another table, the values will be matched. And if the reference is not matched, the errors will be thrown in the outcome. That's what we have studied in the primary key and foreign key relationship. So that's what we are going to see over here. So if I go and create a reference over here that foreign key is taking reference from the customers table. Foreign key as an ID is taking reference, this is taking reference from the customers table ID, which means orders can only be placed by those customers who are actually an enrolled customers into the customers database. which means if the customer has created that account, then and only then he or she can place an order. If it is not there, the orders would not be placed. And that is what a relationship which I have created. But is it similar to joins? No. It is just trying to say, it is just trying to refer each table with another table in order to maintain the integrity. When I create a referential integrity, that does not mean that I am joining the tables. I am just connecting the reference from each table to another table over here. So joins and referential integrity are two different concepts. Yes, definitely, primary key and foreign key of the tables can be used as a common field or as a joining condition between the two tables, but it's not always true. There are certain instances where there is no primary key, where there is no foreign key, but a common field between them that could also be used to join or to combine the data. So it's not necessary your joining condition or the common column between the two tables is obviously going to be a primary key and a foreign key relationship. Sometimes it could be, but sometimes it is not there and it's still fine. That's what. Now let's try to understand over here what are the various types of joins, and let's see what will be the answer for the question which I am asking to you over here. So if I go and tell you the types of joins which are possibly available, which we are going to study. So types of joins. So what are the various types of joins which we have? The very first type of join is nothing but inner join. One of the most popular join into the field of study of joins. And if you write just joins without mentioning what type of join which you are doing over here, without mentioning inner, outer, left, right as a keyword, when you just mention join, by default it acts like an inner join over here. So inner join, what is inner join? We will study eventually over here. So inner joins, we have the next type of join which we have is left join. So definitely you are considering minimum to minimum one table to minimum to minimum two table over here. So when you're considering two tables, there will obviously be something called as left table, there will be something called as right table. So when it is taking data from the left table, mostly it is called as left join. And the third one which we have is nothing but right join. As I said, we have left table, right table. So there is also a data considering more from the right table. So it has right join. The third one over here. Now let's say after that we have something called as full join. Now what is the meaning of full join? Full join means a data is considered from all the tables together. So we have full join. It is also known as outer join. Many people call it as outer join. Many people also call it as full outer join. So the meaning and the use case is same, but it is termed in a different way. So we have full outer join. The fourth one over here, which we have, sorry, this is the fourth one. The fifth one over here, which we have, is nothing but natural join. Now, natural join was also used many a times earlier, but there are certain instances that natural join is not continued now, but we do have a concept of natural join because it has some restriction, it has some limitations which are supposed to be met when we are doing a natural join. So there is something called as natural join. There is something called as cross join. So there is something called as cross join, and there is also something called as self join. Now self join is slightly different from what joins which we have studied so far, but eventually when we try to study this concept ahead one by one, you will get to know what is the meaning of each type of join over here. So you can see these are the various types of joins available at our end. But let's try to solve the question which was coming over here to us. Now, extract the order details of the customer on the basis of the customer name, quantity ordered, price each, and so on. So let's see the query which will solve the answer for the same. So definitely I will write select over here, because I need to select certain data in order to query my result set. I'm not writing anything over here that what I want into the outcome. I'll simply mention star. What does star over here means? Star means all the columns I want to consider over here. So select star from. From where do you think so I want to select this? From table 1 and table 2. So let's say I'm considering from table 1. What is my table 1 over here? The table 1 over here I'm considering is customers. So you know the syntax, I've written table 1. So I'll write it as customers. Usually the table 1 or the first table which we consider over here is considered as the left table. So this is known as the left table over here, but I'll not write it so far because we don't need a concept of left and right over here. So from customers, I don't mention a type of join, I'll just write join over here. I'll just mention join over here. And I'll write something called as orders. So customers table was my left table, orders is my table 2, that becomes eventually my right table. And what is the joining condition? If I write this, on what basis do you think so I should join both the tables? What is the common field between them? Don't you think so? It's ID from the customer table and ID from the orders table over here. So I'll write on, and I'll mention customers dot ID is equals to dot, means from customers I'm taking ID, and orders dot ID. So from orders table I'm considering what? I'm considering an ID. So what is happening over here? It goes to the customers table and orders table. When I say joins, the parser understands it as an inner join. So when I say joins, parser means the fetcher or the query extractor, it understands it as inner join. It understands it as inner join. Now what is the meaning of inner join? It is just taking common between both of them. So what is happening over here? Select star from customers, join, orders, on, customer ID, this. So it goes to IDs for both the tables and it will find common. When I am writing the type of join plays an important role in order to show that what kind of result set will be shown in the outcome. So when I write this 101 is available over here, is 101 available over here? No. So this will not be considered as result set. 101 as an ID has not placed any order. 102, do you think so 102 is there? Yes, but how many times it's there? Twice. So two results would be shown over here. 102, 102. Then 103, do you think so 103 is there? Yes, again twice. So 103 as a customer has also placed an order. 104, do you think so 104 is there? The answer is no. 105, do you think so 105 is there? Yes, so 105 will be there. How many times? Once. And do you think so 106 is there? No, 106 is not there. So it will not show the answer for the same. So what is happening over here for us is, it is going to consider only those orders which are matching from the common field. That's an inner join for us. And by default, it is inner join. So if I try to make the query more simplified, what it wants, I want the customer name. So what do I require? I require name. What do I require? I require quantity. And what do I require again is I require the price. So it is going to show me only those results which I write into the select statements. So here if you can see what will be the answer for my question, let me write down the output over here to you. So let's see What will be the result set which we are going to get from the query which we have written? What we have written? We have written name, price, quantity and price. So these are the three columns which I would be getting over here. That is nothing but name, quantity, and the third thing which we are going to get is price. So what is a name? Obviously 101 is not found a match. So Raj's customer IDs or customer details would not be given over here. 102 and 102 is found over here and it is found twice. So name of Raj is going to come twice. So Raj and Raj over here. Quantity. What is the quantity ordered at the first order which was placed? 2 and which was having a price of 400. So 2 and then 400. So Raj again, if you say 2 and 350. So these are the two entries which are being matched over here from table 1 and table 2. Here 103. Do you think so 103 has placed in order? Yes, 103 has placed in order. So Eric's detail will come over here. So let's say Eric. First time Eric has ordered how many quantities? 3. I guess this is wrong. Raj 102 has ordered 10 quantities, 4 quantities. So yeah, just a second. Yeah. So Eric's 103. 103 has ordered first is 3 quantities. Each price of each is 380. Now Eric has ordered again. So Eric's details is there. And what is there? Eric's 103 have ordered 5 quantity of 700. So 5 quantity of how much? 700. So 104. Do you think so 104 as a customer has placed any order? No. 105 as a customer has placed any order? Yes. So it's Pranav. So Pranav is being there. So Pranav's orders are being placed. Pranav has placed what this? How many quantities are ordered by him? 10. And what is the price of the quantities over here, which is each orders is nothing but 1000. So this is the result which I am going to get, and this is the answer which was expected by me. So this is how the join has worked over here. So when I write simply joins, it is going to do inner join. We will understand inner join in more detail over here, but this is how the query of joins is going to use, and the result for the joins would be given to us in the outcome. So this was just a basic introduction about joins. We will eventually study about each type of join in detail. So what we have seen into the theoretical part, let's try to see practically with the data which is very similar to what I have brought into concept over here. So if you can see in the screen, joins are used to combine data from 2 or more than 2 tables based on a common field between them. Why do we use joins? The data is required for the result set can be available in more than one table. So in order to retrieve the data which is available possibly not in one table but more than one table, we will require a concept known as joins. And there are various types of joins which I have mentioned. There is an inner join, left join, right join, full join, and so on. So by default it has happened inner join for us. So here if you can see, I have created a very simple and small data over here where I have created a platform known as e-commerce. If you can see, the database is being created by me. I have created a small customers table which has certain details such as ID, name, city and address. I have created an orders table which have order ID, quantity ordered, price each, and the product ordered by the same. There are products table which I have written. So I have also entered the data into customers and each table which is mentioned to you. So if you can see, this many customers are there into the e-commerce platform who have enrolled into the e-commerce platform. This many orders have been placed so far. And these are the products which we have. These are the products which are being ordered by those customers. Now, as per the question which was written to you on board, what did I mention? Find the details of those customers who have placed order. Return customer name, customer ID, quantity ordered, and price each. Let's try to see. Now, you know that the data is not going to be available in one table for us. So if I see select star from customers, it is showing details of the customers table for me. But it is not showing anything that this customer has placed an order or not, because this is just the customer registration into the e-commerce platform. I wanted to know that which customers have placed orders. So select star from what orders. So if I do this, yes, I get details, but I don't get the customer name who has placed the order or the customer entire detail. I just get those customer IDs which have placed the order. So definitely, in order to solve this question, I need to combine the two tables. First is customers and then there is orders. So in order to combine both the tables and generate a one result set from both of them, I will require something called as joins. So how do I join over here? So I'll write select star. I'm not mentioning anything so far. Always write star, first combine and then select what columns you want. Select star from. From where are we selecting? From the customers table. So we have customers table as my table 1. And I don't mention what type of join. I'll just write the query which I have written on the theoretical part, on the pen and paper part. So I'll write join. I'll explain more about the type of join, so don't worry about the same. So I'll write orders over here, and what is a common column between them? If I see in the customers table, there is ID, and if I see in the orders table, there is something called as ID, which is matching. Now, it doesn't mean the column name should be matched. The data type and the data element should be matched. So, common names can be different. The column names can be different. It is not going to be the same. So, don't keep that the column names are going to be same. In my data, the column names are same. So, here if you can see order ID, which is there, I have a joining condition on. So, I'm going to join on the basis of customers dot. When I say dot, so from the customers, I'm taking ID as a column, is equals to from orders, I'm going to take what? ID as a column. So this is what is being considered over here from my end. I'll take this and I'll run the query. You can see both the tables have been combined, and as I said, when I just mentioned join, parser understands inner join and it takes only common elements between the matching fields. That is a matching elements between both of them. So here I have done this, and I will mention the column names which I do require. I require customer name. I do require city. Sorry, not city. I require customer ID. So I require ID. I've written this. I require quantity. And I require the price each. Now, when I run this query, you can see it is coming an error. It is showing an error. Common ID. Column ID in the field is ambiguous. What is the meaning of ambiguous over here? That is, when I'm combining two tables, the ID as a column is available more than once. Definitely, in the customers table also we have ID. In the orders table also we have ID. So when it is mentioning that it is going to show ID over here, ID from what table? Do you want it from customers? Do you want it from orders? That is not specifically mentioned over here. So what I will do, I want this ID from what table? Customers. So I'll write customers dot ID. And when I run this, when I execute this, you can see the answer for my question is being shown over here. So the customers who have ordered multiple number of times, you can see those as well. Sam, Rashi. You can see Riya, Pranav, Rishabh. So this is the outcome for my query, and this is how joins are going to work. Let's try to understand more about the inner join, left join, and the other types of joins which are possibly available to us. So, as you guys have seen in the earlier part, that I discussed something about the inner join. That when you don't mention the type of join which you want to consider or which you want to combine the data into, it will by default do an inner join for us. But what is this inner join? Why do we use an inner join? And how the inner join is actually useful for us at many instances. Let's try to understand the definition of inner join over here. So when I talked upon the concept or the question which I needed to solve over here, the answer was possibly available with the help of inner join. Why it was available with the help of inner join? That is, I want only those customer names who have placed the order. Do I need all customers' name over here? The answer is no. I don't need all customers' name. If you see the output which was given earlier, it was only showing those names which are matching into the orders table, such as Ria. I guess the answer is, just a second, 102. We did some mistake in the earlier part, that it was not Raj, it was Ria. Yeah, there is some mistake from my end. So here 102 was the matching element and it is showing Ria for us, and it is showing Ria for us. So if you see, there is a matching element 102, 102 is found. So Ria is found. Ria is a customer who has placed an order. Eric is a customer who has placed an order, and Pranav is a customer who has placed an order. So only those details are being given to us in the outcome. But do you think so Raj has placed any order? No. So how will I require Raj data into the outcome? No, the question was expecting only me to show those customers which has placed an order. So the idea behind this type of join is I want to combine the tables, that is for sure. But with respect to combination, what I want, when I combine the tables with respect to each other, the matching records from the common field should be combined. So on that basis, the combination needs to be there. So that's what an inner join over here. So let us try to understand theoretically that what is an inner join, what is the concept behind inner join, and how to write an inner join into the query. So as I discussed that we are going to discuss and talk upon something called as inner join. So what is an inner join? Inner join is a join which combines the data based on a condition. So it combines data based on the satisfied condition. So it is not going to combine any random data over here. It is going to combine the data which is satisfying the condition. Now what is an ideal condition which I require over here? That it combines the data based on the matching records between the common columns. So it combines the data based on, so it is going to combine the data based on the matching records. So the records over here, the values over here are going to match. So based on the matching records, just a second, matching records between the common fields or columns between the table, common fields or columns. So it is not going to combine all the data or any random data. If I take table 1 and if I take table 2 and there is some match found between both the tables, if the matching value is found in table 1 as well as table 2, inner join is going to combine the data for us. The query or the syntax for the inner join is still the same. There is no such difference over here. So when I try to write the syntax over here, it is going to take for me, that is select the column list which I want over here from the table 1, that is going to be as intact as possible. So table 1. What type of join? In this dash or in the space, I'll mention now what type of join over here. That is nothing but inner join. So I'll mention inner join and that is going to happen in table 2. So inner join table 2 and definitely a joining condition. That will give us a satisfactory condition which I require. That is table 1 dot column name is equals to table 2 dot column name. So This is how the syntax for the inner join is going to work, and it is only going to take the matching records from the common column which I have selected from table 1 and from table 2. That is my satisfactory condition over here. If I show you with an example, imagine that I have a table named as students and I have a table named as courses. I want to know which students are doing what course. Obviously, n number of students are there, so I have ID and I have name over here. I have ID and I have course over here. So as you know, not all students are going to do all courses. So there will be certain courses. So let's say I have student ID S1, S2, S3 and S4. So there are 4 student name as, let's say, Raj, Rahul, Sam and Rashi. So I have this 4 students and only 2 of them are doing course. So I have S2 and S3 doing the course. Let's say the course is SQL and the course which that student is doing is Python. So my question is, I want to know the student names and the course in which they have enrolled. I want to only know those students who have enrolled for the course. That's my question. So if I try to combine the two tables based on the query which is being asked, the common field of combination over here with respect to the data is going to be ID. Now, here if you can see ID and ID is there, it can also be a student ID. It's not necessary that always the common column is going to have a same name. The main requirement condition over here is the common column or the joining column should have the data type to be same, not the name. Name is not a mandatory condition to be similar over here. So if you can see, I have ID over here and I have student ID in the course table. So the student who has enrolled for the course, I will be able to find when I match ID and student ID over here. So how am I going to write a query for the same is, I'll write select star. So star will give me all column names from. Now my first table over here is students table. The second table over here which I am going to do, and I am writing a condition over here known as inner join. So what is the next table which I want to do over here is course. And what is the joining condition? On students. Now definitely, as you know that from students table, what is a common column which I am trying to combine is ID, and from courses table, what is a common column which I am using to combine is student ID. So courses dot student ID. So this is a common field which I'm using to combine. So when this happens, a parser will go into the common columns which I have selected into the joining condition and it will try to match. So S1 is not finding any match into the course table. So that will not be shown into the outcome. S2 definitely finds a match over here and the result will consist of, so when I say the output over here, the output will consist of ID, that is S2, and what is a course which S2 is doing over here. So S2, the name of the student is Rahul and he is doing a course named as SQL, correct? Now it went to S3. Is S3 doing a course? So the match is found over here. So S3 would be found over here. So S3 name is Sam. Is Sam doing a course? Yes, Sam is doing a course of Python. And S4, no, S4 details are not found. So the matching entries are being fetched over here. This is how inner join works. As I said, it is going to combine data based on a satisfactory condition. It is going to combine the matching records from the common columns over here. So this is what we have understood theoretically, but let's try to also see a practical example for the same. So if you see my code file on the question which we have solved earlier, so if I want to talk and discuss about inner join combines data on the basis of condition which is satisfied. It tries to combine data on the basis of matching records within the tables, and it is also known as default join. Now what is the meaning of default join? Earlier in the earlier session, when I discussed that when I just write joins, it is going to consider and combine the data based on an inner join. That is the matching records between the joining column. So if I just take the same query over here, which I did solved, that was, I want to know, find details of those customers who have placed order, return course ID, customer name, customer ID, and quantity and price of each. So if I see the same over here, if I solve the question with the help of inner join, what am I going to do is select, if I do star from, what's the table name over here, what is the first table which I want to consider is customers. And I can also give alias, which means I can name this table in a short form so that when I use this table names, I don't need to write them fully. So I can write as T1. So here you can see I have named customers table temporarily as T1 for the purpose of query. And instead of just mentioning join, I'll mention the type of join over here, that is inner join. And what I'm writing, orders as T2. So I have T1 and T2, so I'll write on. What should I write? Customers.id, orders.id. So instead of writing customers, I can write T1 dot, what do I write? ID. So T1 is acting as a customers table. So there is a temporary name given over here. T2 dot, it also has ID. So when I combine the data based on the same, you can see I got the result. But I wanted the names of the columns. So I want T1. From the T1 table, I want the C name, and I can name it as customer name. So I can use alias over here into joins as well. I want ID. You remember when I just mentioned ID, it was showing ambiguity error. Why? Because it's available in both the tables. So ID, when I just simply write from what table I need to select it, it will show an issue. So when I write T1 from customers, take the ID, it will consider the ID over here. Then when I write T2, from T2, what do I want? I want quantities. So I'll write quantity. And from T2 again, what do I require? I require the price each. So I've mentioned from each table, what do I require into the outcome. So here, if you can see, only those names of the customers are available again for us, which are matching between both the tables. So this is how inner join works. So I hope we are able to understand what does an inner join do. If I want to see again an example for the same, and if I want to know which products are ordered by the customers, so I have a question, that is, which products are ordered by the customers. So I want to know the product names which are ordered by the customers. As I have said that I have products table. So let's say I write select star from products. Now if I just do this is not solving my question. This is not giving me the answer for the question which I am expecting. Why? Because it is showing me all the products available into the platform. But do I require that? No. I require only those products which are ordered by the customer. So if I see orders table, select star from orders. Do you think so orders will have something which I can relate over here? Yes, you can see PID, which has product ID, which is there. So I can get the names of the products or the details of the products which are ordered by the customer. So how will I write it? I'll do select star from, if you want to write it in a beautified way, so from where I can write any table as table 1 and table 2. So I'm writing table 1 as products as P, any name I can give. I do inner join. Inner join what? Orders, because from orders I'll get the match as O. And then on. What do you think? So from products table, what comes? I have PID equals to, from orders table, what do I have? We have again the PID, if you can see. And when I execute the same, you'll get the answer related to the question, that which are the products which were ordered by the customer. So if I just want the products details, so I'll write P dot star. So in the select, when I've written P dot star, so it is not taking all the columns from both the tables. It is taking only the columns from the products table. So these are the products which are ordered by the customers over here. So this is the answer for my question with the help of inner join. So I hope we are understood about what is an inner join and how an inner join works. So far we have seen that what are joins. We also understood the concept known as inner join. Now the another type of join which I would like to discuss is nothing but a left join. Now what is the meaning of left join? Where does this left join table comes? What is a left table, right table? You remember that when I was giving an introduction, I told you that table 1 acts as a left table, table 2 acts as a right table. But let's try to get a more detail or more intel about the same. So when I say that I'm going to understand or I'm going to join the data with the help of left join, so what does it mean? So what is a left join? So left join, it combines data all from the left table. So it combines all the data from the left table. So it combines all the data from the left table, which means I'm going to take all the entries from the left table. Then what is the purpose of joins? That becomes like a select star from that table name query. But it's not the case. It combines all the data from the left table, that is a half part of the query. It also combines data from the right table. So it combines all the data from the left table and matching records. Now what is the meaning of matching records? Means the records which are matching based on the common columns. You know the matching records wala part which we have studied in inner join. So the same kind of concepts would also be carried over here. So and matching records, but this matching records will be considered from what table? From right table. So it is going to consider all data from the left table and only matching data or the matching records from the right table. Wherever the match is not found from the left table, it is going to show us null. Let me also help you understand that how does it works and what is the meaning of left table and right table. You know in joins, minimum to minimum we are going to use two tables. So which table is going to act as a left table and which table is going to act as a right table? Let's try to understand the same. So if I write the syntax of left join, as I said, the syntax of the joins is not differing so much as we are changing the types. It's one and the same. Only the name is changing. But the functionality do change when the name of the join is changing over here. So when I write select, I write the column list, which I have the list of columns which we have from. From what? I am writing this list from table 1. So we have table 1 over here, and then instead of inner, I'll write something called as left join. So in that dash, in that space, I'm writing left join. So I write something called as table 2 over here, and then there comes a joining condition on table 1 dot column is equals to table 2 dot column over here. So table 2 dot column. So this is what I have considered. But how will I get to know that which is a left table and which is a right table? So just see, I have written join as a command, and what is there on the left hand side? What is left hand side is this. So on the left hand side, which is a table which I have considered, that is table 1. So table 1 acts as what table for me? It acts as a left table. In a join, there was no concept of left and right because it is taking the matching records from both the tables. So you don't need a concept of left table or right table. But in a left join, we do require a concept to be known as left table and the right table. So which one is a left table? The first table you consider into the query is known as a left table, or a table to the left hand side of the join is known as a left table. And which one is the right table? The table to the right hand side of the join is known as what table for me? A right table over here. So which one is a left table? This. And which one is a right table? This. So it is going to combine all the data from the left table, that is a table 1, and only matching records from the right table over here. That's what we are going to get in the answer. But let's try to see with an example that how does it solves and what kind of output do we get when we perform a query related to left join. Now imagine I'll take the same example of students and courses. So students, and I'll take courses, let's say, and I have a question. Now what's the question over here? Find all the students course details. Now, what is the question? That I want to know all the students' course details. Means whether the students have enrolled or not, still I want to know the course details for the same. So I have ID over here, I have the student name over here. So I'll write student. I have student ID over here, and I have the course which a person is doing. So I have ID as S1, I have ID as S2, I have ID as S3, I have ID as S4, and as I said that the student name is Raj, Rahul, Sam, and I have what? Rashi. So these are the 4 students who are there into my database, and I have course tables in which S2 is doing a course of SQL, and S3 is doing a course of, let's say, Python. So these are the 2 tables which I wanted to combine. But what is the question? Find all students' course details. So I want all the students' information, that is student IDs, S1, S2, S3 and S4. I want all of them. But do I have course available for all of them? The answer is no, I don't have it. But when I want all the data from one table and I'll only take matching records from the another table, I am going to choose a left join over here. So how does a left join works? Let me write the syntax for the same. And what is the query for my particular question is, I'll write select. I'll mention star. So all the columns from which table? So the table which I write first is a left table. So which table? All the information I want all the information from the students table. So from what? From, I'll write students table. So that's my left table. And what type of join I do need to do is left join over here. In what table? Into courses table. So it is taking left table and this is the right table. The students table is the left table, courses table is the right table over here. And what's the joining condition over here for me? On what basis? From the students table, I am going to consider what? ID is equals to, from the courses table, I am going to consider what? The student ID, that is the SID, which I am going to take over here. So when I write the query, what is going to happen and how the parser is going to understand the question and the result for the same. So here if you can see, when I say students and courses and when I do left join, so parser will take all the details. First of all, it will check both the tables, that is the students table and the courses table. First, it will try to match the inner join records because there is a joining condition students.id, students.id. So what is a joining record? S2 and S2, S3 and S3. So that will be there. So if I show the result set over here, so the output over here would be, let's say ID, I have student and I have what? Course. So which is a common between them on the basis of the joining condition? We have S2. What is there? S2 is there. What is the name of S2? Rahul. And what course Rahul is doing? Rahul is doing SQL. S3, is S3 available? Yes. What course S3 is doing? S3 is SAM. Is SAM available over here? Yes. And it is doing Python. So it is taking matching records from the right table. But it's a left join. So it will take all the pending records as well. So I have S1, I have S2. The name of S1, left table is student. So I have S1, that is Raj. I have S4, which is Rashi. So here you can see Raj and Rashi's names are there, but their course will be null. Why? Because they have not enrolled for any course. So this is the output which we are going to get when I do a left join. It is going to take all the data from the left table and only matching from the right table. So here if you can see, ID and student is considered for all the tables, but courses are only considered for those tables where it is finding a match from the left table. So this was my left table and this was my right table, and this is how left join has worked. So left join combines all the data from the left table and only matching records from the right. This is what we have understood. One of the things that please note that left join is also known as left outer join. Left join, also known as left outer join. So what does it mean? That it's a left outer join. That is, it is taking all the data from the left table. What is the meaning of an outer? Outer means all the data from the table. So it is taking all the data from the left table. So it is also popularly known as left outer join. So many a times in interview it is asked, do you have or do you know the difference between a left join and left outer join? The answer is one and the same. The outer as a keyword is an extra keyword which is added in order to mention that it is taking all the data from the left table. That's what the answer is. It is not like the left join and left outer join are two different concepts. It is the same concept which is there. It is also known as left outer join. So you should not get confused when this kind of question is asked to you into the interview. So even if you don't write outer, the answer is still going to be the same. So this is how left join works. Let's try to see practically with the example. So we have seen inner join ka example over here. If you remember what's a left join? Left join. Left join combines data where all the records from the left table and also matching records from the right table are considered in the result set. Left join is also known as left outer join. So it is also known as left outer join. And if you know the syntax, the first table which we have is left table and the second table which we mention into the query is nothing but the right table over here. So as per the question which I have with me, let's try to solve and let's try to see how does a left join gives me the answer over here. Find all the customer details. So I want all the customer's order details, means whether a customer has placed an order or not. I want all the order details for all kind of customers over here. So if I do select star from customers, so it just shows me what the customer's information. It does not show me the order details for the same. So if I do select star from orders, so I have orders table which is there, but not all customers have placed an order, so I can get the answer over here with the help of left join. So select star from customers. So this customers is acting as my left table. As I told you that when I write something before join or on the left hand side of the join, it's my left table, and from where it is considering orders, and what's the joining condition on customers dot id is equals to orders dot id over here. So here if you can see, all the customers information is being given. Can you see that this customer 105, that is Nihal, has not placed any order. 107, that is Prerna, has not placed any order. So these are the two customers who have not placed any order over here. So for them the order details are blank. So all the customers are being considered, and from the right side only the matching records are being considered over here for us into the query. If you see the another question, find all the details, all the order details for all the customers. So I want all the details of all the customers. It's one and the same. So if I write select star from, but I write orders table first. So orders table is acting as my left table, and I do left join over here. Which table? Customers table, which are there, and I write on, and what's the joining condition? Orders dot id is equals to customers dot id over here. So that's there. You can see there is some mismatch happen. Why? It is showing only order details of those customers which is finding a match. Why? Because if you can see, orders table is my left table. It is taking all the data from the orders table and only matching from what table? From the customers table over here. This is how it works. So writing the tables into the left hand side and right hand side is very important based on the query. As I said, left join could also be mentioned as left outer join, and the result is still going to be the same. There is no such difference into the result over here. Why it is called as outer as a keyword? By it is taking all the data from the left table. So this is how left join works, and this is how the left join can help us to get the result set as per the requirements of the query. So I hope we are clear with what is left join and how do we implement left join into the query result set for us. As you know that we have studied about the joins as a concept, and we understood what is an inner join and what happens when I do left join over here. Now let's try to understand the next type of join which we have, that is nothing but the right join. Now what is right join, how it is different from the left join and inner join, let's try to understand with an example over there, and let's try to write a query for the same with respect to its syntactical approach. So when I want to discuss about the right join. Now as we have studied about left join, you all must be knowing what is a left join. Left join takes entire data from the left table of the table alignment and takes only matching elements from the right table. So if I want to talk upon and discuss about the right join, it's just the vice versa. So what does right join does? Right join takes all the data from the right table. So takes all the records from right table and matching records. So it is taking all the data from the right table but matching records from which table? From left. So it's a vice versa or an inverse of left join, I can say. So this is what right join does. So right join, as you can see in the left join, it combines all the records from the left table and only matching records from the right table based on the common field. What does right join does? It takes all the records from the right table and only matching records from the left table over here. So if I show you an example, that there is a table, just a second, let me increase that. Yeah. So if there is a column x1 and x2, that's a common column between them, 3, 4, 5, 6, 8, 2, 4, 5, 4. So this is data, this is data. Imagine this is my right table and this is my left table. So it is going to take 3, 4, 5, 6, 8, all of them. But for my left table, it is only going to consider 4, 5 and 4. As you can see, 4 was repeated twice, so it will consider it twice. It's not like it will consider it only once. So what it does, first it will take inner join and then all the data from which table, then the pending ones from the right table. That's what it is going to do. Now, as you have seen this, that this is how it works. So all the data, so if I get the result set over here, so x1, x2, it's a right join, so 3, 4, 5, 6, 8 has been shown over here. Now for x2, it will only show 4 and the 4 will be shown 2 times. And this is 5 and rest all of them are what? All of them are null. So this is how right join will perform. All the data from the right table and only matching from the left. So how do we write the syntax for the same? The syntax is very simple. So if I want to talk upon the syntax over here, what we will do, we'll start with select star from and then the table name. As I have said, the first table which we mention is always which table for us? A left table. Which type of join? Here I have to perform what? A right join. So I'll do right join and then I'll focus on table 2. Table 2 is which table? Right table for me. And then I will write an on condition. That's a joining condition. That which is a common field between them. So table 1 dot the column name is equals to table 2 dot the column name. So what's the column name over here? That's what we will see. And this is how right join is able to write the queries over here. So let's try to see with the example which we have. So we were talking about the customers and the orders database which has been created. So imagine that I write the query in such a manner that select star from and I write customers and I write a right join what? Orders. And I write a joining condition on. What's a common column? Let's say customers dot id equals to what I write? I write orders dot id. So when I do this, all the data from which table? Now which one is my right table? And orders table is my right table. Because this has been written what? On the right hand side. So orders is my right table. So all the data from the orders table and only matching data from which table? From the customers table would be selected. And that's how it will give us a query. Now let's see with a practical example over here with respect to our code. So how does it shows? As I said, find all the order details for all customers. So I want this. I want to find all the details for all the customers. So I have an e-commerce data. If you know that, select star from what? From customers. If I do, I have a customers table. So there are customers which are there. And if I do select star from orders, so this is there. What I will do over here is I'll try to combine both of them with the help of right join. So how does right join will perform? If I do select star from customers and I write what? A right join. So which join is required over here? Right join. Right join what? Orders. So I'm going to join what? Orders over here and I'll write on customers dot id. That's, let us see that what's the common element between the customers table. So what do we have? ID, correct, equals to what is there in orders. We do have ID over here. Yes, we can use it. So orders dot ID, which is there, and this is how the data is coming. So all the data from which table, my right table is orders over here, has been considered, and only matching data from which table, the customers table, has been considered. Now, as you know that left join is also written as left outer join because it considers all the data from the left table and matching data from the right. Outer is the only extra keyword which can be added, but the outcome still remains the same. Similarly, in right join, you can also write right outer join. What does it say? It does the same thing. It takes all the data from the right table and matching from the left. So that has been shown over here. So you can see all the data from the orders table has been considered. Now let's say in orders, you can see this is a data where there is customer related information 102, 004, 001, 003. In customers table, you can see 102, 004, 005, 006 and many more things. So all the customers who are there, orders are being available for them. So we can get the answer with the help of right outer join or right join. So as I said, you know that, right? What is the difference between left join and left outer join is an interview question. Similarly, what is the difference between a right join and right outer join is also one of the interview question. So what will be the answer for the same? Right join or right outer join is still the same. The outer as a keyword is an extra keyword which is mentioned, which states that all the data from the right table is being considered. So that's all we can discuss related to right join. So far we have studied about inner join, left join and right join over here. We have another type of join from the multiple types of joins which are possibly available in SQL. Now what's the next type of join which we can study and which we can discuss in terms of getting a query result from my data. Now the next type of join, which is also known as an outer join, one of the popular join, not so much widely used in join, and MySQL doesn't support it, but definitely I'll try to explain you what does my outer join helps us to do. Now there are many words written for the same. You can call it as outer join, many people call it as full join, or many people do call it as full outer join. Full outer join, or many people call it as full join. Now what is the meaning of full join, full outer join or outer join over here in general? Now when we were discussing about inner join, if you remember the inner join, what does inner join does? Inner join takes data from one table, data from another table. If it is matching, only that values will be considered in the outcome. That was an inner join. That it combines data only when the match is found. The second one, that is nothing but my left join. Left join takes all the data from the left table and only matching elements from the right. That was the case. Now when I talk upon right join, it does vice versa like the left join. It takes all the data from the right table and matching from the left. But what if I want to take all the data even though if it is matching or not. And for that, I will be using something called as outer join. Now what does outer join does? Outer join combines data, or so it combines all the records or all the rows which are there. So combines all the records, or I can call it as rows, from all the mentioned tables, all the tables. So whatever tables you have been using, it will combine all the rows from the table even though no match is found. What does it say? Even though there is no matching element found between them, it is going to consider all the entries over here. Let us see with an example that what it is. Actually, your outer join cannot be performed into your MySQL because MySQL doesn't support outer join over here. So what does it do? Let's say x1, x2, x3 is table 1. Table 2, I write x3, x2 and x4. That's there. Now if I say 1, 3, 5, 2, 4, 8, 6, 6, 7. If I say A, B, and let's say 2, C, D, and let's say 10, E, D, E, and let's say 1, F, G, let's say 3. So this is the data which is there. And if I write the query for the same, what would be the query over here? The query would be select star. I'm selecting all the columns from where I'm selecting over here? From T1. Now my T1 as a table is what table? My left table. And what I wrote outer join. I can write full join, I can write full outer join, it's fine. Outer join, and then I write what? T2. T2 is which table for me? It's a right table. And I write on as a joining condition. That is from T1, which column I want? X1. And from T2, which column I want? X4. Now it doesn't matter if the column information or if the column name is different, but the information within the column needs to be same. So here if you can see, when I write this, what happens over here? It will go to the left table, right table, and it will go to x1 and x4. x1. 1 is 1 found over here? Yes. So this record will be there into the entry. So in the join it is doing. If 2 found over here, is 2 found? Yes, it will be there into the entry. Is 6 found over here? It's there in table 1, and table 1 is what? My left table. But it's not there in table 2. It's fine. It is still taking it over here in the outcome. Now, it will check 10. Is 10 there into T1? No. But it will still take it. Is 3 there over here in T1? No. It will still take it. So what happens over here? It doesn't matter if there is a match or no. All the entries from both or the multiple tables which are being selected will be used as an outcome or will be shown in the query result. So if I see the result for the same, how does it looks like? It looks like x1, x2, x3, x4, x2, x4 which is there, and x3 is again here. So it will show you 1, 3, 5. x3 related is, let's say for this entry it's nothing, so it will show you that. So it was 1 ke liye we have that D, E and 1 which was there. 2 is matching, yes. So 2 ka A is like A, B, sorry 2 ka it's 4, it's 4, 8, and what it shows me? A, B and 2. Let's say what it shows 6, which is there, and 6 is not there. So 6, 7 and no entry is there, so it will give what? Null over here. And if you want to say, let's say 10, it will show over here. And for 10, is there any value which is matching? No. So it's null over here. There is no 10, so it will be null over here, null over here. And what is the value over here? C, D and 10. So here you can see it doesn't care that if there is a match between the two tables or not. It is just trying to combine all the records, all the entries from both the tables. And that was right, outer join for us. So this is all about outer join. Now outer join is not feasible into our MySQL, and that's why we didn't see with any practical example for the same. But if I want to simply explain what does outer join does, it will combine all the data from the multiple tables and show it at once into the query. And it will not focus on if the match is found or not. If it is found, it's well and good. If it is not found, still it's good that it is going to be considered into the outcome. So as we have discussed a lot of type of joins over here, whether it be a left join, right join, outer join, inner join, left outer join, left inner join, and many more things. Now, what I am going to study, or what we are going to study, is there any other join which are different from those which we have studied so far? So if you remember that when I discussed about joins, I said that there is an inner join which we know now. Inner join is used to combine data which is common between both the tables or multiple tables which are being used. Outer join is combining all the data from all the tables which has been mentioned, no matter if it is a match or not. Cross join is something which we have to study. Left join is combining all the data from the left table and matching data from the right. Natural join is something which we have to study again, and set join is also we have to study. Now we also know what is the right join. It is combining all the data, or it is collecting all the data from the right table and only matching from the left. So what we have to do over here with respect to cross join, natural join and set join. So let us understand over here. So first of all, let's try and discuss out a natural join. Now as the name suggests, natural. As the name suggests, natural. Now what is the meaning of natural? Natural means you naturally find something over here. So natural join, what it does? Natural join is a type of join which people say that it behaves like in a join, but no, it doesn't behave like in a join at all instances. Now natural join is a type of join which searches itself. Now what is the meaning of searches itself? Which means they don't require any joining condition. Now what's the joining condition? You remember that we write on table1 dot column is equals to table2 dot column. That's a joining condition which we give. So natural join will combine the data very similar to inner join, but it has certain requisites, it has certain requirements, and it has certain behavior to be followed. So natural join combines data naturally from multiple tables without any joining condition. Now what does it say? It will not require any joining condition to be there. There is no joining condition required. It will naturally go and search for the data for the same over here, and then it will try to generate or get it into the result cell. So for that, let's say I have table where I have ID, where I have name, I have age as table 1, and I have table 2. Let's say I have student ID, I have the course on which they have been allocated. Right? So I have ID as 101, I have name as, let's say, my name I insert, and I have age as 30. Now student ID over here, let's say the student ID is 101 and I'm doing a course of what? SQL. Now let's say there are few more students and I write it as Rashi, age is 23, 103. Let's say this is Raj and this is 25. Let's say 104. This is Hitesh and this is 26, and 103 is doing the course of, let's say, Python. So this is the data. If I want to combine these two tables, T1 and T2, with the help of natural join, how does a query will be written? So in order to write the query for natural join, what I have to do, I have to write select, I can write star from the table 1. What is the table 1 over here? T1, which is definitely which table of mine? A left table. And then instead of writing inner, outer, right, what we have discussed so far, I write something called as natural. So natural join. So when I write natural join, it will ask for T2, that is a table 2, and I write this is a right table. You don't have to write this is left and right. I'm just writing it for your simplification. And when I try to write on as a joining condition, it will throw me an error because no joining condition is required. If I try to write using, it's still a joining condition and it will not be required. It will throw an error. So my query is formulated only till here. That is this. So what happens when I go over here, when I do and when I write this table? It will go to T1, it will go to T2 and it will naturally find. What is the meaning of naturally find? It will go and itself find, is there any common column between them? So here ID not matching, name not matching, age not matching, student ID. Here there is no student ID, course not matching. So there is no match found between them. That's what we can see. So when no match is found, it should give us blank result, error or anything. It performs a slight different way. That is, when no match is found, it behaves like what? A cross join. So when no matching column is found, no matching column is found, it will behave like what join? A cross join. But let's say instead of ID, it was a student ID. It saw that yes, there is a match between them. Now it's just a rough scenario that instead of ID, it was a student ID. Then there is matching column found. So matching column found is there, and what we will do if the matching column found is there. Now this matching is not only with respect to the name, but the values within should also be matching. So inner join, if the name of the column and the values in them is also matching, then it will perform an inner join. As you can see, in this student ID and student ID was matching. So it will go in this table 101, 102, yeah, 101, 101, yes. 102 not there, 103 yes, and that will show a result set very similar to what? A inner join. But it is naturally going and finding the data in order to join these fields. Why? Because natural join goes naturally. There is no joining condition required. So many people call that it works like inner join. No, there are possibilities, there are scenarios, and how does a natural join works and reacts in terms of giving us the outcome related to certain queries. So earlier people used to use natural join a lot because they used to think, okay, when two tables are there, the column name is going to same. But there were certain instances where the column name amongst the shared columns are different. So at that time natural join was failing and it was giving every time a cross join result, which was giving a lot of entries, and that need to be avoided. For that they came up with an approach of inner join, where I can mention the joining condition, but in natural join I cannot mention the joining condition. So this is all about natural join over here. I discuss cross join, that what is cross join, so that you get a more clearer idea that what it is actually. So we can perform practically what is natural and cross join and understand the result set or the outcome. So the next join which we will be studying is nothing but a cross join. Now what is the meaning of cross join over here? And let us understand what does cross join means. So cross join, also known as Cartesian join. Now remember this term. What is the meaning of what? Cross join, it's a Cartesian join. So cross join is also known as what? A Cartesian join, where each entry from one table will repeat itself with each entry of the another table. So cross join or Cartesian join, where each entry of table 1, so each entry from one table repeats with each entry from another table. So it gives a Cartesian product over here. So if I want to simplify with an example, imagine that there is one table over here that is nothing but drinks. What drinks are ideally available for us to have it into the restroom? So imagine that there is a drinks table which is available, and there is, let's say, breakfast which is available, and when I am ordering, I want one drink and one breakfast combination. So drink, let's say there is tea, there is coffee, there is juice. So tea, coffee and juice. Let's say for breakfast we have poha, we have idli, we have eggs, and let's say we have oats. So I want to make one drink and one breakfast combination which is there. So what I can do? I can either order tea and poha, tea and idli, tea and eggs, and tea and oats. So every order or every record from one table can make a possible combination with every record of the another table. So how many entries I made, how many records I made, how many possible outcomes I made? 4. Now let's say if I want to see with coffee, what can I order? So with coffee I can order poha, idli, eggs and oats. So it has 4 possible outcomes. With juice, I can order poha, idli, eggs and oats. So 4 outcomes again. So 3 records over here. So 3 juices were available, 4 breakfast options were available. So what are the possible combination pairs? 3 into 4. 3 into 4 is nothing but how many pairs could be made? 12. So 12 such combinations are being made. So what was the reason behind showing this example? That each record of one table is going and making combination with each record of the another table, so that we can generate an outcome. And this is known as a Cartesian product. This is known as a Cartesian join and also known as cross join. As I said, where entry from one table repeat itself with the another entry of the another table, or record from one table repeats itself with the another record from the different table, or each record from the different table. So it will create multiple outcomes over here. So how many combinations are being made? 12 with respect to the data. So in order to write the syntax for cross join, what is a cross join? Syntax. So for syntax, or let's say the query, not the syntax, but let's say the query. So what I will do, I'll start with what? Select. Just a second. What I will do, I'll start with what? Select star from. Now I'll mention table 1. Now what is the table 1 which I have? Drinks. What is the table 2? Now in order to mention the table 2, I'll write what? Cross join. What is the table 2? That's breakfast, which is there. And here you have to mention the joining condition. If you don't mention it, still fine. So if I write it till here and then close it, this is what I'm going to get. Tea poha, tea idli, tea eggs, tea oats, coffee poha, coffee idli, coffee eggs, coffee oats, juice poha, juice idli, juice eggs and juice oats. That's what I'm going to get because each record is being repeated with another record of the entire table. So here if you can see, when I say no matching column is found, it performs cross join, which means if I say that instead of this ID, student ID, it was just ID. So according to the natural join, when it is naturally going and searching for a common column to find a join, it cannot be found out over here because there is no common column which can show a match. So what it is going to do, it is going to repeat a cross join over here. That is, this entry will repeat this and this. This entry will repeat this and this. This entry will again form a combination with this and this. And this entry is going to again form a combination with this and this. So how many records will be made? 4 into 2. 4 into 2 is nothing but 8. So each record from table 1 repeats itself with each record of the another table to make possible combinations or pair. And this is what a cross join does. So when a natural join doesn't find any common column name based on the name and based on the natural selection or natural search, it is going to work like a cross join. And let us see with an example now that how does a cross join works. So natural join, as I said, we had tables. Let's say select star from which table do I have? Customers. So this is a customer table and I do select star from which table? From orders table, which is there. So these are the two tables which I have. Now I know ID is a common column between them. And when I did left join, I wrote on customers.id is equals to orders.id. But here I will write select star from customers. Select star from customers and I'll write what? Natural join. What? Orders. And if I try to say that there is a joining condition, if I write on over here, you can see on is not valid at this position, expecting the end of the line or end of the statement which was there. So on, let's say customers dot id is equals to orders dot id. Now people think that it is a mistake. So orders dot id, which is there. You can see you have a syntax error. What is the syntax error over here? The writing pattern must have been wrong. So on is never being used over here, and that's the reason why the writing pattern was wrong. So when I run this or execute this, can you see an inner join has performed? Why? Because ID as a common field was found between them, and the result which we got from an inner join, the same result is being shown over here. Now, if I do a natural join when the column names are not same, let's say select star from products, which is there. Now product name, products table and customers table doesn't have anything in common. So if I want to do is, let's say select star from products, and if I write natural join, what? Customers. I take customers and there is nothing in common over here. And when I execute it, can you see this? That there are n number of records. Each entry has been repeated itself. Can you see this? So each entry has been repeated itself n number of times. That was a cross join. So each entry from one table is repeating itself with each entry of the another table in order to generate the outcome. So there are many outcomes generated. So can you see 49 rows are being given in the outcome, and that's how cross join works. If two tables who are asked to naturally join doesn't have anything in common, so it will not give us error, it will not give us blank result, it will perform what? A cross join. That this was about natural join. I hope it's clear. Now let us focus on the cross join example and let us see how does cross join works. I know that I want to mention this data for each entry or each order which is being placed. So if I like select star from which table, let me take it as orders, and here instead of natural I'll write what? Cross join. What I want to give over here is nothing but the products table. So here you can see each product is repeating itself with respect to each order which has been placed. So this is how cross join works. Now as people say that can I write on condition? Yes, you can write on condition over here. So on orders dot id, PID equals to products dot p underscore id. So here if you can see, when I write on as a joining condition, it's not behaving like a cross join, it is behaving like an inner join. So in cross join, if you don't write any joining condition, it can work like a cross join where the Cartesian products are being mentioned, but if you mention any joining condition, it will work like an inner join for us. So this was a cross join, and when I can use a cross join, let's say I'll create a table, company, and let's say company name, I'll create it with one column, C name, which is there, and it's what? It's a varchar, 100 characters, and I say it's a varchar, and yes, that's it, no need to do it. So I ran this, I do insert into company, insert into company. I know one value is there, so I'll write values over here, and I'll write xyz.com, which I have mentioned, and this is being written. So if I do select star from company, so it is showing me this. If I want to repeat the same name to all the customers who have placed orders or who are about to place orders, let's say I do select star from customers cross join, let's say orders which are there, it will do this. Instead of cross join orders, I can write cross join what? Products. So it will do what? Cross join what? The products which are there. So here you can see, products in company. Yes. So here you can see each data is being associated with the name of the company. So this is how I can do. Now, if I say that I want all the details from the customers table, so how I will do it? Customers dot and star. So all the data from the customers table would be gathered over here. So only customers related data you can see in those queries. So this is how cross join is working. If you want the company name, so company name, C name, let's see company का नाम क्या है, C name correct है, C name from company. So here you can see this is what it is showing. So the company name of each individual is also being shown. So selective data is being shown into your cross join. So this was all about natural join and cross join and how both of them could be helpful in terms of implementing and writing certain criteria and conditions with respect to the data. So I hope we are clear with what is a natural join and what is a cross join. So as we have seen that how does a query is being written and executed with respect to certain joining statements. Now let's try to combine all the different types of joins and let's try to solve certain questions based on the same. And there are furthermore joins which we will be studying, that is nothing but a cross join, self join and a natural join. We will understand that how those types of extra joins would be used and understood and how a query result would be generated from the same. So if you can see on the screen that there are certain questions framed on the e-commerce website or e-commerce database which we have. So on this e-commerce database, we have 3 tables. The very first table is related to customers. Now what does this customers table tell me? Now customers table will tell me that what information is there related to the customers. So what all customers are there who have been enrolled into this platform. So if you can see there are n number of customers which are there, and the second table which we have is nothing but the orders. Now what does orders table tell me? Now this orders table will tell me the customers who have placed the orders and what was the orders placed by them. So this is the orders table and definitely it will be having certain products which are being ordered. So there is a products table which is there and here I do select star from products. So these are certain products which are being ordered over here. So if I want to solve the questions which are there, let us see how we are able to solve it. So what is the first question? Find what were the products ordered by each customer. Now in order to find that what products are being ordered by each customer, what I should ideally do is, I should ideally go to first customer table. Let us see, I have customers information which is there and there is nothing related to what has been ordered. So definitely I'll go to orders table to see if I have it or not. And yes, we do have order ID, that's the order ID which is being used, and the ID, the customer ID who has placed the order. And here I have product related information but not the name. What is the question which I want? What were the products ordered by each customer? So I don't know that what were the products which are being given over here. So I just have IDs, P1, P2s and so on. So I need to combine data from the products table itself. So far, the examples which we were seeing, we were trying to combine data from one table or two tables, not more than two tables over here. So if I want to combine data from more than two tables, is it possible? The answer is yes. When I was teaching you about the explanation for what is joins, joins are used to combine data. Now many people say that joins are used to combine data from two tables. No. Joins are used to combine data from multiple tables, and we will see that approach, that how multiple tables are used to combine the data with and how we will get the query set for all of them. Now I want to use three tables over here. First is the customer, then there is the orders, and then there is the products which are being ordered. So let us see how I can combine a customers table and an orders table. I need something in common over here. So what is a common over here? I know that ID is something which is common between customers and orders table. Then I have something called as products. I have product ID and I can combine it with which table? With the orders table over here. So let us write the query for the same. And if I write select star from, I'll write from. From what? from the first table, I'll take the customers table and first find what were the orders placed by them. So customers, and I'll write with join. Let's go with inner join at the very first go, and let's then modify the query. So I write inner join over here, and which table I'm going to combine it with? Orders. So it takes the customer table, it takes the orders table, and combine both of them with the help of what? An inner join. But what is a commonality, or what is a search element which I want to do? So on means on the basis of what I want to combine these two tables. So there is customers dot ID. I know that there is ID into customers table, and I know there is ID into which table? Orders table as well. So if I take this and I run this query, you can see I will get all the details of those customers who have placed orders. Now I definitely know not all the customers have placed orders. So here it is showing only those customers who have placed what? Orders for us. So if I want to find all the customers over here who have not even placed orders, then I will use left join. Now why I am using a left join? Because customers as a table is on the left side of my query, and I want all the information from the left table, and that's why I'm writing what? A left join over here. So when I write a left join, if you can see, there are customers who have not even placed any order, but still their entry are being available. Why? Because it is combining all the data from the left table and only matching from the right. So this has been considered. Now what I do require over here is nothing but the products related information. I have got product IDs, but I don't want the product IDs. I want the name of the products to be shown, like what were the products ordered by each one of them. So here, in order to combine more than two tables, how I will do? I will write again a join. What type of join I want is an inner join over here. So inner join over here. And which table I want to join? I want to join a products table. And products table is being used. Now, based on what commonality should I join? On. Now, in the orders table, I know there is a product ID. So, on P underscore ID. And in the products table, I definitely know that there is an ID. So, I'll write products dot ID. Products dot, just a second, products dot P underscore ID. And if I take this over here, you could see that it is giving me the products which has been ordered by those customers. So this were the products which has been ordered by those customers. So if I want all the product related information or all the orders related information, you can see when I did inner join, only the matches are being given. But if I want all the entries of this query and only matching over here, that is the products table. Now many people don't know that what actually happens when you write more than one join over here. I know that this is my left table and this is my right table. I know this is my left table and this is my right table. But when there is one more join mentioned, which one is my left table and which one is my right? This entire thing is my left and this is my right table. So I want to use this entire element over here. So I will be writing a left join, and it is giving me a result set for the same. So all the entries are being shown over here with respect to the query. So as you saw that we have got the query and the result from all the three tables. Now what is the purpose of two left join over here and how it has performed? Now when the query was executing, when the query was written, select star from customers left join orders. And on this, let's focus on this first query. What does it say? The first table is my customers table, which is acting as a left table, and the second table is my orders table, which is definitely the right table. So when I do the query, all the data from the customers table and only matching elements from the orders table are being fetched. So when I run this query itself, it was giving me some results. Now when I try to join it with products table, if I do inner join, only the matching elements would be shown. And if I want all the entries which were shown in this query, I will write what? A left join over here, and it will take all the entries which were shown in this query and only matching entries from the products table based on what? The product ID. And you can see this is how the result has been generated. Now there are certain columns which are repeatedly shown. I don't want all the columns which are there. Let's take certain of the column datas and let's see how my query could be executed. So instead of star, we will mention a specific column name which we required. Let's say I require ID, so I wrote ID over here. Let's say I require CNAME, so I will write CNAME over here. Let's say I required city from which the customer belonged, so I wrote that over here. Then let's say I required the order ID, so O_ID is being mentioned over here. Now what is the quantity ordered in price each? I want the total price to be there, so I will write price each into quantity ordered. So that's the QTY, quantity table. And then what I want the product name which is being ordered. So name of the products, and let's say I can get the details, it's fine. So when I run this, it is going to throw me error. Now why it was throwing me error? Earlier though it gave me the outcome which was there, but why it is now throwing me the error? You can see the error is not related to the wrong column names which were there. The error is related to what? Ambiguity issue. That is ambiguous issue. Now what is the meaning of this? Now when I am observing the data into customers table, if you see customers table, there is ID, and in the orders table also there is a ID column which is mentioned. Now when I say to my SQL that I want ID, it got confused. Okay, you want ID, but from which table? Do you want it from customers table? Do you want it from the orders table? And that's why it got confused, because it was the same name column which I directly wrote. So column ID in field list is what? Ambiguous. And for that, if I want it from customers table, I'll write customers dot ID. So from the customers table, this ID is going to come. CNAME, city, and when I execute this, it's executing it properly, and you can see it's giving me the proper answer for the same. So this is how ambiguity or the ambiguous issue could be solved. When you have same column names and you have directly mentioned it into your select, it will get confused. Okay, if the same column names are there in multiple tables, from where do you want to choose it? And that's when you have to mention the specification that you have to choose it from the particular table. This is how we got the answer for the query. So when I run this query, you can see that what were the products ordered by each customer over here. So customer 105 has not placed any orders. So you can see no order detail for the same. Customer 107 even has not placed any order. So no order detail for that customer as well. So this is how our query related to multiple tables joining as well as allowing certain queries or certain columns to be shown into the outcome could be written. Now, I know that when I'm trying to combine the data, can you see this ID and ID? It's the same column amongst the two tables. Product ID and product ID. It's the same column name among the two tables which are there. So instead of writing on orders.product ID is equals to products.products ID, can I use something else? When the column names between the tables are what? Same for the shared column. So yes, I can use something called as using for the same. So I will write C. Select. Let's say I'll take this entire query, but I will remove all this rest of the statements. Yes. So I'll remove this on. I'll remove this one which is there. So I wrote left join orders, and instead of mentioning which column from table 1 and table 2, I'll write using. Now using is a statement or using is a function which I can use, and I have to give a bracket that using what? Between customers and orders, I want to use what? ID. So you can see ID is a common column name where the name of the column and the data within the column is also same. So it can combine directly. So using is used only when you have to join the two tables and when in order to join it, you have a same column name. So I'm writing ID. On is used when you have same column name or different column name as well. So here I know products may using. I didn't need to mention that I wanted product ID from orders table or no. From the first query, wherever the product ID as a column was there, it will consider that over here. And that's there. And when I run this query, you can see the same outcome is being generated for me, which was being generated above. So using as a keyword can also be used, or using as a function could also be used for me to get the result set of a query only when the shared column between the tables is having the same column name. That's when using as a part could be added into your joins. So this was the first query resolution over here. Now what does the next query says? Find out how many orders were placed from each city. Now I want to find out how many orders were placed from each city. First, let's try to see which tables would be useful. So as per the query, let me see select star from orders. So I have order related information, but do I have anything related to city? I guess no. I don't have any data related to the city column. So let me see, the orders are being placed by whom? Customers, and they will definitely be belonging from certain city. So select star from what? I'll write what? Customers. And let me see if they have city related information or not. Yes, they do have city related information over here. So what I want over here is I want to count how many orders were placed from each city, which means first I need to combine both the data and make it as one table, and then need the count approach for that particular city. So for that, let me combine this data. As you all know, select star from customers which were there, and I want all the details from the customer table because all the city related information is required for me. So I will use something called as left join. Why I am using left join? Because customers as a table I have mentioned on the left hand side of the table query. That's the first table, and that's why I use left join. So it will take all the data from the customer table as per the requirement. And I want which table? Orders, which are there. And I want to mention on or using. If I do with using, it's fine because I know customers and orders have a same column, shared column, which is named as ID. But if I want to use on, is it not possible? Yes, it is possible. That's a basic way of writing the joining condition. But at certain time, if I don't want to repeat my customer's table name, the table name could be big. I don't want to repeat it again and again. So I can give an alias. You all must be knowing an alias which was there, an aliasing or a token name which could be provided. So I will name this customer as C and I will name this customer as O, the table as O. So when I want to use C or customers table, I can mention it as C. When I want to use orders table, I can mention it as O. So I'll write on what? C dot ID equals to O dot ID. So this is also a possible criteria or a scenario which we can give. So when I write this, you can see all the city related information is coming for the customers and all the order related information is also being shown. But my question is not कि I want to find out the cities for the customers who have been placed orders or not. My question is find how many orders were placed from each city, which means I want to create groups of cities and then run an accumulation of count over there. You all must be remembering a group by clause which we have studied. So definitely a group by clause could be helpful over here. Now how does a group by clause works? So after joining, so group by is written after joining. So I've joined the data. What I will say, I will group the data. So group by. Which groups aggregation is required over here? I want the data count related to city. So I want to create groups of what? City. Now, as I have said, if I run this query, it is going to give me error. Why? Select list not in group by clause. You all must be remembering that when I taught you group by, the column which is a part of my group by is the same column which should be a part of my select. So that's a city. So when I get this, it is only giving me the city from where the customers are there. They are placing the orders. It is not giving me the count. In order to find out the count, I have to use what? Aggregated function. What's my aggregated function over here? Count. And it is counting what? I can write star, I can write city, it's fine. So if I write star, it's giving me. So how many orders were placed from each city? From Hyderabad, I got 1 order. From Bangalore, I got 2. From Chennai, I got 1. And from Mumbai, how many orders were placed? 3. But instead of this, now let me do star and let me eliminate this group by. So how many total orders were placed from Mumbai? You can see 1 and 2. And how many orders it is giving me? Let's see. 4. Why? Because I did count star. It is not counting, it is counting all the rows. So Mumbai was there. I want to count only when the order was placed. So can I write order ID? Yes. Now you have to be wise when you are choosing this. Now can you see Mumbai? So 2 customers from Mumbai has placed order. Let me explain you what has happened over here. So when I see this data, Hyderabad, how many orders are being placed? 1. Bangalore, how many orders are being placed? 2. Chennai, how many orders are being placed? 1. Mumbai, how many orders are placed as? You can see 1 and 2. There are 2 orders being placed over here, which are there. So what you have to do over here is, if you do count star when you are finding, so if I write city and you're writing count star, when you're writing count star over here, what does it do? It will count Mumbai as 4, but ideally how many orders were placed by Mumbai? 2. Star means all the rows, so all the rows are being counted. So Mumbai as a row is available, and that's why it is giving me what? 4. But I want to count only those who have placed orders. So I'm counting on the basis of what? On the basis of order ID. And this is when I got a correct count, where I know Hyderabad, 1 customer has ordered, Bangalore, 2 customers have ordered, Chennai, 1, and Mumbai, 2. So this is the query result of my data. Now instead of count ID, I can use as, I can give this spaces like order count, and this is what it shows. So from each city, how many orders were being placed, you can see. So find out how many orders were placed from each city. We saw the answer for the same. This is how joins can help me to get the answer of the results. Now what is the next one? What was the total amount spent by each customer on the platform? Which means how much was the total amount spent by each customer? Let us try to see. So as you know, I'll again use the customers and the orders table over here. Select star from which table? From the customers table as C, and let's say in a join, I will take only those data who have placed orders because I want to find the total spend which they have done. So orders as O. Now I can write using as well. Using, I know both of them have common name, that is IT. And that's it. So when I did this, you can see this is the data which was there. Now I want to see what was the total amount. Means what was the total spend done by each customer. Can you see? Sam has ordered twice, 2 different products, so spend will be different. Now Rashi is there, Pranav is there, Rishabh is there. So I want to create what? I want to create group by, because I want to find it with each customer. So each customer group needs to be created. C name. I'll create a group by on the basis of the name of the customer. Now what is the next question which is required? That the column which is there in select. Group by, same column should be there in select. Now what I want? I have price of each product into quantity, because quantity is being there, and that's one thing. Now I will write sum of this. Total is what I want to find. So this is what the sum which is being gathered over here. Sum, as I can write total amount, and you can see it is showing me the total amount spent by each customer. So how much was the total amount spent by each customer? You can see it from here. So Sam spent 9,900, Rashi spent 2,250, Riya spent around 2,760, Pranav spent around 39,000, which is there, and Rishabh has spent around 757 over here. So I hope this you are getting it, that how we are able to solve the group by related queries as well. We can definitely do it with the help of the joins. Now, who were the customer who spend more than 5k on the platform? I know that what was the total spent by each customer. Now I want to filter out this spend which I have calculated over here, and definitely in order to filter out the grouped result, because this is not an actual table, this is a grouped table. In order to filter this, I will definitely require something called as having. So what I will do over here is I'll select the same query and I'll just modify it a little bit. What is the modification? Who are the customers who spend more than 5k? Now Sam has spent more than 5k, Pranav has spent more than 5k. I want those customers who were there. So instead of where, you all know that where cannot be written after group by, and where cannot filter an aggregated data. So what I will write? Having. Having what? Total amount. The total amount should be greater than what? 5,000. 5k is nothing but the 5,000 over here. And you can see which are the two customers who have spent more than 5,000 on the platform. It's Sam and Pranav. So this were the two customers who have spent more than 5,000 into the platform for placing any orders or ordering certain items. Now the last question which we have, how many times each product was ordered? I want to find out how many times each of the product was ordered and sort the data from highest to lowest. They're asking me to find out how many times the product was ordered, and I want to sort it. Means the highest ordered product to the lowest ordered product which is there. So let us see. I don't require a customers table over here. I have orders table and products table. It's more than fine. So select star from which table I want. I want orders table. Let's say as per the question, how many times each product was ordered. So in the orders table, I have product ID. So on the basis of product ID, I can do find the analysis. But definitely I don't want to give the product ID. I want to give the name of the product which is being spent, or which is being used, or which is being bought. So which table will have that information? Select star from what? From the products. So it is finding those products which are there. So find how many times each product was being placed or was being ordered. So what I'll do, select from, you all must be knowing star from which? From orders as O. If you want to do inner join, fine. If you want to do left join, fine. If you want to do right join, fine. Let me do a right join over here. Why I'm doing a right join? Because I want all the products information over here. So products are mentioned at what side? The right hand side of the data or the query which is there. And that's why I've written right join. All the details from what? From the products table are being required. And I can write on O dot product ID equals to p dot product ID, which was there, and I end the query. So you can see this is how the data has been coming along. The product IDs which are there, here it is matching, here it is not matching. Now I want to create what? Groups. Now group by. Which group I want to create? I want to create the name of the product which was there. And if you see, if you run like this, it will give me error because product name as a column needs to be mentioned as a group by statement. So product name, if you can see, this were the products which were there and how many times each product was ordered. So if I like count and I'll do ID instead of using star. So here if you can see, notebook, dark chocolate, hair accessories, beanbag, perfumes, toys and games and camera is being available. So here it's there, as I can find out like total count over here, and you can see the table name or the result column name has been changed. What I want to sort the data from highest to lowest. In order to sort it, what I'm going to use, I'm going to use order by. I want to order by what? From highest to lowest. So I write total count and order to lowest, which is nothing but descending. And when I run this, you can see which was a product which was ordered the most over here. You can see dark chocolate, then notebook, then hair accessories, then perfumes which are there. Now beanbag, toys and games and camera doesn't seem that people have ordered them. Let us see in orders table. P2, P2, P2. It has occurred 3 times, so it is showing me. P3 and what we have? P5. So it has occurred what? Sorry, P3, P5 and P1. It has occurred once, so it is showing me what? Once. Over here. Which was there. Now instead of ID, if you want product ID to be mentioned, you can mention the product ID which is there, but it's ambiguous. So I will mention it from which table? From the orders table. So from the orders table, if I mention the product ID, it can show me this required result sets. So these are the products which are ordered what? Once, and this is the frequency of ordering, and these are the products which has not at all been ordered, and you can see how many times each product was ordered. So most of the time chocolates were ordered the most from whatever products are being available into my data. So this is how we can use our inner join, left join, right join in order to solve those queries and get the particular result set with respect to the statements which are being provided. So this was the simplistic approach and the use case of writing joins and getting the reports from the query and from the data which is stored within the database. So far we have seen that how we join and combine the result of multiple tables and show it as one into the query with the concept of joins over here. But are joins actually requiring 2 tables from me? Can it be possible that the table which is required or the info which is required to be sufficiently available in 2 different tables or multiple tables is due to some issues or due to some data inputs it is available into the same? That how I can get the result from that kind of table and how joins are actually giving me the answer for the same. Let's try to understand it over here. Now if you can see on my screen, I have an employees table over here. So this table name is as employees, and my question from this table is I want to find out the name of manager to which that employee is reporting for each of the employee over here. So I just have one table provided. I have employee ID, I have names of them, and I have reporting IDs which are there. It has not been given okay what employee, or it has not been given a different table related to the employees reporting part, or the employees details over here. There is one table related to employee IDs as well as their reporting IDs. And the question which is asked to me is find the reporting manager of each employee. So the question is, they are asking me to find the reporting manager of each employee over here. Now, as I said, I definitely require two tables in order to search the data of the reporting. But due to some issues, the data is ideally possible in one table. Now, how can I use joins over here? We all know that joins are used to combine data from two or more than two tables to generate a result set for us. But there are no two or more than two tables. So what can I do over here is, first of all, let's see the columns which I require to join and get the result set are there or not. So in this table, I have employee IDs related to each employee and I have reporting IDs. So to which this employee is reporting, I have them. And can you see these two columns could be used for us in terms of joining the two tables. But there are no two tables. So can I join a table with itself? The answer is yes. If I want to join and get the result over here, I can join a table with itself. And the concept where the table is joined with itself is known as self-join. Now many people say, okay ma'am, self-join is something which is newly created, or do we have to write a keyword known as self to get a self-join? The answer is no. It will perform just like your inner, left, right join, but just the concept or the name as self has been given by developer. Now this is a joins which doesn't have any keyword known as self. It's a developer created join where developers understood the need of this join. Why? Because this kind of data came into consideration when they were performing certain query analysis, where the table which was ideally supposed to be there in two different information, or the information which was ideally supposed to be there in two different tables, is found in one. And that's when they find a need of joining a table with itself with the help of inner, left, right joins which we have studied. So self is not a keyword, or self join is not a keyword. It's a concept where the table is joined with itself. So self as a keyword is used just because a table is joining with itself over here. So let's try to see how a syntax will work for the same. So I will write select star. So I'll write all the columns over here from which table? Now you all must be knowing the first table which is used as your left table. So I'm writing employees over here. Now after writing employees, do I write a keyword known as self join employees over here? So if I write something like this, the query itself here turns wrong. Why? And if this kind of question is asked to you all in interview, the interviewer will get to know, okay, you don't have any idea related to what a self-join is. First of all, there is no self as a keyword created in order to do a self-join. As I said, it's a developer created join. It's a logic, or it's a concept which is used to join two tables, showing it as two different tables, although the base table is the same. So self keyword is not required over here. It's not mandated to be written. You can write your inner, outer, left, right, no matter whatever you mention, but there is no keyword as self. Now, if I do something like this known as, let's say, inner join over here, and I say on employees dot reporting is equals to employees dot employee ID. If I do something like this is still going to give me an error, because in a query, even though you have two tables mentioned, the two table names could not be same. It needs two different tables to be considered to be joining and showing it as a result set, but we are using the same table. So alias or the aliasing concept is very important over here. What it will do, I can alias my table as E, that is employees, and I can alias it as R, that is reporting. So even though the base table from where the query is being returning the outcome is the same, the two tables are shown to different over here with the help of alias. And as I said, joins require minimum two tables to be combined and joined and shown in the result set. So we have a table known as E, which stores data related to employees. We have a table known as R now, which stores the data related to reporting. But if you see, the base table behind both the E's and R's is the same. So this is what it makes itself a self-join. What is the meaning of self-join? A table, when it joins itself, is known as a concept of self-join. And the joining condition is very important over here, because if the joining condition is not correct, it might not give you a required or the desired outcome for the same. So if I say that I want to find the reporting manager of each employee, so from the employees table, I want the reporting part, which is matching from reporting tables employee ID, EID, which is there. And this will provide me the result set related to the same. Now what has happened over here? A table has joined itself because the information is available in the same table which was required to join for us. And this is how self-join works. Now I cannot show the result set over here to you. So the same type of data I have into my database, and I'll show you with a practical example for you and show the concept of self-join, writing with respect to inner, left, right, and so on. And we will also write and try to write a joining condition with the help of where clause. Let's try to understand over here. So if you can see on my screen, a self-join is a type of join where the table joins with itself, allowing it to compare rows within the same table. So rows are compared within the same table in order to generate the result set. Remember, there is no self-join as a keyword. So if I have a table known as employees, select star from employees, which is there. And as I said, the example which I gave you on board. So I have employee number, I have last name, first name, extension, email, office code, reports to. So 1002 does not reports to anyone. So he or she doesn't have any reporting manager. 1056 reports to 1002. So this is going to be the reporting manager of this employee, and that's what I wanted to know, or I wanted to get into the outcome. So if you see my database, there is no manager table or no reporting manager table available. So as I said, when the data which was ideally supposed to be available in two different tables or multiple tables is by some issues or by some discrepancy or the data related constraints or data insertion part is available in the same table. But still I can write a query in order to generate the outcome for the same, and that's when developer came up with a concept known as self-join. So the question was, find the reporting manager of each employee. So I want to know the reporting manager of each employee over here. So select star from employees. It is showing me the employees detail. I want to know the reporting manager over here for each employee. So I want to use employee number and reports to match with each other and get the name of the reporting manager. For an example, 1002 doesn't have any reporting manager. 1056 does have a reporting manager of 1002, that is this employee is the reporting manager of this employee, and that's what I wanted to know. So if I use a keyword known as self join employees, if I do something like this, this is going to be what? I'll write on. What is an on condition? I'll write employees. Employees dot reports to is equals to employees dot employee number. And when I execute this query, you can see nothing is being written. There is no self join as a part working over here, and no outcome is generated. Even though the query is running what successfully, no outcome is generated for the same. Now, if I do inner join over here, you can see when I'm doing inner join, what is a query? Not unique table or alias employees. So it requires two different tables from where the table would be joining. But is there any two different table join happening? No. It is showing the same table. So it is asking no unique tables or alias. Either the table name should be unique, or the alias which you give, or the token name which you give should also be unique. So I'll write as E and I'll write as R. So when I write like this, you can see it's having an issue into the same. So employees dot reports to employees dot employee number. Now the table names are E and R, so that might give you an issue. Now on condition, what I'm going to write in on condition? If you see an employees table, this table is named as E, the same table is named as R. Now imagine if this data was available in two different tables named as employees and reporting manager. What we will take? We will take the reporting IDs from the employee table. So the same thing which we are going to do, employees dot reports to. So I'll take this and I'll try to match the employee IDs of the reporting table. So R dot employee number. And when I execute, you can see it is showing me the data related to the same. Now 1056. What's the employee number which is matching? 1002. So it is showing me all the columns and many columns over here. So let me write E dot first name, comma E dot last name. So it will show me the employee names over here, the first name and last name for the same. Now if I do R dot first name, that is reporting table dot first name, to whom this table is being reporting to, so you can see it is being reporting to that person. So first name, let's say this is not first name, this is last name. So if you see the employees table, 1056 is reporting to 1002, and have I got it correctly? The answer is yes, I have got correctly. 1056, that is Mary, is reporting to 1002, that is this domain. Now I have got the data. I have done inner join, and that's the reason why it is not showing me the data. Now if I do left join, you can see there is no reporting manager of that employee. 1002 has no reporting manager and it has considered it was null. So we have considered the reporting manager name, R dot last name. What's the name? I can concat this data which is there, concat this as employee. I'll write the name as employee, name, and then the next one is concat and I can write it as reporting manager. So here you can see This is an employee name and there is no reporting manager. This is an employee name. Who is the reporting manager for the same? If you want space, you can give space over here. First name, last name with space. Just there, so it is with separator, it is considering. Just a second. It will have e dot last name over here for us, and you can see there is a space coming along. R dot last name, and it is having that space. So who is the reporting manager of each employee has been shown over here. If you want to know the employee ID, e dot employee number, comma, let's say concat. You can see the employee number of this details, and you want the r dot reports to number, and you can see this as a value. Let's say I forgot a column over here, comma over here. Just a second, let me bring it, and it's a comma. So here you can see the reporting IDs are there, the reporting manager names, it's there. So reports to over here. So if you don't want reports to as a part available, it's fine. You can do this. So employee number 1002 doesn't have any reporting manager. Employee number 1056 has a reporting manager. Employee number 1076 has a reporting manager. Employee number 1088 has a reporting manager. If you can see, 1002 doesn't have. 1056 has a reporting manager as 1002. So this is how self-join will work. A table has joined with itself. So no self keyword is being used to join the table with itself. The concept is created by developers just to know that when a table has an information which was ideally there in two tables, or ideally supposed to be a part of two tables, but it's available in one table. And that's when a self-join as a concept could be used. I can use a self-join with the help of where clause as well. So how I can do it is select star from, let's say I'll take employees as E and employees as R, and in the where condition, I write the condition which I had given. E dot reports to, the employee reports to, the reporting ID should match with reporting stable employee ID. So it is giving me the data. Let's say I use the concat approach, which I did over here. And the same answer is being thrown to me in the outcome. So this is how I can do and perform a concept known as self-join. So I hope you're clear that what is a self-join and how self-join is used to join a table with itself. In the self-join part, we can do a concept of left, inner, outer, or right usually. We don't write a keyword of self-join over here to join a table with itself. It is doing inner, left, right by default over here. So this was all about self-join. Now imagine that you have written all the clauses into your query in order to retrieve the data, right from the select clause to the limit clause. Now what is the flow of writing the query? What are the flow of writing the clauses, and how does a clause is executing and retrieving the data from the database which is stored into the database server? Now, this is one of the most important thing when it comes to the flow of the query. or the flow of the clauses, which needs to be known when you have implemented multiple clauses into your query. So what ideally happens, or what actually happens when a query is written, how each clause should be placed within a query, and how the execution happens. Let's try to understand the same. So we will understand the flow of query with respect to its writing statements as well as with respect to its execution over here. So first, let's try to understand with respect to its writing statements, that how the query is written over here. So with respect to the writing logic, how the clauses should be placed. So you all must be knowing that when you start retrieving the data, when you start fetching the data from the databases, you definitely start with something known as select. So whenever you write a clause, the clause usually starts with a thing known as select. There are certain instances where it starts with a with clause, usually during your CTEs or common table expressions. But at usual, you will always write your retrieval statement starting from select. So the first part which is written into your query is select. Now after select, which clause is going to come? You all must be knowing the syntax: select star from table, which is there, or select column list from table. So after select, we usually write something called as from. But do you remember that there was a clause known as distinct? It was supposed to be written with select statements. So after select, if you are required to find out the distinct elements from the data, so you will write something called as distinct over here. So the next clause which is written is nothing but distinct. Now, what after distinct? What is going to come after the distinct statement? Definitely your from statement. So select distinct column list from and the table name which is there. So here you will mention something called as from. That is, after writing select into your query, after writing a distinct clause over there to find out the unique elements from the same, you will mention something called as from. From will help you to go to from which data, from which table element you want to fetch this data over here. So from will be written after that. After from, you will definitely write something called as joins. Now we know that we have written where clause, but there are instances where you have to combine two tables or more than two tables to show it into the result set. So what are we going to write over here after from? Is nothing but joins. If the join is not there, then you can proceed with something called as where. So in terms of writing flow, you will write joins over here into the statement after from. So after you have joined the two tables, then you will try to filter it out on the basis of where clause which is there. So you can filter out the rows with respect to the criteria which you want or the search condition which you want after joining the table with the help of where clause. Now after writing a where clause, what do we implement? We group the data. After filtering, if there is a requirement of grouping the data, we definitely group the data over here. So I'll write something called as group by. That group by will help me to group the result set with respect to the outcome which needs to be shown. So group by would be written for the same over here. And let's say if I have grouped the data, but I wanted to filter out the group results over here. So how will I do it? I'll write something called as having. So if I wanted to filter out the group results, I will mention something called as having. And after mentioning having, let's say I wanted to sort the data over here on the basis of the counts, on the basis of the names which I have gathered, I'll definitely write something called as order by. So I'll mention something called as order by over here. And then at the end comes your limit statements. So what is coming over here after order by is nothing but your limit. That what are the limited records which you wanted to show in the outcome. So this is how the query flow is supposed to be written over here. Now let me write a query with the same flow which I have mentioned over here, and let me show you that how a query will be executed or will be written over here. Let me write it down over here itself. So when I write a query, what I will do, I will first start with select. So select is going to be the first part over here when the query is written. Now after select, I write something called as distinct into my query. So I have written distinct. Now imagine that I have data related to the employees and departments. I wanted to solve a question and I'm writing a query for the same. So I'll write select distinct and I write something called as department name. Let me write it down with a different color. That's a column name. So I'll write it over here as department. Which is there. And here, let's say I want the department project name, which it is working. And then I will find out how many employees are there. So I'll write count star over here, which is the same, which I'm doing over here. So count star. So I've written those columns over here. So I wrote select distinct department project count star from. Now from which table I want this? I want this from which table? From the employees table. So I'll write what the employees over here. So what I want the employees table to be mentioned. Now definitely I want to join this criteria over here. So I had a joining statement and I wanted to do is inner join. So I wrote inner join and I wanted to join a table known as departments where the project and other related informations are found. So I will join the data on the basis of departments, which was there. I named it as E. I'll name it as D. So it becomes very easy for me to write the query. So obviously with join, I'll have a joining condition because without joining condition, it will not filter out the data for me. So I'll write on a joining condition. What's the joining condition? E dot department ID is equals to D dot department ID. So that is a joining condition which I have mentioned over here. And then after writing this, I'll write where. Now where? What's the criteria? I want to only take those employees where the salary is greater than 30,000. So I have filtered the data over here. And then after filtering out with the help of where clause, I want to group the data. So group by. You remember the column which are there in group by should be a part of my select. In select, there is something called as department and project. So I want to group the data first on the basis of department and then on the basis of projects which are there, which is being worked upon over here. So I have done the same. After grouping the data, what I am mentioning over here is nothing but having. Let's say I say that filter out those departments and project names where the count of the employee is also greater than 2. So more than 2 employees should be working on the department based projects, which was there. So after that, I mentioned that I wanted to sort this data over here. So order by, I wanted to sort on the basis of, let's say, the count, which was there. So I'm sorting the data on the basis of count. So count star. In which order? In descending order, which I'm mentioning. And I wanted to see the top 3. So which of the departments and projects have more employees working in it. So top 3, and I limit the statement with the help of limit 3 records over here. So this is how I have written the entire query with respect to all the clauses. Now one question which comes into mind that when you see the query statement written over here is The way the query is written, is it the same way that it is executing and showing me the result set? The answer is no. The flow of execution and the flow of writing of the query is totally different from each other. So if I wanted to show you the flow of execution, the flow of execution means how the query executes and give me the outcome, is not how it is supposed to be written. So the flow of execution is totally different from what it is being written. So how does a query goes and executes and fetch the data over here? Let me understand with the statement which I have written. Now imagine, select distinct department projects count star. This is not running first. Whenever a query is written, always it will execute the from clause very first. So what is being executed when a data is being fetched from the query is nothing but the from clause. So as per my query which I have written, it will first go to the employees table which is there. So it will select the employees table, and after that what it is going to execute, is it going to execute select for us? No. After from, it is going to go and do the joining statements if available. So do I have joins into my data? Yes. So it will go and take employees data, join the department's data with each other over here. With respect to which join do we want? We want it with respect to the inner join. So it has joined the data with respect to the inner join. So first the from executed when the query is generating the result set. After that, joins have been executed. Now, what is going to execute later is nothing but where clause and not the select. Even though we have started the query with select, the select is not executed first. First, the from is being selected and from is working. Later on, joins are being implemented when the outcome is generated, and then comes the where clause. So it will filter out the data based on the condition. Over here, it will join the two tables first and then filter out those employees who are having salaries greater than 30,000. After filtering, do you think so now select is working? No. It will group the data then. So it will implement what? It will implement group by for us. So it will create the groups on which the data is supposed to be grouped. So on what basis I want to group the data? I want to group the data on the basis of departments and projects. So all the filtered records will be grouped now on the basis of departments and projects with respect to finding their count over here. So grouped has been done. Is it now that select is executing? No, it is now executing the having statements. Now what is having saying? I wanted to find out or filter out the result set having count of the employees greater than 1. So it is executing that. Now after executing having, after filtering out the group data, what is going to execute? Is it going to execute order by? No. Now it will select the select statements. So after having, what it is going to select over here is the select statements, that it will select the data which is supposed to be shown in the outcome into the select column list. So after selecting the table, joining the tables, filtering out the result sets based on the where condition, grouping the data which is filtered, and then filtering the group data with the help of having, now the select statement will be selected to generate the outcome. And select statement will select the columns which are available into the column list. After that, what is going to execute? Is order by going to execute? No, it will execute the distinct clause. What is distinct clause? You remember that distinct clause will give me distinct result set or unique result sets which are there. So distinct will be executed over here. And after distinct, it is going to now execute and do order by sorting. So order by happens after distinct, and at the end limit is being working or limit is being executing to show me the limited set of records from the query. So the query which I have written, the flow which the query has maintained while it was written, the same flow is not maintained when it is executing or when it is fetching the data, retrieving the data from the databases. So that's why this is one of the important interview question when it is asked that how do we write the clauses within the query and how do we execute the clauses. What is a flow of query written and what is a flow of execution of the clauses within the query, because both of them are not same, they are totally different from each other. So this was flow of execution of the queries which is there, and this is how clauses are executed when a query is being written with all the clauses. So I hope we are clear with the same. Hello all, we will understand a new topic today. Now this topic is somewhat, people think that it's related to the joins which we have studied, but let's try to see how does set operations or set operators work into SQL. Now, as we all have studied, what are operators? Operators are nothing but operations, or they are used to perform operations or tasks within the data. Now, what is the meaning of set operations? In school, you all must have studied about sets. Now, two circles where you had numbers and where you had to do certain tasks such as A union B, A intersection B, A difference B, and so on. So the same kind of logic which we are going to understand in SQL. And let's try to see how set operators are different from what we have studied so far over here and how they could be used and when they could be used. So the topic for the day is nothing but the set operators in SQL. Now, when I talk upon set operators, they are special kind of operators which serves a purpose of combining the results of two or more component queries. Now, what are they doing? They are taking queries and then combining both of them and showing it as a one result set. That's what in simple terms I can talk upon the set operators. So the set operators are a special kind of operators which serve the purpose of combining the results of two or more component queries. Now the queries that contain set operators are referred to as compound queries. Compound means combined queries which are there. The result of this operation is a single set, that is a single outcome. Even though I'm using three queries to combine it at once, the outcome is going to be only one, not multiple, which are there. So the result of this operation is a single set, no matter how many select statements will be present in the compound query. So in simple terms, set operators are used to show me a compound result or a combined result of multiple select statements. So we have four types of set operators which are frequently used in SQL. In MySQL, we preferably use the only two, which is union and union all, but I'll show you all the four operators with a simplistic example that how all four of them will generate an outcome for us. So here you can see a Venn diagram. You all must have seen in school that two circles, when they combine together, it becomes union. Union all means both the queries individually, all the results would be shown. Intersect, you can see it will only show the matching records between both the sets which are there. And minus is it will show only data from table 1, but it's not possibly available in table 2. So we all have studied this set kind of operations into school, but let's see how do they work. I hope you understood the Venn diagram which is being shown over here, but let's try to see a practical example or the practical implementation of the same. So imagine I have two tables with respect to set operators which are there, the table 1 and table 2. Here you can see the columns between both the tables looks very similar, but the records are not so similar. The records are different from each other. But the column names, the count of the column looks same. One of the major criteria which set operators do require when they are used. First is, whatever queries you use, the column names and the data type must be same. The length of the column or the count of the column must be same in both the queries. We will also see how it is shown, and the positioning means the position where each column is mentioned over here should also be same. That are certain key requirements over here, but let me talk that later. Here you can see we have table 1 and table 2. In table 1 we have customer ID, order code, date of order, name, sex, city, country, age and number of items. Same goes in table 2. I have customer ID, order code and same set of columns which are available in table 1. Here you can see customer IDs 1, 2, 3, 4, 5, 6, and then it's 11, 12, 13. Now if I see table 2, it's 2, 3, 7, 8, 9, 10 and 14. Between both the tables, which are the common customers which I can find? I think so it's customer 2. Yes, I think so it's customer 3, which is common between both of them. Now I know this, but does my SQL know, or does my SQL will help me to perform the same over here? Let us try to understand with all the 4 types of operators which are there and how all of them will generate an outcome for me. So if you have seen this table, let's proceed further with understanding the first set operation, which we know is nothing but union. Now, what is the meaning of union? In school, you all must have studied A union B. A union B, correct? So this is what we used to study in set operations. A union B. This is a symbol of what? Union, which are there. So what ideally used to happen? Imagine that we had set over here 1, and let's say we had another set B over here. So I had A and I had B. Now imagine I have 1, 3, 4, 5, 8. I have 3, 7, 2, 5, 10. So this is the data, and if I do A union B, what it used to show me? 1, yes, A is an element of A, X is an element of A, that is a data part, should be a part of A, or it should be a part of B. So 1 is there, it's in A. 2 is there, yes, it's in B. 3 is over here, 3 is also over here. So it will be not showing me twice, it will be showing only once. That is what a union is. It will show me the record even though it is available multiple times, but only once. So 3 is shown only once, then 4, then do I have 5? Yes, I do have 5 twice, but it will be shown only once. So here if you can see 6, not there, 7, yes, 8, yes, 9, no, 10, this is a data, this is an outcome which I had generated with A union B. It will combine all the data from A, all the data from B, and if there are repeated elements, or I can call it as duplicate entries, it will be shown only once. That was the simplistic meaning of union. Now let's see with the data which we have, how does a union will perform over here. So you all must be knowing that customer ID, order code, name, column list is same, and that's a basic rule that we wanted the column numbers and the names to be same. It's there. Now when I do A union B, that is table 1 union table 2. So what it will show all the details from here, but what is a matching element? 2 and 3. 2 and 3. It is available, it's a duplicate entry, so it will be shown only once for me. So here, let me proceed further with what is a union. So here you can see the SQL union operator. The SQL union or the union operator is used to combine the result sets of 2 or more select statements. As I told you, set operations are used to combine the results of the select statements or the queries or the component queries which are there. So the union operator is used to combine the result set of 2 or more select statements. Now, what are the rules which a union or any kind of set operator should follow? First, every select statement with union must have the same number of columns, which means if the first select statement had 3 columns, the next select statement which I want to combine or unionize should also have 3 columns, which are there. The column names or the columns must be having similar data types, or else it would be an issue over here. So the data type should be what? Same. The columns in every select statement must also be in the same order. So the order of the execution or order of mentioning the columns into select statement is also very important, which is there. The syntax is very simple. You have to write multiple select statements and just have to add a word known as union between them. So if you can see the syntax, select column names from table 1, union, select columns or column names from table 2, which is there. So the table which we have, if I write a select statement over here, or if I write, so select star from table 1, that's the first select statement, the first query which I have. Then I have union, which is there, and if I do select star from what? From table 2. So I had two select statements and I have combined the result of two select statements by adding what? A union as a keyword. Is it satisfying the rule which has been set? Is column number or column count the same? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had 9 columns over here. Do I have 9 columns over here? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first condition or the first rule is satisfied. The second rule over here is the column names and the data types must be same. Yes. Are the names of the column same? Yes. The data types are same? Yes. So that seems to be what? Correct. Now the column positioning should be same. First is customer ID. Is first customer ID over here? Yes. Order code, yes. Date of order, yes. It's the same. So all the three rules which we wanted are being satisfied. Now let's see when I do union, when I run this query, what is the result which it is ideally giving it to me. Can you see all the information from table 1? Now what is there in table 1? Just a second. 1, 2, 3, 4, 5, 6, 11, 12, 13. Is it giving me 1, 2, 3, 4, 5, 6, 11, 12, 13? That was the result from the first select statement. What was the result from the second select statement? 2, 3, 7, 8, 9, 10, 11. That was the result from the second select statement. But 2, 3 is not again repeated. It has started from what? 7. Why? Because I said you that it is only going to give me what? Distinct records which are there. It is only going to give me distinct records. So if 2, 3 is available once, it is not going to be repeated or it is not going to be shown. So if one row is possibly available and if a duplicate row or the same row occurs, it is not going to show me 2 times. It is only going to show me once, which is there. So it has started from 7, 8, 9, 10 and 14. So if you can see from the second query or from the second select statement, it has given me 7, 8, 9, 10 and 14, which is there. So this was about union, that how does a union works. Now let me explain you the another set operator which is union all. It's almost the same. It's just a slight difference. What is a slight difference? Let us understand over here. So what is union all? The union all operator selects only distinct values by default. The union operator, what does it do? It will show me distinct values, which means if the duplicate records or the duplicate rows are available, it will show me only once. But union all will also show me duplicate rows or duplicate records. So if the record is repeated n number of times, it will be shown that number of times for me. So the query is same, select column list from table 1, union all, select column list from table 2. So I'll write select star from table 1, union all, select star from table 2. And here you can see 1, 2, 3, 4, 5, 6, 11, 12, 14, 13 was taken from the table 1. And 2, 3. Now 2, 3 was already there. The same record was there. But 2, 3 over here is again what? Repeated. Why? Because it was union all. It will allow the duplicate rows. It will allow the duplicate entries to be shown. Union was only showing me distinct values or distinct rows. Union all will also show me duplicate records if they are or if there is. So that was a union all very similar to what a union is, just it allows me to show duplicate records or duplicate entries over here. Now the next one, intersect. You all must be knowing intersect over here. We used to write, right? A intersect B. We used to write A intersect B. This was a symbol of what? Intersect. Now what does intersect used to find out? Common. If you know the Venn diagram, this is table 1 and this is table 2. The common between both of them is known as what? Intersect. So the same thing it is doing. It is finding the common elements between both of them, or the common rows, or the matching rows, or the duplicate rows between both or multiple select statements over here. So the intersect set operator is also used to combine two or more select statements, like we saw in union, but it will not give me all the rows or all the result. It will result the table only holding the rows which exist in all the select statements, which means it's matching in all the select statements, or I can call it as duplicate entries in all of them. So in other words, it only returns the duplicate rows, but they are present only once in the final result. Now you all must be knowing that in table 1 and table 2, customer ID 2 and customer ID 3 was repeated, which means it was there in table 1 as well as in table 2. So that are the intersecting or the matching records or the matching rows between two select statements which we wrote. So the syntax is same, just you have to remove union or union all and just have to add intersect. Now MySQL server does not support intersect as an operator, but if it is supposed to be written, this is how it executes and this is how the query is shown in the outcome. That was about intersect, which is there. So here you can see it showed me the matching records or the matching entries between both the tables or multiple select statements which are there. So the next set operator known as minus, many people call it as except as well. What it does, it will show me data from the first query, but it should not be found in the second query or the another queries which are there. So a minus set operator shows the rows that are present in the first query but absent in the second query, in which order? In ascending order, removing any duplicate rows which are there. So I had data. Now I have written select star from table 1. I have written minus, that is remove the records which are matching between multiple select statements. So select star from table 2. Now you can see it is giving me 1, 4. 2, 3 is not given over here. 1 and 4. 2, 3 is not given over here. Why? Because 2, 3 was found in the second table as well. So it will show all the data from the first query and it will show nothing matching from the another query. So that is not match. So here you can see if I do 1, 2, 3 is not shown because it was a match. It was found in table 2 as well. 4, 5, 6, 11, 12 and 13 which is there. In simple terms, it is also known as A difference B. You all must be knowing this set operation known as what? Difference. What it does, it will take all the elements from A which should not be found in what? B. So this was A, this was B. It will take all the data from A, but it will not consider the matching elements which are also found in what? B. So that is what a minus operator does. Sometimes people do call it as except over here. So this is also an operator which is not supported by MySQL, but this is how we can actually do the set operation and how the outcome would be generated over here. So this was the set operations which are there. Now I showed you with some theoretical logic. Let me show you with a practical example for union and union all that could be done in MySQL. And then let me talk upon a very famous interview question, which is nothing but what is the difference between a set operators and a joins. Many people will ask you these questions and you need to know the answer for the same. But let's first see the practical implementation and then let's jump into the question and how do we answer the same. So if you can just a second. So if you can see my screen, what I have written, union. Union is a set operation in SQL that combines the result of two or more select statements into a single result set. So no matter how many select statements you are writing, the result will be shown only one. So the result set contain all the distinct rows from all the select statements, eliminating any duplicates if there are. So it will eliminate all the duplicates which are there. So I've written the syntax, select column 1, column 2. So it depends on the column list which I'm giving. In the query 1, union, the same column number should be also there in this. And then we have union operator or union all, which will help me to also show me the duplicate entries or the repeated records over here. Let me talk upon it with the examples, and I'll also help you to understand the rules which a union or the set operation sets over here. So let me go and take the employees table. So select star from what? From employees which are there. So can you see the employees which are there? So this is a data which you can see. So I have employees table. I want to see the employees which are working in the department as, let's say, D1. So where department ID is equals to, I write the employees should be there in department as D1. I can see that this is the employee which belongs to department as D1. Now, I wanted to know that which employee has the maximum salary over here, that is the highest salary. So I'll do select star from employees which are there, where I'll write a question. I'll write not where, but I'll write what? Order by. Order by what? Salary. And definitely, I want to sort the data in descending order, and I want to know the employee who is having salary. That's the highest salary. Can you see the employee Joey, ID as 130? That is an employee who is having the salary. Now, what is the question? Find the details of those employees who belongs to department as D1, or they have the employee has the highest salary. So what is the question? I want to find out those employees who either belongs to department as D1 or they have the highest salaries which is there into the data. Now definitely when I run this query, select star from employees where department is equals to this, it is showing me the details of the employees which are belonging to department as D1, but it is not showing me department having highest salary. So if I write where and I write and then I write salary is equals to max salary, you all must be knowing this is incorrect. Why this is incorrect? Because I cannot use aggregated functions or the grouped functions into my cell where clause, and you can see the error, invalid use of group function. Let's say and ki jagah I'll write or, and when I run this, it's still the same. Either D1 or the employee is having the maximum salary. But this is a wrong query because in where I cannot do it. I can definitely do it with subquery, but it will add a complexity into it. How can I do over here is First, let me find out, okay, which employees are belonging to department as D1. Yes, many people, how they will solve this question is, they'll do this and they'll do order by what? Salary. And they will do limit as 1. They will do this. But it's not there. Let's say I'll do salary as descending and limit as this. So what is the problem over here? It is only seeing, or it is only observing the department as D1s and their salaries are sorted in descending order, and I'm getting the first result over here. But I don't want to show the maximum salary of an employee from D1 department. I wanted to show that which employee is either belonging to department as D1 or having the maximum salaries. So if I run this query over here, you can see this is there. This is employees belonging to D1 and this is an employee who's having highest or the maximum salary over here. I want to combine the result of both the queries into one. So I will use something called as what? Union. I'll use something called as what? Union, which is there. So let's try to practically see what we have understood and learned theoretically with respect to those set operators. As I've told you that MySQL as an RDBMS does not support intersect as well as the minus as a set operator, but it does support union and union all. So let me show that how does union and union all will be showing the result set. The rules actually need to satisfied when the set operators are combining the data from multiple select statements, and how do the errors will be shown if the rules are not being satisfied. So here you can see I've written union is a set operation in SQL that combines the result set, that combines the result of 2 or more select statements in a single result set, which is there. Which means even if I write 10 select statements, it can combine the data and show it to me as 1 in the outcomes. The result set contain all the distinct rows. So union will do what? It will show me all the distinct rows. So even though any row is repeated, it will be shown only once to me for all the select statements, eliminating any duplicates. So union will not consist of any duplicates which are there. You have seen the syntax. The first select statement, select column 1, column 2 from table 1. Union, select column 1, column 2 from table 2. The union operator can also use with an all keyword, that is a union all as an operation, which will also include duplicates into the result set. The syntax remains the same. Just instead of union, you have to mention something called as union all. Let us see with a practical example over here. Now I have employees table. So select star from what? From employees, which is there. So here you can see I have data related to employees over here. I have ID, first name, last name, phone number, hiring date, job title, department ID and salary. Let's say I want the employees having salary greater than 30,000. So what will I write? Where salary is greater than 30,000. Let's not take 30, let's take 50,000. So I've considered it as 50,000 over here. And I execute it. So this many records are there which are having salaries greater than 50,000. Now let's say I want salaries greater than 90,000. Not there. Let's say I write salary is greater than 80,000. Yes, I do have an employee. Let's say I have salaries greater than 70,000. I have 5 of them over here. Now, in the first query, what it is showing me? It is showing me the employees having salary greater than 70,000. Now, there is also one more query which I am writing. Select star from employees. Having what? Let's say I write where, just a second, where department ID is D5 or salary is greater or is less than 40,000. So what is the next query? What it has? It has either the department ID as D5 and the salaries which are there is less than 40,000. So you can see a lot of queries which are there. And I'll write one more query. And the salary is not equals to, so I'll write not equals to 0. So it should not be equals to 0. So it is giving me those results where the salary are less than 40,000, yes, or the department is D5. So here you can see I have written two select statements. The first select statement give me the details related to the employees having salary greater than 70,000. So in this, it is giving me or generating me 5 result sets over here. You can see 101, 107, 111, 112, 130 which is there. And the next query, what it is showing me, it is showing me the result set over here where the department is either D5. So you can see all the employees from department D5 or the salary is less than 40,000. So here you can see that there are two departments, D2 where the salary was less than 40,000 which is there, and the salary should not be equals to 0. So the salary over here, that some of the employees doesn't have any salary, it's 0 over there, and I don't want those details to be there because when I fetch salary less than 40,000, definitely 0 would also be a part of it. I don't want those employees to be there. So this is the data which is showing. Now let's say the query says I want to get the details of the employees having salary greater than 70,000 or salary less than 40,000, or they should be belonging to department as D5, or the salary should not be equals to 0. So a lot of criteria I need to write in where clause. So what did I do? I wrote two select statements over here. Select star from employees where salary is greater than 70,000. I wrote another select statement over here which is giving me department as D5, salary as 40,000, and the salary should not be equals to what? 0. And I want to combine the data of both the select statements. So here I need to first remove what? Remove the colon from the first select statement, and I need to write or mention union between them. So what is the meaning and the purpose of adding union between both the queries? Now you must be knowing A union B. Consider data from table A, consider data from table B, and combine and show it at once. If there are duplicate entries, show me only once. So imagine my set A is nothing but select star from employees where the salary is greater than 70,000. My set B is select star from employees where the department ID is equals to D5 or the salary is less than 40,000 and the salary is not equals to 0. So I run this, and when I run this query, you can see the data which is there. So here, this is a result of my query, or this is a result of my outcome. So the result of query 1 is combined with the result of query 2. It does a row-wise combination. But are the rules satisfied? Does it show me any error over here? No, because I have selected all columns from query 1 and all columns from query 2. So the length of the column was matching. But imagine, I would have written ID over here. I would have written, let's say, the first name of the employee over here. And I would have written, let's say, the last name of the employee. And I would have mentioned what? Salary. So my first query, how many columns does it consist? It consists of 4 columns in the outcome. In the second query, how many columns does it consist? It consists of all the columns which are there. So the column count definitely is not matching in both the queries which are going to union themselves, that is combine themselves and show it at once. So when I run and execute this query, you can see the error. What is an error? The use select statements have a different number of columns, which means the column count is not same in the select queries which I have mentioned over here. So if I have written ID, first name, last name and salary, if it consists of 4 columns in the first query, the second query should also consist of 4 columns. Let's say I write in the second query as ID. I write the second query as first name. Let's say if I write, let's say not this, I had phone number. So I'll write phone number and I write what? Salary over here. Now you can see ID matching. The column position of first column is same. The column position of second column is same. The column position as well as the data type of third column is not same. The column position and the column name and the data type over here for the fourth column is same. The column count in query 1 is 4. The column count in query 2 is also 4. So when I execute it, you can see it's correct. But there is no phone number column created. I thought that phone number will be a new column created and it will show only for the query 2 results. But no, you can see phone number column has added over here. So the major reason why they required your data should have common columns, the same positions to the columns as well as a matching data is this. Because when it is combining the result of 2 select statements, you can see this kind of discrepancy can occur. And that's why the rules which are required for a union to satisfy is this, that you have to have the same column count or the same number of columns in all the select statements. It's not just the 2 which I have written. Secondly, you should have the column positions as same. The first column is ID, the second column can also be ID. Second, first name, last name, last name. So it becomes very easy to write it down. The third thing, the data type should be same so that it gives a proper representation of the data. But here it is not giving me a proper representation of the data which is there. So this is all you can see with respect to union. But what if now I'll change it to what? Last name, which is there, not last value, last name. And here when I run this query, you can see it is showing me correctly. Now instead of union, let me do union all. Do I have duplicate entries? Yes, because there were employees who were having salaries greater than 70,000 also available in the second query. So I'll copy the same query and I'll write union all. So all as a keyword, what it does, it will help me to get the duplicate entries also there in the data if possible. So when I run this, you can see 101, which is there. 101 is again repeated. Can you see 101 is again repeated into the data which is there. So duplicate records are shown into what? Into my union all. But union will not show me the duplicate entries between the multiple select statements. So that is how union and union all can work, and both of them can help me to get the result set and the outcome over here. Now intersect. What is intersect? Intersect is a set operation in SQL that returns only distinct rows, that is a matching rows that appear in both result sets of 2 select statements. The result set of intersect operation only consists rows that are common between both the select statements. You can see select column 1, column 2 from table 1, intersect table 2. But MySQL does not support select operator, which is used to combine results of 2 or more select statements and return a common result, which is there. For intersect, we can take help of inner join or in as an operator or subqueries to get the result over here. Now, let me try and show you how I can combine data from more than two select statements. Now, many people think that we can combine data in union only with respect to two select statements. The answer is no. I can combine data from more than two select statements. So, if I write select star from employees and I want to know where, let's say I write select star from employees, which are there. So I show this table, and what do? I will group the data. So let's say I had where, and I'll write department ID in. So I'll take two departments, D1, D4 and D1, D5 and D4. So these are the three departments which I have considered in the first one. Let me group it by. So here I'll write department ID, which is there, and group by. I'll group the data with respect to department IDs which are there. So it will show me the three department IDs, and I'll write count of employees in each department. So here you can see D1 has 3, D4 has 5, and D5 has 4 number of employees working in them. Now I'll write select, same query, which is there. So department ID, I'll write count star from employees, where in the second query it took only those departments where the salary is greater than 50,000. It took only those departments which are there. So which departments have salaries greater than 50,000? These are the departments. Now I'll create group of them. So group by. So group by what? Group by department ID, which is there. And then I'll do count star. That is count the number of employees which are there. Here you can see D3, D4, D5 is there, and I have one more select statement. Let me write that over here for you. So I have select this. So I have this, and in this, let me write a condition where, let's say, we have job title, and I'll write a like operator, like, and it has something related to sales. Anywhere, job title has something related to sales. And when I run this query, here you can see this query results D3 and D4 as a department having count as 4 and 1. This query results what? Results D3, D5 department, D4, D5 and so on. And here this query results this. So there are three queries which I have written, and I want to combine all the three queries over here. So I can write union between them, and I can write union over here. So here you can see this is how I am combining data from multiple select statement. So it's not like I can write only simplistic select star from table, and then I just take another table and just write simplistic where clause and combine the result set. I can definitely combine the data with group by result sets as well. So multiple select statement outcomes can be combined together with the help of union, and that's what we have seen so far over here. So union as a clause or it's not a clause, I can call it as an operator, which is used to help me to combine data from multiple select statements. It combines the data row wise instead of combining the data column wise. We have seen joins. Joins are combining the data column wise. More columns are added over here. Here, more rows are added from the select statements because it is combining the data row wise over here. So, this is just a practical example of how union alls would be working and how they will be showing the outcome. We also saw an example over here with respect to the table, which I brought over here with respect to theoretical part. Here, if I go and understand a very famous and a very popular interview question, and it has been asked a lot into interviews with respect to understanding the basics of the SQL. What is the difference between joins and unions? Can you help me to understand how joins and unions are different from each other? Now, many candidates have said that both are same. Many candidates have said both shows me same results or the same outcomes, but it's not like that. When I want to combine multiple data or multiple tables, where even though the column names or the column list are not the same, even though the data types is not the same, even though the number of columns in multiple tables is not the same, I can definitely do it with respect to joins. But union, as you know, there were certain rules which we need to ideally follow in order to show a union. So if you can see on the screen, I have table 1 in a light pink shade, I have table 2 in a maroon shade, and when I join it, can you see columns are extended over here? So all the columns from table 1, all the columns from table 2, when I use join, you can see 6 columns are being created. Union, on the other hand, what it is doing, it is not adding the data column wise, it is adding the data row wise. So records of table 1 or the query 1, records of table 2 are added or appended one below the another, or I can call it as concatenated one below the another over here. So with respect to structure, tables require a common or a shared column, whereas with respect to structure of union, tables require a similar structure, that is a similar column name, similar column count, as well as the data type. When it comes to appending, it appends the data column wise, which means it add new column into the data when you join. Here it appends the data rows, that is add rows into the data which is there. Now with respect to data, it widens the data. As more columns are added, it becomes width, the width of the data increases. Now it lengthens the data. As more rows are added, the length of the data would be increased. So here joins and unions are not same. Joins are used to combine data from multiple tables based on a common field, whereas unions are used to combine data from multiple select statements. So this was all about unions, union alls, or I can call it as a set operators. This is how set operators will work, and this is how joins will help me to show the difference, that joins and unions are different from each other, and joins and set operators are definitely different from each other. So this is all about the set operators which we have studied so far. So far we have studied about using queries related to filtering the data, relating to grouping the data, having it sorted, as well as aggregating the data, creating aggregated outcomes, as well as a lot of queries related to joining two or multiple tables as such. But every time I was only using one select statements. But what if my query consists of two select statements which needs to be worked together, or more than two select statements which needs to be worked all together in order to generate the outcome? For that particular point of view, there is a next topic which we are going to study. The topic of discussion which we are going to have over here is nothing but subqueries. Now, you all must be knowing the meaning of a query. Now, what's a query? Query is a request for data from the databases. Now, what is a subquery? Subquery is nothing but, so what is a subquery? A query within a query is known as subquery. So that is the main point of using a subquery which we are going to learn. Today, here we understood it in a very simpler terms. Let's try to understand in more detail that what is the subquery and how we are going to use it for generating the result set, which is not dependent on one query or the one query result set, and it's dependent on multiple queries to be used at once. So, if I want to talk and discuss about subquery, what's a subquery? A subquery in MySQL or in general SQL. Now, why I have written MySQL? Because we are working on MySQL as a server. So, a subquery in SQL or MySQL is a query which is nested into another SQL query and embedded with select, insert, delete, or update statements along with the various operators. Now, it can be used with your equals to, in, not exist, and n number of operators which are there at our end. Now, we can also nest the subquery with another subquery. A subquery can have one more subquery within it. So, they can be nested within each another. A subquery is also known as inner query. Now, what's an inner query? A query which is inside. As you can see in the image which I have brought over here, there is an inner query. There is a query within a query, and that is known as subquery. So it's nested, and the query which contains subquery is also known as outer query. So a query within which a subquery would be stored is known as outer query or the parent query. If you can see in the image which I have brought, it is being showing. The inner query executes first, gives the results to the outer query. So it is helping me to understand how does a subquery works. Now subquery works by running the inner query first, and whatever result will be generated through the inner query will be given out, and that will be used by the outer query or the parent query to generate a result set for us. And the main or outer query will be performed and it will give us the answer. Now MySQL allows us to use subquery anywhere. Now what is the meaning of anywhere? We can use it within select, we can use it with the where, we can use it in the from and at multiple places. So MySQL will help me to utilize and use this subquery at n number of positions. And one thing which you all must be remembering, that no matter which subquery we are using or where we are using the subquery, it should be enclosed within parenthesis. Now what's a parenthesis? That is, it should be enclosed within round brackets. All subquery forms and operations are supported in SQL standard will be supported in MySQL. Now what is this? All the types of subqueries, whether it be a single query or a multi-subquery or a correlated subquery, all will be supported in your MySQL. Now why this statement is coming? You all must be knowing that when we studied joins, not all types of joins were supported in MySQL. But the SQL version in MySQL supports all types of subqueries to be used over here. Now I talked a lot about the definition and the technicalities which are there related to subquery. I know that theory cannot help you to understand that what is a subquery, how the subquery is helpful for us, and how the subquery will generate a result set. We'll see a practical example for the same, and we will also solve multiple questions based on the different types of subqueries which are there. But before solving a subquery, we need to know certain rules which must be followed when a subquery is being written. The rules which are there, first is subquery should always be used within parentheses. That is, it should always be stored within the round brackets or within the parenthesis, very popularly known. If you don't store it, it will not be acting as a subquery and it will throw us a result error which is there. It can also show us a syntax error because the syntax is not in the proper format which is supposed to be there. The second, if the main query does not have multiple columns for subquery, then subquery can only have one column in the select statement. That is, your subquery within a query will only have one column to be shown in the outcome. Your main query can have n number, but your subquery will always have one column. I'll explain all of them with a practical example. We can use comparison operators such as greater than, equals to, less than, in, any, some, and all. A multi-row operator is useful when the subquery returns more than one row. So, It depends that which kind of operator I am using when the subquery results more than one row or a single row as such for us. We cannot use order by statements. Now this is very important, that whenever a subquery is written, you cannot write order by within a subquery. It should be written in the main query, that is the outer query, but a subquery will never consist of order by statements, which is there. So as we now know subquery theoretically, as we also now know the rules to be followed in the subquery, let's try to see with an example. So here I have brought a table for you and there's a question being framed. And I'll help you to understand what does it looks, how the query would be written, what's an inner query, what's a subquery, what's a main query over here with the pen and paper logic, and then we'll understand it with respect to our code file as well as the SQL queries into your MySQL server. So, if you see the question, what is the question over here? This is a table related to employees. As you can see, there is an employee ID, name, department, location, age, number of trainings done by employee, KPIs met are greater than 80% or not, the experience of an individual as well as their salaries. Now, what's the question? Filter out those employee details who have salary greater than the average salary. Now this is a question which I need to solve from the table which is provided to me. Now imagine this table name is employees, which is there, and I try to solve this question over here. Now you all must be knowing, if this kind of question is coming, filter out, which means definitely I want to filter out the data. So I can use where as well as having. So filter out those employee details. So I want to filter out the employee details of those employees who are having salaries greater than average salary, which means I don't want to return an aggregated data, that is the group by data. I want to return each employee details where the salary is greater than the average salary of all the employees, not related to any group. It's an individual row filtering which I wanted to do. So I can use a where clause over here. And how I will write the query. First of all, when this kind of question comes, what people do is they will start writing. Let me change the color over here. They will start writing select star from, let's say the table name is what, employees, and I'll write what, where the salary of the employees. Definitely I want to filter out what salaries of the employee. Salary is greater than, let's say if I do average salary. If I write the query like this, and many people have written the queries like this, what is the problem in this query? Is it going to give me the result set which is required, or it will show me error? Definitely, if you have understood the where clause, this is not an ideal way to write where clause. Why? Because where clause never use aggregated functions. That's your min, max, average, sum, count to filter out the data. Why? Because aggregated functions are never part of your where clause. So this query or the result from this query would not be generated. The response would be an error. That is invalid use of group function. You have used the group function or the aggregated function in a wrong manner. So this is a wrong query. So I cannot solve with this approach. Definitely I want to solve it with the where clause, but I am not able to solve it over here. So what I can ideally do is, I can use the query results. I can break the question in two parts and try to solve it over here. Let me clear it out. So let's read out the question again and let's see how the question would be broken into parts. Filter out those employee details who are having salary greater than the average salary. First of all, I need to know the average salary of the employee. Now, what's the average salary of the employee? If I do select average of salary from what? From employees. So this query over here is going to return the average salary. This is a simplistic query to find out what? To find out the average salary calculated or scored or achieved by the employee over here, or being paid to the employee over here. Now, what's the average salary? Definitely, I'm not calculating it. I'm roughly saying that the average salary over here is 37,000. So, the output of this query is, let's say, 37,000. Again, I said that I'm not calculating it. I'm just roughly considering that average is coming as 37,000. If you want, you can calculate, but it's not an actual table which is there at my end. So, I have said 37,000 is the average salary for the employees of the data which is possibly available to me. Now, I want to find those employees who are having salaries greater than 37,000. So, how can I write the query now, the modified query over here? It would be written as select star from employees where. Now, I'll write where salary is greater than what? 37,000. So I'll write like this. So it will go to the data and it will filter out the salaries which are greater than 30,000. That is this employee, 37,000. This employee, and this. So 4 employees details are found. But this 37,000 is a static value. If there are 2 more new employees added, they will definitely have salaries with them and the average would change. But my query over here will still calculate for what? 37,000 greater than salary over here. So let's say 2 more new employees are added. Here there is 49,000 as a salary added and 60,000 as a salary added. And my average over here is now not 37,000 but changed to, let's say, 42,000. Change to, let's say, 42,000. Now, I cannot filter out the data over here where the salary is greater than 37,000. I have statically written 37,000. So, here also every time I have to manually change what? 42,000. And then it will give me result set for the same. But it becomes difficult for us to manually change n number of times when new data is being added. So what I can do, I can use a subquery in order to solve this problem. How? Let's try to see. Okay, imagine that I am writing a query over here that is select star from employees. That is a result which I need to get in the output. I want all the employee details where. Now where I am writing what? Salary. And what I want, when I am trying to equalize the value, I want the average of the salary which is generated by this query. So instead of writing a static value over here, what's a static value? A fixed value. Can I write the query instead? So I'll write greater than, and here I'll write what? Select average salary from what? Employees. Now instead of writing a static value over here in the where condition, what I have written another query. A query which gives me the average value so that can be used by my another query to get the result set. But the query approach over here is still wrong. If you remember the rules which we mentioned for a subquery needs to be written in a parenthesis. Now what's a subquery over here? A query within a query. Which query is a within query or inside a query? This query where the average of salaries is calculated for the employees. So this is my within query and I have to formulate it into what? Into brackets which are there. So here you can see this is a query. Within this query there is one more query which is being acted over here. So whenever I run this query, first my inner query will give me what? The average salary from the employees table, and that value will be used to filter out the outer query results which are there. Well, like similar to what we have done by writing two queries separately. First, I calculated the average salary and that I used for finding out the employee details. So the same thing is happening, but instead of putting a static value, my query is being written over there so that it generates the outcome every time without mentioning any static element over here. That's how subquery works. That's a simplistic example of what a subquery happens. Now, let me name this subquery, which one is subquery, which one is main query, and what actually happens when the result is generated. So, as it said, the query within a query is known as what? Subquery. So, this is known as what? A subquery, which is there. Now, subquery is also known as what? Inner query. It is also known as what? Inner query. And this is also known as an independent query. Now, what's the meaning of an independent query? This query is not dependent on anyone. If you run this query separately, this can work. Now, what does it mean? Let's say if I run this query, select average salary from employees separately, is it going to work? Yes. So that's an independent query, my inner query and subquery over here. Now, what's this query known as? This query is known as what? An outer query for us. Also known as what? A main query. Now, what's the meaning of main query? Because this query is going to get us the result set or the outcome which is required. And this is also known as dependent query. Now, what is the meaning of a dependent query? Dependent query means the outer query is actually dependent on an inner query, so that the result of an inner query would be used to generate the outcome. That is known as what? A dependent query. Now, how does it actually works? When I'm writing this query over here, first it will run the inner query. Select average salaries from employees. So it will calculate the average salary. Let's say the average salary is 42,000 now after inserting two new employee details. And this 42,000 which is generated from the inner query will be used to filter out the data from the outer query. Now, salary greater than what? 42,000 would be filtered out and then you will get the result set. So, which is the data? This one, this one, this one and this one as well as this one. So, these 6 records are going to be shown into your outcome when this query is going to execute for us. So this was a simplistic show, a simplistic example on how a subqueries are going to be written, on how a subquery is going to execute and how a subquery looks like when it is written into the query. Now we will see practically that how all of them would be utilized into queries. Let's solve some questions. Let's see the types of subqueries which we have and let's try to see which subquery is ideally used a lot. So here, when I go on my screen, as you can see, subqueries are queries embedded within another SQL query. They are typically used to retrieve data that can be used in the outer query to perform operations. Subquery allows more complex data retrieval and manipulation. All the complicated logics we can write and manipulate the data and generate the outcome for the same. Now, as we saw the example, let's try to see the same example over here. Select star from what? From employees. So I have employees table. I have companies database where there are 4 tables: departments, employees, time, projects and timesheets. So I have data related to employees as you can see. I want to find out the employees having greater than the average salary. As I showed you, the same way I'll show you over here, which I showed you on pen and paper. As I discussed that if I write where clause and aggregated functions directly into it, it is not going to show us the result set. Like where salary is greater than average salary. Let's say I'll write average what? Salary, which is there. When I run this query, when I execute it, can you see what it is showing me? Invalid use of group function. Why? Because you cannot use aggregated function into your where clause to filter out the result set. It is a saying of where clause that you cannot use. When I try to use having over here and run it, What it is telling me? Inaggregated query without group by. So it's incomplete for us to run. So where and having could not be used. Now definitely I don't want to use aggregated record filtering. I want to filter out the data row wise. So when I want to filter out the data row wise, I need to use a where clause. So first let's find out the average salary of the employee. What's the average salary of the employee? I'll write select average of salary from what? From employees. I do this. So you can see this is an average salary which is being given by the employees. I'll right click. So I'll right click. I'll copy the row which is there. And what I will do, I'll paste it over here. Instead of average salary, I'll paste the value. What's the value? 516.667. This is the average salary which I have calculated. So the employees having greater than average salaries are found. What if I try to fill in the details of more employees over here? The average is going to change. So when the average is going to change, definitely I want this query to also not use a static value over here, but use a dynamic value over here. That is, let's say I have employees table over here and I'm changing the salary. Where let's say its job title is sales head and he belongs to department D3. I'm changing the salary. So let's say I'll write update salary set. Salary is equals to, let's say, 65,000. Over here, where the department, let me see what it is showing. Department ID is D3, job title as sales head. So where department ID is equals to D3 and here the job title which is being given is nothing but sales head over here. So when I run this query, okay, salary, it's not, it's employees. So when I run this query, it is changing, and if I see the employees table, you can see where it was sales head D3, it has changed to 65,000. Now if I check the average salary which is there, what's the average salary? 52,142. So if I want to now filter out the data greater than the average salary, definitely I cannot go with the static value. So I have to use the query which is giving me the average salary instead of inserting a static value. So here I'll copy this and paste it over here. So this is a query which is helping me to get a result set. When I run this, it is telling me that it's an SQL syntax error. Why? Because a query which is written within a query, you have to put it into parenthesis. If you remember the rules, that subquery will always be written within a parenthesis. So I have written this. So what will happen? This is my inner query. That is an independent query. So if I run this query separately, it's going to execute and give me the result sets. Just a second. Yeah. So if I run this query independently, it is giving me the result sets. And this is my outer query or the main query on which my result is dependent. So when I run this, this is how it works. So this is how my inner query and a basic approach of subquery would be written with the same example which we saw on pen and paper. So as we have seen the simplistic approach of how a subquery works, let's try to understand what are the various types of subqueries which we can use, which we can write and generate the outcome for the same. So subqueries can be categorized into different types based on their structure and the number of rows they return. Now the main types include, first is a single row subquery. Now when a subquery returns one row, that's a single row subquery which is being called. So a single row subquery returns only one row as its result. It is commonly used with comparison operators like greater than, less than, equals to, and not equals to, or it could be greater than, equals to, and so on. Now, multi-row subquery. What's a multi-row subquery? A multi-row subquery returns more than one row as its result. It is often used with operators like in, any, and all, which are there. Now, there is a correlated subquery, slightly different from what we have understood with respect to subquery. We will see that how does a correlated subquery works. Correlated means the subquery is related. As of now, what we have studied that the subquery is independent. But when a correlated subquery comes, it becomes a dependent query over here. So a correlated subquery references column from outer table and it is executed once for each row processed by the outer query. This type of subquery depends on the outer query for its values. So it's dependent subquery. It's not the independent subquery which we have seen. So correlated subqueries are slightly different from whatever subqueries which we have studied so far. Let's try to understand them. Now, as we have seen a single row subquery, what does a single row subquery says? A single row subquery returns only one row as its result set. So it is going to return only one row for us. Now imagine, find the employees belonging to, let's say, sales department with a subquery. Now if you can see the question, that what they want over here, that they want an employee's result to be given which are belonging to sales department, where now you have to do it with the help of subquery. Now this is a question which is available into two tables, that is select star from employees. Now if I do select star from employees, you can see that I have employee ID, first name, last name, email, phone number, hiring date, job title. I have department ID instead of having department names. And then there is what? A salary which is being given. Now I want to know the department ID of the sales department. So let's say I'll do select star from, let's say there is a table known as departments. If I do this, you can see the sales department is D3. So when I want to find the employees belonging to sales department, definitely I can do it as select star from employees, where let's say department ID is equals to D3. So I'll get those as department employees details. So all the employees who are belonging to department D3 are being shown, that is they are from the sales department. But as I said, I don't want to be stick to static values or a fixed value when my query is being generated. I want to use a subquery over here. Now I can do the same thing with the help of joins in a more easier manner. But as it is said to us that we have to use a subquery, let's try to use a subquery over here. Now we will also understand the rules which were mentioned by us related to subqueries. Now what it is? First of all, let me go to the departments table, select star from what? From departments, which are there. So I went into departments table. I want what? I want the data related to the sales department. So where I write, where the name of the department is having a value equals to what? Sales. And here you can see which department is related to sales, the department D3. Now I want this department ID to be matching with the employees details table over here. So I will write something called as ID, that this ID I want to match with the department ID from my employees table. So here if you can see, this query I will be using into as a subquery that is within my table. So how am I going to use it is select star from employees where the department ID is equals to. Now equals to is used when you use single row subquery. Why? Because equals to, greater than, less than are used to filter out the data based on one value. Now the subquery which I will be using over here is this, is returning me one value, that is the department ID as D3, and as it is said, subquery is what you have to write into a parenthesis. So according to the rule, I have written in parenthesis. Now it was also mentioned that your subquery cannot have multiple columns. Your subquery will have one column. If I write multiple columns, select star from departments where name is equals to sales. When I do this, you can see operand should contain one column. So that is operator should contain one column as an output. It is having multiple columns over here in order to filter out the data. So department ID should match with the ID of the department tables. So as per the rules, if you can see, what were the rules? The rules were your retrieval, just a second, yeah. What were the rules? Your main query does not have multiple columns, but your subquery should only have one column. It doesn't depend on main query that it has multiple columns or not, but your subquery should have one column. That's a mandate thing which is there. And as per the rule, I have written over here, that's one column. It is being used to match the data from the main query. So here you can see it is giving me data related to which department? Sales department. Now what is this query? This is a single row subquery. Why it is a single row subquery? Because when I take this inner query or my subquery and run it over here, it's returning me one value or one row. When your subquery returns one value or one row, it's a single row subquery. So this is what we have performed so far with respect to a single row subquery, and this is how it works. It uses equals to, greater than, less than, and so on. So this was a single row subquery where it returns only one row as its result. And the operators used are equals to, greater than, less than, as well as not less than equals to. So the query which we wrote earlier was also a single row query, because when I execute this subquery, it was returning me one row over here. Now let's say I want to find the employees from 3 departments. I want to find the employees. So I'll say find the employees from sales, HR, and let's say finance department. So I want to find employees from sales, HR, as well as finance. So how will I be able to find it out? Select star from departments. Let me see, do we have these departments or not? If you can see, I have HR, I have sales, I have IT. So when I say that where the name is equals to sales or the name of the department, now or it can be either sales or HR or finance. So or let's say I do HR, or I say the name of the department is what? Finance. And when I execute this, you can see my query is returning me 3 results. I want their IDs to be used over here. So when I use this, my query, which will be used as a subquery, is returning not one row, it is returning multiple rows for me. So when I write the subquery over here for this, I'll write select star from what? From employees where, and I say department ID, which I want to match, and I do equals to over here, and I write this query as a subquery. So I write it and I execute it. It is showing me error. Now subquery returns more than one row. As you know, when I run this query, which is used as a subquery, how many rows it is returning? Multiple. So it's a multi-row subquery which is there. So for a multi-row subquery, we never use equals to. You all must be remembering, when I want to filter out multiple datas from one particular column, we studied an operator known as in. So in as an operator will help me to filter out multiple records from the data. So when I run this query over here, you can see the employees belonging to D1, D3 department which are there. So here a multi-row subquery has run. Multi-row subquery returns more than one row as its result. It is often used with operators such as in, any and all. So if used it with the help of what? In, because my subquery was returning more than one row for us. So this was a multi-row subquery. So as we saw, example related to how a single row query will generate an outcome for us, how it would be written, how a multi-row query will generate an outcome for us, and how it would be written. Let's try to create and let's try to solve certain problem and also understand what is this correlated subquery and how does it works. So find the details of the employee who have spent maximum hours on the project. So I want to find out the details of the employee who has spent some hours on the project, and that hours are what? The maximum number of hours which are there. So let me first see the data which is available to me. So definitely when a question comes to you, you have to break it down into parts. The first part is find the details of the employee who has spent maximum hours on the project. So I need what? I need the details of the employee. So the first table of consideration over here is nothing but the employees. So select star from what? From the employees which is there. So I'll select the employees data which is available to me, and this is the data where I have first name, last name, email, but there is nothing related to hours which has been worked upon by the individual. So let me see which table will have the information for the same. As I showed you that I had a company database where there are 4 tables. So first table is employees where I get the employee related information. So find the details of the employee who has spent maximum hours on the project. Let me see the projects table. Does it consist of anything related to the hours spent by the individual? So I'll do select star from what? From the projects table. So it will show me all the data related to the project. That is the name of the project, the description, the start date, end date, and the department which is working on this project. But definitely it is not giving me anything related to the hours. Let me see the timesheets table. I think so. There is the project related information on the basis of the hours spent by the individual. So if I do select star from timesheets, yes, you can see that there is hours related information from the same. Now what it is asking me? Find the details of the employee who has spent maximum hours on the project. I want to find out the maximum number of hours spent by the individual on the project, which is that employee. So let me first find what is the maximum number of hours spent over here. So in order to find the maximum hours, I do max, and I cannot write star, as you know that maximum would be calculated for a particular column. So which column I want to calculate it for? Hours. So maximum number of hours, you can see what are the maximum number of hours spent by the individual over here is 9.50. Now I want to find which is that employee who has spent 9.5 hours. So in order to find out that, what I will do over here is, let me see which employee is there. Select star from timesheets. where hours. Now I'll see from timesheets which is a table. Hours is equals to the maximum number of hours. So this is my inner query which is giving me one single result set. So it's a single row query result which is being generated, and this will be used by the outer query to give me the outcome. As I've said, a subquery needs to be mentioned into what? A parenthesis or a round bracket. When I execute it, when I run it, you can see 9.5 hours were spent by an individual where the employee ID is 112. So I want to find the details of the employee who is having 112 as an employee ID, which is there. So let us write a query for the same. So this entire query, I'll say that employee ID which I want to find is 112. So I'll go into my select. Now this entire thing is going to act as a subquery. Why? Because it is giving me the answer for the employee ID 112 who has spent maximum number of hours. So how I can do it is select star from employees. I've written select star from employees. I'll do where the ID of the employee is equals to, and I'll do that select. So if you can see, let me beautify my entire query. How to beautify? Select it, this one, I'll select this one, and I'll try to beautify it. So when I click on beautify, just a second, why it is not beautifying? Let me write it down correctly. Okay, this entire thing is a subquery for me. So I'll try to beautify over here. So what is happening? Let me talk upon this and let me help you to understand the working for the same. Now what is the question? Find the details of the employee. I want to find out the details of the employee who has spent. So who has spent what? Spent maximum hours on the project. I want that employee to be shown who has spent maximum hours on the project. Now what were the maximum hours which were spent on the project? If I run this query, I'll get what were the maximum hours spent on the project. It was just a second. It was 9.5. So what were the maximum hours spent on the project? 9.5. But I don't know which employee ID did spend those maximum number of hours. So I wrote a subquery which will show me the maximum number of hours spent by which employee, which is that employee who has done the same over here. So I'll run this query. It will show me which is that employee who has spent maximum number of hours over here. The employee ID 112 is the employee who has spent maximum number of hours. I want to find the details of that employee over here. So select star from employee over here. You can see the main query is this. The main query is this. My subquery is this. So if I show you with respect to the details, let me talk upon the details over here. Okay, if I show you that this is a data which was there, let me hide this. So this entire thing, select star from employees. That's my main query. What it is? It's my main query. And here this thing is my subquery. Or the nested query. What is the meaning of nested? That is within. So a nested query which is there, or I can call it as an inner part, or the inner query which is being executed, and this is my outer query which is being executed. So if you can see the data, my data is dependent on the outcome of this to find out which is that employee who has spent maximum number of hours. Now it's not mandated that your inner query will only have one query. As you can see, my inner query has two queries mentioned over here. That is, first it will calculate maximum, then it will give me the ID of the employee who has spent maximum number of hours, and then it will go to the outer query to generate the results set. So inner query results will be used by the outer query to generate the result set which is there, and this is what it is known as the data. And this subquery is known as independent. As I showed you, running those queries independently, when I run those queries separately, is it giving me the answer? Yes. So independently executing. So this is an independent outcome which is there, and this is how your subqueries are working, which we have understood. It is also a single row subquery because each subquery over here is returning one single result set or one single record which will be used by you to execute or generate the outcome. So I hope we are clear with the same over here and how multiple subqueries will be used in order to generate the result set. So this was the answer for the first question. So which is that employee who has spent maximum number of hours on the project? The employee name is Abhishek Patil, and he is having a job title as senior analyst belonging to department D5 and having a salary as 75,000. So this is how we have used the subquery over here. Now find those employees who have altogether spent more than average hours. Now what is the meaning of this? Just understand the question over here. Find those employees who have altogether spent. Find those employees who have altogether spent more than average hours. Now I want to find how many total hours were spent by the individual and which individual spent more than the average hours given over here. Now how will I do it? First of all, let's try to solve the question over here. It is asking me the data related to the hours spent. Let us first go to the employees table. As you know that it is related to employees. So when I go to employees table, it has information, but it doesn't have anything related to the hours spent. Now if I do select star from timesheets, if you know that timesheets is a data which has related to the hours spent, you can see each employee on a different day has spent different number of hours. I want to find all together hours spent. Now how will I do it? You all must be knowing that we have something called as group by, which will tell me the total number of hours spent by the individual. So what I am doing, select star from timesheets. If you can see, it's there. I will write a query. You all know I will be doing what? Group by. I will be grouping the results. So I will be creating aggregated data. So I'll do where from what? Timesheets which is there, and I don't want to do, I want to group the data. So I want to group the data on the basis of what? On the basis of employee ID. So I'll say that I want to group the data with respect to employee ID. As I've discussed when we studied group by, the column which is used in group by, the same column would be a part of my select. So I'll do employee ID which is there, and what I want, it shows me the IDs which are there, but what I want the total number of hours spent by them. So I do sum of what? Hours, as let's say I'll write a column name, what it is? Total hours. So I write the same. So what was the altogether total hours spent by the individual? What is the total hours spent by them? That is what? Employee ID and total number of hours. 101 as an employee has spent around 29 hours working on the project altogether. 102 has spent around what? 34. 103, 104, 105 and so on would be used. Now I want to find out what the average of total hours. How will I find out? Do you think so that if, let's say, I do having total hours greater than the average hours, average total hours, if I do total hours is greater than the average total hours, it's invalid. Now you cannot filter it in this manner into your having clause as well. Your total hours is already an aggregated function, and your value which you want to spend over here cannot be this. Cannot be this. I want to find out which employee has spent more than total hours altogether. I cannot find it in this way. That's incorrect, because total hours is already an aggregated function. I cannot do greater than this over here. So that needs to be more filtered out. That needs to be more enhanced over here, and let's see how it works. So I cannot use having in order to filter it out. So I want to use the result generated by this query to find out the average of total hours. I cannot use it directly. I cannot write select average hours from and directly a table name. Why? Because this query is not stored anywhere. This query is just simply there with me. So I want to generate an outcome based on the grouped table which is stored nowhere. So I will show you an approach of writing a subquery into my group by. How? Or into my from. How? If I write select average of what? Of total hours which is there. So total hours, and from where I want to find out this total hours. Now there is no table. The query result which I generated from group by, I want to use it as a table. So I will mention this entire thing as my subquery. This entire thing will be used as a subquery. But when I run this statement, you can see it will show me an error. What's an error? Every derived table must have its own alias. Now from, we write a table name instead of writing a query. So the query which is being written, it's not a table which is there. I want to write a name of the table over here. So this query will represent, so I'll give an alias. This alias is what? Hours. So the table name is hours which I have given. Hours spent. Let's say I give hours spent as a name. And when I run this, it will give me the average number of hours altogether spent. What is the data related to that? So average number of hours which are spent over here. So you can see that what are the average number of altogether hours which are spent, that is 30.25. If I just find the average over here, select average of what? Hours. From timesheets, it's 5 average hours. So it's an individual. But the average hours which are generated now is related to the total hours altogether which are spent. So this is how we can get the average hours. Now what is the question? Find those employees who have, what is the ask of the question? Find those employees who have altogether spent more than average hours. So I will use the average which is generated by this query. So I'll write the same query over here. Select by employee ID. See, so I'm writing it over here. That is select employee ID, sum of hours as total hours from timesheet, group by employee ID, and I'll write what? Having what? The total hours. Total hours greater than. So here you can see it is showing me the employee who has spent greater than what? average number of total hours altogether. The average number of total hours altogether were 30 point something, and it is showing me those employees who have spent more than average number of hours. Now if I want to find employee details, you can modify it further, that you can only get the employee IDs over here, and the employee IDs which you get, just a second, yeah, it's a having part, so I can still modify, or I can use it as a table and then get it sorted as just say total hours which are there over here. And after this I can write a join statement to get the employee details over here, so that I get those employee details, the employee names as well as their IDs which are being used. So let me join. So I'll do inner join. What? Employee details. If I want employee details, I'll write employees as E, timesheets as T. So let me join on E.id is equals to T.employee ID. So if I want details related to the employees which are there, so when I run this, it will show me first name, last name as well as the total hours spent by the individual. So in the group by, I can write the first name, the last name, and the columns which are there into my group by, the same columns would be a part of my select. So I'll write first name and then I'll write last name, you can see comma, and I'll do sum of hours. So this is an employee who has spent more than how much? 30 hours. That is an average of altogether hours. Now how this query has formulated, let me help you understand the same. I know it's complicated. Subqueries can add a lot of complexity to your outcome, but it ideally helps you to solve all the complicated logics which are there. The question was not complicated, but the answer became complicated when we tried solving it. Now what was the question? Find those employees who have altogether spent more than average hours. So first of all, I went into finding out the altogether hours over here. So this query is giving me the total hours spent by each employee. Now I wanted to find an average of this total hours. I cannot do it directly because this is not an actual table. This is a group table which is being generated. So in order to find the average of this, but this is not an actual table, I have written the subquery into from. So the result of this query will be used as a table. So from, we know the table name, but I didn't have a table name, so I have written the query. But whenever in from you write a query, you have to give them aliasing, because a table name needs to be there. So what's a table name? Hours spent. So this query is represented as hours spent. So I want to calculate the average total hours spent by the each employee over here. So if I run this query, it will give me what as a total altogether average hours spent. It's 30.25. So it is giving us the outcome over here. Now I want to find the details of that employee who has spent all of this hours. So I have selected two tables. First is the employees and the timesheets. I've joined it and I've grouped the data on the basis of employee ID, first name and last name. So it will give me the employee ID, the first name, the last name, the employee consists of the total hours which are spent by them, and I am calculating what? I'm calculating the total hours which are greater than what the average total hours over here. So this is how we can get the result set, and this is how the result is generated related to the employees who have spent more than average number of total hours altogether. So as you saw that we have solved some questions, so let's proceed with the next question which is being asked, and we will solve it with the help of subquery. Now what is the next question which is the ask over here? Find those projects which are available in the timesheets table. Now obviously I have data related to the projects, I have data related to the timesheets. Now let me show both the tables for you. Select star from projects. Now projects table consists of what all projects? were given to the organization or for the company to work upon. So here you can see there are 6 projects in total named as P1, P2, P3 and so on. And there are certain names of the project, their description, start date and end date, that when the project actually started and when it actually ended. And then we have the departments working on those projects. Now what I wanted over here, I want to know which projects are available in timesheets. Now definitely these are the projects which are given, but not all projects information or not all projects working hour are being traced into timesheets table. Let me see, select star from which table I want, timesheets. So let me see, now in the timesheets table, yes, we definitely have project ID over here. Let me see which project do I have. So projects ID. So what all projects do I have? Now multiple records are coming. I want to show the unique project IDs available into the timesheets table. Now what should I do is I should do distinct. Distinct what? Distinct project ID over here. And when I execute it, you can see that P1, P2, P3, P4 and P5 is not there. We had a P5 project over here. If you see the projects table, that we had a P5 project which is attendance regularization, and in the timesheets the data related to P5 project is not there. We had 6 projects in total and 5 projects data is available. Now find those projects. Now understand the question over here. Find those projects which are available in timesheets table. Now I wanted to know only those project names which are available into timesheets. I can definitely do this question with the help of a joins, which we have studied. But let's try to utilize it with the help of subquery, and let's see how does a subquery works. So over here, the project IDs which are available into my timesheets table, I want this IDs to be matching to the projects table and those project information should be given to me. So I will use this query with the IDs of the projects available in timesheets as my subquery, that is my inner query, which will help me to get results for the outer query, that is the project names which are there. So if I do select star from projects, that's the query, and I'll write a where condition. Where what? Where if you see the ID from the projects table should match the ID of the project ID table from the project ID column from the timesheets. So I'll write ID and I'll write equals to. In this equals to, I'll write this query. I'll write this query which gives me those project IDs. So I'll copy this query over here. And as you know that subqueries are always written within parentheses. So I have written it within the parentheses which are there, and this will definitely give me error because it's a multi-row subquery. What is the meaning of a multi-row subquery? My inner query is resulting multiple records, not one records. So I'll write an operator known as in to match the data based on multiple records. And when I run this, can you see the outcome over here? Now let me, so here can you see the project IDs which are there. So we have got P1, P2, P3, P4 and P5. P5 is not there. P4 and P6. P5 is not there because P5 related information was not available into timesheets. So the question was find those projects which are available in timesheets. So these are the 5 project details which are available into the timesheets table. So here you can see my subquery over here is this, which is returning the distinct project IDs from the timesheets, and those project IDs are used by the outer query to find out the names of those projects from the projects table. So this was a subquery which we solve over here, and this is the data, this is the outcome which it is giving. So based on the questions which we solved so far, the subqueries were the subqueries which we used over here, we solved a lot of questions over here. So the subquery was independent in nature. What is the meaning of that? Independent in nature, which means if I run this query, if I execute this query separately, it is going to execute for me and it is not showing me any errors over here. But if you remember that in the types of subquery, we also had something called as correlated subquery. Now, what is the meaning of correlated? Correlated means a related subquery. A subquery will have relation, or I can call it as a dependency. Now, as I was telling you that subquery is independent in nature. How come a subquery can become dependent? Or it can be dependent on the outer query which is there. Let's try to understand it over here. So, a correlated subquery references columns from the outer query. So it takes data from the outer query, and that's why it becomes dependent on the outer query and is executed once for each row processed by the outer query. Now what does it mean? Let me tell you with a simplistic example for the same. Now this type of subquery depends on the outer query for its value, which means this subquery is not independent in nature. It is dependent in nature. So far, if I take the example of the last query we wrote, if I need to write for the same, just a second, yeah. So this part is known as my inner query. This part was known as what? My inner query. Also was known as more the subquery which was there, and this was independent in nature. Now what is the meaning of that? Independent in nature, which means if I run this query separately, I can get the answer of the query which is there. And this was my outer query. I can also call it as a dependent query. Why a dependent query over here? Because this query was dependent on the inner query result which was there, and that was also known as my main query, because this is a main query which gives me the result sets or the outcome over here. Now in this, my inner query was executing only once. Now what does it mean? That when I run this statement or this query which I have written, the inner query will execute once, and the answers or the outcomes of the inner query will be used by the outer query. The inner query is not going to execute n number of times for each row of the outer query. It is going to be executed only once. But there will be certain correlated query which will show correlation between inner query and the outer query. So, the major difference between an correlated and the so far studied queries which we know is non-correlated subquery, this executes multiple number of times. Means if you have 10,000 outcomes in the outer query, it will execute 10,000 times. If you have 500 outcomes in the outer query, it will execute 500 times. So for every outcome, for every row of the outer query, the inner query is going to execute. And non-correlated subquery is something which executes only once. That's the simplistic difference over here. Now the subquery, query within a query is known as subquery. The subquery over here is also known as dependent. So subquery is dependent. What is the meaning of that? that this query is going to be dependent on the outer query. But so far we have studied that subqueries are independent. So far we have studied that subqueries are what? Are independent in nature. So there are special cases when this correlated subquery is used. Sometimes it can be computationally heavy, and sometimes it can help us, or it can consume a lot time to generate the outcomes which are there. So it's not always preferred approach, but let's try to understand correlated subqueries with the help of two examples which I have over here. Now imagine the question: fetch employees who earn more than average of their departments. Fetch employees who earn more than their department's average salary. Now imagine I have employees table over here, and this table has a lot of information. What kind of information it has? It has employee ID, which is there. It had employee name, which is there. Let's say they have employee salary over here, and we have something called as department over here. I want to know now employee ID 101, 102, 103, 104, and 105 is the employee's details. Let's say name is A, B, and C. So we have the names of the employee. Let's say the salary over here is 3K, 4K. Just a second. Yeah. 3K, 4K. Now K over here is 1000. So 3K, 4K, or let's not write 3K and 4K, I'll write thousands to avoid the confusion over here. So let me write it as 3000, 4000, let's say 6000 over here, 5000 and 4500. A random salary, and let's say I write the department as admin, HR. Then here again this is admin, HR, and then this is what? Finance, which is there. Now what's my question? Fetch employees who earn more than their department's average salary. Now when my query goes and helps to find out the question for the same, let's say it goes with first record over here. Now first of all I need the average salary of each department. So here let's say department I made, and here I make the average salary. So what's the department name? Let's say I have department as admin, HR and finance. And I have the average salary for admin, 3000 and 6000. 3000 and 6000, 9000. 9000 divided by 2 would be nothing but 4500. Let's say I have 4000 over here and 5000 over here. Again I have 9000, so it's 4500, and finance department had that only. So let me write 4500 over here. Now I wanted to know which employee is having, fetch employees who earn more than their department's average salary. So which employee is having 4500 with respect to admin, then with respect to HR, with respect to what? Finance. So when I go with the first row over here, first row 101, then A 3000 with respect to admin. So it will go and run this query. This query will be executed. This will be my inner query result, and it will check the salary. Now definitely this is not correct, so this will not be fetched. Now it went into the next record, that is HR, and over here is what? HR salary is greater than 4500. So this query will be executed again. The average salary of the department will be calculated again, and this row will be compared now with this. This is not there, so this will also be not executed. Now it will go to 103 where admin, it will execute the inner query again for this particular column or this particular row. 4,500 is the salary, average salary of admin now they have got, and 6,000 is definitely greater than that, so this will be selected into the outcome. Now for the next employee, this inner query will execute again, the average salaries would be populated again. So here 5,000 which is there. Now 5,000 is definitely greater than 4,500, so this will be executed. Now 105, see 4,500, you can see it's not greater than, it's just equals to, so this will not be executed. So which two employees have salaries greater than their department's average salary? It's the employee number 103 and 104. But over here for each row check, the inner query was executed that number of times. So I had 5 rows in the outcomes in the outer query to be checked. So inner query will be executed 5 number of times. So that is the simplistic difference between the non-correlated, which we have studied so far, and the correlated subquery. Now let's try to write the same thing with a code, and let me show how does a correlated subquery looks like. So when I go over here and when I do select star from, let's say, employees, which I have. So we had employees table. Here you can see all the employees which are there, and I wanted to know the department wise average salaries over here, but I don't know which employee is earning more than their department's average salary. I want to find out the department's average salary. Let me do it over here. So I'll create group of what department IDs, and I'll find out what average salary which was there over here, and then I'll do what group by with respect to what the department IDs which were there. When I execute, you can see this is being shown over here, D1, D2, D3, D4, D5 and D6, D7, nothing is there. So there is an empty. With respect to that, their average salary is what? 0 over here. So here you can see this is a data. Now for D1, those employees are having salaries greater than 40,000 would be fetched. For D2, those employees having salary greater than 30,000 would be fetched. For D3, greater than 57, greater than 66, and then over here greater than 35, that will be fetched. So in order to run this query, first of all, what do I want in the outcome? I want the employee details in the outcome. So my main query will be select star from employees. Now definitely the same table I'll be using in my inner query over here. So I'll name it as a table known as outer, or let's say I'll write outer table over here, and where I want to compare their salaries. So I'll compare what salaries over here should be greater than. So fetch employees who have more than their department's average salary. So I'll do this. Now here, can you see this? I'm writing a subquery, but the subquery is slightly different. So I'll do select average what? Salary, because salary, the average salary from the inner query will be used by the outer query over here. Salary from which table? From employees. From employees, and I'll write a condition where employees dot department ID. So the department IDs of employees should ideally match with the outer table dot what department IDs which are there, and I want what? I want the group by result with respect to the department IDs. So I'll create department IDs group by, and these are the two employees who are having salaries greater than the department's average salary. Now what is happening over here and how this query is different from what we have studied so far? Just observe this very carefully, that what I have written. So this entire thing over here is my inner query. This entire thing is my inner query, and this query over here is dependent. Why do I call this query dependent? The meaning of correlation means a dependency or a relation. So the queries have relation. The dependency over here is this. Can you see the table which I had in the main query? I'm using it into my inner query. In a correlated subquery, I can do this. Now, how do we examine that it's a correlated subquery with this? Where the outer query or the main query table is used within the inner query. That's a correlated subquery. Non-correlated subquery will never do this. So the outer query table is used within what? Within the inner query to generate the result set over here. So that shows a correlation or a dependency which was not shown earlier so far. You cannot use this employees table directly over here because you have main query as one table. So this is my main query. Which is there. So earlier the inner query used to execute only once and the outer query was supposed to be generating the outcome. But here what it had done, select average salary from employees where employees.department is equals to outer table.department ID group by department, it has done. So if I show you here, this is the data and let me run both the queries. Select star from employees. I'll show you how this query has actually worked. I'll take both this query. I want both the outcomes to be there. So I'll run this. So you can see two outcomes. This is the average and this is the employee table. So first the inner query executed. The inner query executed. Now average salary from employees where employees.department ID is equals to outer table department ID group by department IDs. So what is the first table department? D5 over here. What's the department over here? It's D5. So D5's average salary is computed. So this query will give me D5's average salary. What is D5's average salary? 75,000. And what it will do? It will compare it over here. Is the salary greater than 75,000? No. So this will not be shown in the outcome. This is done. Now for the next result over here, what it will done? It will run the inner query again. Now what's the department over here? D1. What is the salary? 40,000, but I don't want to see this. D1, so employees.department ID, that is this, and outer table.department ID is this. So D1 would be shown. So what is the D1's average salary? 40,000. Is this employee's salary greater than 40,000? No. So this will not be calculated. Now it goes to the third data. It will see the department as D3. What is the average salary of department D3? 57,000. What is the salary over here? 55,000, which is definitely less than, so this will not be shown in the outcome. If you go with the department over here for fourth record, the inner query will execute again. What is the department? D3. It will calculate the D3's average salary, 57,000. And it's again 55,000, so it will not be shown in the outcome. So Same happens for the D5, D6. So how many times the inner query is going to execute? 130 times. Not 130 times. Let me see how many employees do I have. I have 130 as in last ID. So how many employees do I have? I have 21 employees. So my inner query is going to execute 21 number of times to compare with the outer query. And there is a relation made that the IDs of the outer table and the inner table will be compared, and that will be used to generate a result set. So every time the outer query record is there, it will be searched by the inner query executed that number of times, and that is the meaning of correlation. So the inner query seems to be correlated or dependent on the outer query to generate the outcome for me. So this was a correlated subquery. Over here, let me show one more example related to correlated subquery for you so that you'll get it more clear. Now, find departments without any employees. I want to know which department doesn't have any employees working in it. Let me see, select star from departments. So I'll see this. I have D1, D2, D3, D4, D5, D6 and so on. Now if I do select star from employees, which are there. So here you can see D1, D2, D3. I want to know, okay, which departments the employees are working and which is the department where the employees are not working over here. So department IDs, and I'll write distinct because it will show me the distinct and not the repeated elements. So D1, D2, D3, D4 and D5 are the departments in the employees table where it is there. Now let me see, D6 and D7 is not there. So find which departments without any employees. Which are the departments where there are no employees working in it? D7 and D6 over here. So that I wanted to find with the help of subquery over here. So how will I find it? First, let me write select. I want the department IDs. Let's say I'll write select star from what? From departments, and I'll write where ID is equals to or in, because my inner query will give me multiple results. So I'll write in select department ID from employees which are there, and I'll write where. Now employees, what should match from employees table? The department ID, and the outer query will be related. It's a correlated subquery. The table, the outer query table will be used over here. So which table is it? Departments. So can I use it? Yes, departments.id, which is there. So when I run this query, it is giving me the department names where there are employees working in it. I want to know which department has no employees working in it, which means where there are no employees still yet hired by the organization. So instead of in, I'll write not in. You all must be knowing that it will not consider the values shown which are matching. It will show which are not matching over here. So D6 and D7, we saw over here that the employees working were in D1, D2, D3, D4, D5. D6 and D7 was the department where there were no employees working. And with this query, we got it very clear. So for every record over here, it will go to every record in the outcome and it will try to do a match over here, which is there. So if I show you what it will do, I'll run both the queries. So departments. So this is a departments table and this is my inner query which I have used. So what it is showing me? The first record is D1 over here. Is D1 found in my inner query? Yes, D1 is found. So I am writing not in. I don't want it because it should not be found. So the second record is this. My inner query will execute again. D2. Is D2 found over here? Yes, the D2 is found. So it will not be shown in the outcome. D3. Yes, the D3 is found. The inner query executes again and D3 is found. So it will not be shown. D4. Yes, the inner query is executed and D4 is found again. It will not be shown. D5, which is there, and the inner query executes again and D5 is found, so it will not be shown. Now D6, yes, for D6 inner query executes and D6 is not found, so it's not in the list which is given by the subquery. So definitely this is the department where the employee is not working. For D7, it will run the inner query again. Is D7 available? No, it's not available, and it will give me the result set or the outcome, stating that D6 and D7 are those departments where there are no employees working in it. Now many people, what they do, instead of writing this, it will write exist. Now exist is a subquery, or exist is a statement which will help me to return an outcome if the values are matching, if the subquery results an outcome over here for me. So these are the department which exist between both the tables, supported by the inner query relation. Now if I write not exist, so it will show me which doesn't exist between both of them. So which are the two departments which doesn't exist between both of them? It's D6 and D7. So this is how a correlated subquery was slightly different from the non-correlated subqueries or the basic subqueries like single row and multi-row which we studied. They are mostly known as nested subqueries which are there, or non-correlated subquery. Now this was just a practical implementation for both of them. I hope you are clear with this, but let's try to see with some differences between both of them over here. So we understood that when to use subqueries, how to use subqueries practically. Let me show you over here that what is the difference between a correlated and a non-correlated subquery. Now if I want to talk upon a feature of execution, as I said, correlated subquery will execute once per outer row, which means the number of times the outer rows are available, the correlated subquery or the inner subquery will execute that number of times. So imagine we have 10 outcomes in the outer query, so the inner query is going to execute 10 number of times for each row. It will be computed. Now when I talk upon a non-correlated subquery, it will be executed only once. That is, if I want to find the average salary greater than average, so it will execute once, it will give me average and it will be computed by the outer query to generate the result set. Now dependency can reference outer query column. Correlated subquery can take outer query table and outer query column to show relation, as we have seen. Now non-correlated subquery cannot reference outer query columns. It cannot do it. It cannot use outer query information over here. The meaning of correlation lies over here. That it relates with the outer query, it does not relate with the outer query. Performance may be less efficient for large data set. Now when you have a large data set, let's say I have 1 lakh of records. For 1 lakh of records, 1 lakh time the inner query is going to execute, and that can be computationally heavy. So certain of the times people preferably don't use correlated subqueries. Instead they prefer to use joins or unions to perform this task very efficiently. Now generally more efficient because the query is executing, the inner query is executing only once, so it's not that efficient that it has to run n number of times. So it becomes more efficient for us and not so much computationally heavy as compared to a correlated subquery. Now use case. Results depend on outer query values. So the inner query results are going to be dependent on the outer query for me. Results are independent on the outer query, which means the inner query over here is independent in nature, and the inner query over here is dependent in nature. You all have seen that over here. So if I show you that this shows dependency. Why dependency? Because outer query table is being used over here. But this shows independency. Nothing from the outer query is used over here. So the inner query over here is independent, but the inner query over here is what is dependent in nature. That's what we can see over here with respect to the subqueries which are there. So that was a major difference between a nested or non-correlated subquery and a correlated subquery. You will usually see a non-correlated subquery used a lot as compared to a correlated subquery, just because correlated subqueries can be certain times computationally heavy. So they are used when you have less number of data in the outer query or less number of data into your inner query which are there. So what are the advantages and disadvantages of using a subquery? Advantages: simplicity. Now subqueries can make complex queries easier to read because it's a query within a query. So I can execute one query and get the outcome for the same. Just like what we did in the question where we have to calculate the employees where we have more than average hours. It was a lot of queries, it was a lot of complications. But if I run one query at a time, I can understand what is happening within it. So it can help me to understand the simplicity within the complex queries which are there. So subqueries can make complex queries easier to read and understand by breaking them into smaller parts. Modularity. Subqueries can be reused and modified without affecting the outer query. Yes, my inner query I can modify according to the convenience, according to the requirement, where I don't need to modify the outer query, but inner query can modify it and get the result set over here. Now flexibility. Subqueries provide a way to retrieve data without the need of joins. So without even joining two tables, I can definitely get the results from two tables over here. That is what a flexibility feature of a subquery is. Now, obviously, the things which comes with advantages will have certain disadvantages which are there. Now, disadvantages of subqueries. Performance. Subqueries can be less efficient than joins, especially in large dataset, as they may execute multiple number of times. Your correlated subqueries, when you have 10,000 records, the inner query is going to execute 10,000 times. It can be computationally heavy and it can be less efficient as compared to joins. At that particular time, joins will be more preferable for us. Complexity. Correlated subqueries can become complex and difficult to optimize. Now, when you add multiple correlations between the subqueries, it will be more complex in nature and that can lead to confusion within the queries and the outcomes, and it can become difficult to manage because it becomes heavy and computationally inefficient over there. So, these were certain disadvantages of a subquery. So here we have completed what is subquery, why do we use subquery, what are the simplistic example of using subquery, the types of subqueries which we understood. We saw practical implementation of what does a correlated and non-correlated subquery look like. We understood what is a major difference between both of them and what are several advantages and disadvantages of the same. I hope you all have understood what is a subquery and why do we use a subquery and how come subquery can help me to get certain result sets without joining two tables or without doing any of the complex tasks. But yes, the subqueries can get complex when you try to add multiple queries within them. So this was all about subqueries. I hope you have understood the same. So far, we have seen retrieving the data, fetching the data, and accessing the data in the outcome with the help of select statements, where we were getting some responses for the request which we give in the form of query from the database where the data is being stored. But what if I have a huge amount of data? Do you think so? The time consumed for getting the result set and the outcome would be the same for what it was for the smaller data? The answer would be no. The query time or the access time or the fetch time for the data might definitely take a longer hour or a longer duration for us. Why? Because the data might become slow in terms of processing and searching. So that's when we use a query optimization approach known as indexes. Now, what are indexes? Let's try to understand, and let's try to see some practical implementation of what indexes are and how do we create indexes into the tables on my databases. First of all, if I want to talk upon indexes in simple terms, now imagine that I have been provided with a book for SQL and I wanted to search for the topic known as joins. It's a book of 500 pages. And definitely, if I want to search for the topic of joins, I need to go and search for all 500 pages over here. Don't you think so? It will consume time for me. Definitely, it will. Then, what I can do as an alternative in order to save my time and going to all the 500 pages and accessing the data, I can go to the index page and I get the topic names over here. Now, how it would look like? The index page of the book will look like something like this. It will have a name known as index, and let's say the first topic is related to the intro to SQL. So introduction is there and the page number is 1. Let's say in the index page, the second topic is related to DDL and the page number is 10. The third topic is related to DML and the page number is, let's say, 20. The fourth topic is related to DCL and the page number is 24. And let's say the fifth topic is related to what joins and the page number is 28. So if I want to get the access of the chapter for joins or topic of joins, what I can go is, instead of going to each 500 page over here, I can go to the page number 28 where the topic of joins is being stored and I can get the result set for the required outcome over here. So the search over here will be made easy with the help of index page. That's what indexes does in SQL. Let's try to understand with some technicalities over here that what are indexes, how do we use indexes, and how do we create indexes for the same. So, if you can see on my screen, an index in SQL is a performance optimization feature. Now, what is the meaning of that? Now, when a query is being written, we have seen a lot of syntax of writing queries, retrieving the data, fetching the data with the help of all the clauses, with the help of with statements, subqueries, and many more. And we know that the queries needs to be optimized for the better performance. When the huge data is there, we need the query processing to be done faster, quicker, and the answer or the responses to be generated quickly. In order to optimize the query approach, or in order to optimize the outcomes of the query, we use something called as indexes. So indexes are used for performance optimization, that is performance improvement of the data retrieval. So an index in SQL is a performance optimization feature that speeds up queries by allowing the database to locate data faster. So this will help me to allow and locate the database faster, quicker, and the search will become very easy. It works just like an index for a book, as the example which I gave, helping you to find information quickly without scanning each and every page. So instead of going to each and every page, it will help me to locate the data quickly and easily over here. So why do we think so? And why do we need to use indexes over here? First, when filtering large data sets. As you know that when I have 500, 1000, 10,000, a lakh of records in my database, it will definitely consume time for me to search the data and get the result set into the outcome. So when I want to do a quicker search or a faster search with the help of where, having, order by, joins and many more things, I can take help of something called as indexes over here. So when you want to filter large data sets, you can use indexes. The second, on columns which are frequently used in searching. Let's say in every search of my query, I'm searching on the basis of departments of the employees, the location of the employees. So there are columns which are very frequently used into the search. So that's when I can use something called as indexes. And for unique constraints, so if there is any column which consists of unique as a constraint on that, I can use indexes to filter the data, to fetch the data and get the retrieved outcome very easily, very quickly. So these are certain use cases that why do we think so, or when do we use indexes over here. Now let's try to see some indexes which we can create into my SQL server. Now what is the first type of index? A primary index. Now you all must be familiar about a primary key. Now indexes are given and created by two ways. First is automatically and the second is manually by the user which is there. Now what is the meaning of an automatic index which is created? Now just imagine I create a table known as, let's say I am there into the Imarticus databases and I am creating a table and it's related to, let's say, customers. So create table and I create a table known as customers. Now in this customers table, I'm giving customer ID as a column name. It is an integer and I'm giving a constraint of primary key. Now what it means that when I'm creating a table, it is a primary key over here. Primary key. The second one which I am giving and which I am creating it over here is nothing but customer name which is there, and let's say the name over here is varchar 50. Here I say the customer's age, it's an integer which is there. Let's say if I create a customer's email ID over here and this is going to be what, varchar for the same, and let's say 100 records over here, and this is the table which I had created. Your customers already exist. Okay, let's say I'll write customer info and I run it, and you can see customers info as a table has been created over here. So what is the meaning that, what is the need of creating a table over here? And I was talking about a primary index. Now you remember that I have given a primary key as a column over here. So when I go into customers info and there is an option of indexes, if you can see, it is having an automatic index created known as primary key. So primary index automatically creates when a primary key is defined. So this index will automatically get created when you are defining what? A primary key over here. Ensures unique and non-null values for the same. So it ensures that all columns are unique and all columns are not going to consist any null values over here. And that's how an automatic index is created. So primary key is an example of an automatic index which is there. So here you can see we saw with an example that when I create a table, when I gave a primary key into indexes, it's pre-created and pre-available for us. Now the next index is a unique index. It ensures that all the information which I pass is going to be what? Unique over here. Now how do I define that all the information which I pass over here is going to be unique? It's very similar to primary key, but it will consist a null value because it is only saying me unique. It is not having a property of not null. So it can be unique, but it is not sure that it is going to have not null as a constraint. So what can I give over here? Let's say I have customers table. So select star from. As you can see, I have customers table. I have ID. I have name, I have city, I have address. Now, if there is any key defined, I can define what? Describe customers over here. You can see describe customers. My ID is already what? A primary key with an auto increment. There is a name, there is city, there is address. So this is already there for me. And if I say that address of each customer is going to be unique and I want to create an index known as unique. So how will I create? So create index. The syntax for creating index is what? Create index, and you need to give a name of that index. So what is the name of the index? Let's say I give the name as address ind on on what table I want to create this index over here. So I want to create this index on the customers table. And on what column do you think? So from the customers table, the index would be working, because it's not going to work on the entire table. It need to work on a column or a set of columns. So which column do you think? So I want this index to work. I want this index to work on address. So I've written it over here. Now it's a unique index which I am passing over here. So I can write a constraint known as unique. So I'm creating a unique index over here, and when I execute it, you can see it is giving me error. Why? Because address as a column was having varchar over here. So whenever you create, just to show you that it's not a number over here, and it's what? It's a text which is there. So whenever we have text varchar, usually it consumes a little time for that indexes to happen, or sometimes error. So I can give a varchar over here. Let's say I give a varchar of 35 and I create the index. You can see an index has been created. And if I refresh it in the customers table, in the indexes, primary key as an index was pre-created, was automatically available when the table was itself created. But if you can see, I created an index known as address int. So a new unique index has been created over here. So this is how we can create a unique index, and there is no such requirement that if it is a unique index created on that column, it asks that each record should be unique, but it is going to consider null for us. And in the address column, if you can see, it was considering null, it was having null, and there was no issue when the indexes were created. So this is how a unique index is being created, that it ensures all the columns are unique. Now we have something called as cluttered index, which is there. Now determines how the data is physically stored. Now whenever you create a table, your primary keys are by default your cluttered indexes. Now what are cluttered indexes? Cluttered indexes will help you to store the data, will help you to create indexes, and that index column will be sorting itself automatically. So this sort will happen automatically. It orders the data automatically over here. So determines how data is physically stored in a table. The table can have only one cluttered index. Now remember that a table can have only one cluttered index which sorts the data in an order, so that the search becomes very quick, very easy. And the primary key whenever you create is a by default cluttered index into your databases, which is there. So that was a cluttered index which was there, which will help me to keep the data stored physically. The data would be sorted on whatever column which I create as my cluttered index. By default, my primary key is a cluttered index, and if you see, select star from customers, all the data as I enter it, it is sorted in which order for me? In my ascending order. Now if I show you the select star from students as a table, if you can see, this is a data where the data seems to be sorted in which order? In an cluttered order. Now let's say if I insert data into the same. So insert into students, and I'm inserting values. Let's say I'm inserting value as 105. Now 105 as a student, I don't think so it's available over here. So the name of the student, let's say I give the name of the student as Jay, and I give age as 38. Let's say I give city as Mumbai. I give the address as, let's say, 16th Road, Pali Hill. I give the address. Now contact is 9967564589. I've given this as contact number. Let's say I give an email known as j.patel@yahoo.com. So I gave it as an email ID, and let me write the enrollment date that the student has enrolled today. So it is inserting a current date. Okay, let's say 28, 27. Yeah, it's inserted. So if I see the student's info over here, you can see primary key was my cluttered index over here. And when a cluttered index is created, now if you can see 105 was added, it should ideally be at the end. But why it is showing in a sorted order? Just because my primary key by default is a clustered index. And the column which is acting as a clustered index will sort the data, will arrange the data in an order. And you can see 105 was not there, I added it. Ideally, as per the database scenario, it should be at the end. But as student ID or the primary, it's a primary key of my table, it's a cluttered index by default, it is sorting it in an order and arranging it accordingly. So the search becomes very quick, very easy. Cluttered indexes can make the search very quick, very easy when the data is being shown and given in the outcome, as they are sorted in nature. So they are quicker or faster in terms of searches. So the next we have is non-cluttered indexes. What is the meaning of non-cluttered indexes? Stores the index separately from the table data. It is not storing the indexes in the table itself. It will store the indexes separately as compared to the table data which is there. A table can have multiple non-cluttered indexes. So each column separately you can create a non-cluttered indexes. It is not going to sort my data in any order which a cluttered index was doing. And that's a major difference between cluttered and non-cluttered indexes. If I tell you that the data is sorted in an order in cluttered indexes, and that can make the search very quick, very easy. But if I want to talk upon the non-clustered indexes or non-cluttered indexes over here, it will make a data search slightly slower or slightly time consuming as compared to my clustered indexes which are there. So that was about non-clustered indexes in terms of searching the data. Now we have something called as composite indexes. Now what is the meaning of composite indexes? Composite indexes are those indexes where two columns or multiple columns will be used as an index for search of a quicker data accessibility. So indexes based on how many columns, multiple columns together is known as composite indexes. Improves performance for querying, filtering both the columns or multiple columns together as such. So when I have to create, let's say I have a data known as select star from employees, employee details. So I have a column known as employee, I have a table known as employee details. And if I go and see the employee details table, if you can see, and if I want, I have two indexes created into it. You can see I have created one index on the column known as ID. I have created another index on the column known as location and salary. Now let's say when my search is happening, I want to search the data always. My queries are consisting always of salaries as well as the departments which are there. So I want to create an index on them. So I'll write create index which was there, and index, the name of the index is very important over here, that how do we give a name to the index. Now I can write any name, IDX, or let's say I'll write index on department and salary. So I write IND underscore department. So that's my index name. On which table do you think? So this index is going to work on employee details. But if you don't mention any columns, definitely it is going to give you an error, because in the entire table the indexes might not work. So we'll write the column name. I'll create indexes on the basis of department which are there, comma. Let's say I'll create on the basis of salary, and I close it. You can see that's being created, that's being closed. I can also write location in between. So I want this to be created on the basis of location, department and salary, and I'll do this. Now what is an issue over here? Let's say if I describe, whenever this text and blob issue comes, you always describe your table. So describe employee details. When I describe my table, can you see department? Department is having a data type as text. My salary is integer, so no issues over here. Location over here is also text. So whenever any column is having a data type as text or something which is apart from numbers, so you have to mention a varchar for a safer side, so that this issues related to the search might not come very frequently for you. So I am writing department as 25, location as 30. So I do this and I create an index. Can you see an index is created? So if I do this, you can see an index known as IND department, which I gave over here, is being created. It's being available on what one? On the department as a column, location and salary. Now if I write a table, let's say select star from employee details, where location is equals to Mumbai and salary is greater than 50,000. So you can see a search is happening for me and it consumes a little time for us. So if you want to understand, okay, how this query is done, so you can write explain the select statement. So it will help you to explain what is there. First ID, select type is simple. You are writing simple queries over here based on one table. The table name on which it is working, employee details, there are no partitions. The data is in the form of range. You can see possible keys. What is the possible keys? The location and the salary as an index, which is working on this. So the location and salary is working on this. Let's say I write this and I give the name as department. Now department, like I give the department just like, let's say development or something over here, and I close it. You can see it is helping me to search the location and the department over here. The key which is there, the key length, the reference, the rows, how many rows are there, filtering, and what is an extra part. It's a where clause which is being working over here. So you can explain your query over here with the explain statement, that what you have written, and your indexes will be working on the same. So this is how you can create your indexes and you can make your search faster. Now, what are certain disadvantages and certain don'ts of creating indexes or using indexes? First of all, when you have a smaller chunk of data and you want to retrieve the data or retrieve the information or the query approaches or the responses from them, indexes might not be so much helpful for you because the data length is anyhow small. So it's okay if you do a normal search instead of indexes. Second, if the query or the table is having insert updates happening vigorously and on a very frequent basis, the indexes might not be a fruitful approach at that particular time. And that's when indexes might not be so much helpful and they are suggested to be avoided over here when multiple inserts, updates are being happening into your data or into your table. where the indexes are being created. So that is some don'ts for your indexes which are there. Let's say I have created an index, but what if I want to drop an index? I want to eliminate that index which is created. So dropping index, how will I drop? So I'll write drop index, the name of the index, let's say IDX. I can write name or I can double click on the same. So this is an index on what table? On the employee details table, and you can see the indexes has been removed, and here in this table the indexes are gone. There is only two indexes, that is new one and index department. If you want the new one to also be eliminated over here, I can write drop index new one on, like on what you want to make this drop element work on the indexes and employee details, and you can see, you can refresh, there is no new one as an index available into my table. This is how indexes are going to be created, and this is how indexes will help us to do the retrieval of the data and the fast search of the data. So indexes as a concept are used to do the query optimization approach, because it's not about only writing queries but optimizing their performance as well. And this is how we can understand and utilize indexes for the same. So now we are going to study a new topic of discussion. Now what is this topic about? Now imagine that I have a lot of data with me in the databases. I have data related to the bank accounts of the employees, which are there, such as their name, their Aadhaar card, their PAN card, their security pin details, their email IDs which I use, their official accounts which is there, their account numbers which are there, balance, and the salary details which is there. Now, when I'm sending it to a person, when I'm giving the access of the data to any person, I don't want to give all the information of related to that particular employee. I want to restrict the information, which means I don't want to show all the records, all the rows, all the columns to the person. I just want to show certain limited set of records. That is the first thing which I wanted to do. Secondly, I don't want the person to whom I'm sharing the data should apply any changes or modify my existing data or my base table over there. At that particular instance, what I should do to avoid or apply this level of security. In order to get this level of security, I would definitely create something called as views. Now, views is our topic of discussion for today. Now, what are views? If you can understand views in simple English term, view means to see. Now, what I'm going to see? I'm going to see the data. Now, I'm going to see only that data which is provided to me. I'm not going to see the entire table over here. So, I can view only the data which is possibly shown to me. Now, when I'm viewing, you all must be knowing of virtual reality. Now, what's virtual reality? It's something which is virtually available, but I cannot physically mention or I cannot physically handle it over there. So, views are also known as virtual tables. What is a virtual tables? Which means I can query the data. I can see the data, but I want to physically store the data. I want to physically make the changes to the data. That would not be possibly available. That are views in SQL. Now, let's try to deep dive into what is views, how the views are created, and what are the views, what are the advantages, and what are the different types of views which we will see and which we will use over here. So, when I talk upon views in SQL, as I said, they are popularly known as what? Known as virtual tables. Now, view is a virtual table whose contents are defined by a query, which means I will make sure that what amount of data and what level of data to be shown or to be shared with the individual. So it will be defined by the query. So it will be defined that what contents or what amount of data to be shared to the individual in the form of view. As I've said, view is nothing but a virtual table. It's logically available to me, not physically available over here. So it consists of set of named columns, as I said. I have n number of details related to the employees. So I want to share only details related to the name, the location, the department to belong to, and their performance details. I don't want to share their Aadhaar card details, PAN card, the account details, the PIN number which these guys have set for their account, because that is a confidentiality information which I have and I don't want the other person to see it. So it consists of named columns, that how many columns I want to share, and set of rows into the data. Let's say I want to share details related to the only employees belonging to IT department. So I can do it over there. I can limit my data to the rows which I want to share over here, which comes from table referenced in a query. Now when I write a query, definitely this query would be collecting data from a table. So views are created from a base table, which means I have or I need to have a table first in order to create a view. So the result of a view is produced dynamically. Now what is the meaning of dynamically? Every time I call a view, the query, the code which I have written would be executed n number of times. So the result of a view is produced dynamically when the view is referenced, when the view is referred to a table. So, unlike tables, views do not store the data. As I've said, it's a virtual table. What is the meaning of virtual table? It's visibly available to me, but it's not physically available to me. What is the meaning of physically? It will not capture any memory for its storage. So, they act as a filter on the underlying tables referenced in a view. Views can be used to focus and simplify and customize the user perception of the database, which means how the user wants to see the data, how the user wants to share the data to the person to view it. The views can be created and customized in that particular manner. They can also be used as security mechanism. As I said, views only give read-only access. What is the meaning of read-only access? Which means just read my data, but don't allow the updates to happen over there. So the security would be maintained. For example, to grant user access of the data through the view without directly accessing the underlying base table. As I said, when I am sharing the employees' details, which I want to share to an individual to work upon, I don't want to share the account number, Aadhaar card, PAN card details from the base table. So I will share a view which will have limited set of information and not share the actual table which I have with me related to the employees. So if you can see in the image, there are multiple tables, and when there is a view, it is a combination of all the multiple tables based on the restrictions which I give over there. So this is how a view is created, a view is stored. Now what are certain benefits of creating view? It creates data abstraction. Now, what is the meaning of data abstraction? View allows user to interact, which means to talk with the data without the data directly accessing, which means it will not take the actual data over here. It will only take the view query which is being mentioned. So views allows to interact the data without directly accessing the underlying tables. I'll not take the underlying or the base table directly. It will just help me to get the query related information from the main table, providing a layer of abstraction, or I can call it as a layer of security or amount of content to be shown into my outcome. Security. Views can be used to restrict the access to specific columns or rows. As I said, I don't want all the employee details to be shown. I want only limited set of records to be shown over here, ensuring that user only sees the data with an authorized to a view, which is being provided to a view. Simplified queries. Now, if I want to combine data from multiple tables and show it at once in a view, I can definitely do it. So I don't have to write the complex queries again and again. I can write the query and store it in a form of view. So views simplify complex queries by encapsulating the logic within a view, that is storing them within a view, making it easier for the user to retrieve the required information again and again instead of writing the big and the complex queries over here. So this is what the benefits of the view is there. But how does a view looks like? How do we actually create it? And what is the syntax for the same? Let's try to understand it over here. Now, when I go over here, I will be going to classic models as a database, which we all have used earlier. I have given the access related to the classic models database, which is there. I have n number of tables, which is there. So let's say show tables from classic models. As the database selected is classic models, and you can see I have n number of tables. I have views created over here earlier. Let me drop all the views over here. So I can drop a view. Let me drop and let me create again for you. Drop. I'll drop this. And I'll drop this view. So I don't have any views created. And when I run this, now it will not show me that average employees and many more things. Why? Because it was a view, it was a virtual table created. So when a view is created, what all things are important over here? First of all, I need a base table. Now, what is a base table? From where a view is going to be created, from where the query is going to be stored. Now remember one thing, as I said, views are virtual tables, so they are not storing the outcome physically over there, but definitely they will store a query with a name, and that query will be executed in number of times. So I'll do tables. Over here I have those tables. Now what is the question? This statement uses create view statement to create a view that represents total sales per order. Means how many were the total sales created by per order. But before going to this complex example over here, let me help you to understand a view with a very simple example. So select star from, I have multiple tables over here. If you can see, let me take data from customers table. Now when a customer is enrolling to any e-commerce platform, now classic models has data related to multiple queries which are there. Can you see it has data related to the customer's phone number, address line to city, postal code, sales representative, and the credit limit of the customer. Now when I am sharing this with other person to see the data over there, definitely I don't want to show the phone number of the employee of the customer over here. I don't want to show the credit limit of the customer. So I will not have all the data to be shown as an outcome. I want to restrict the columns. What I don't want to show? I don't want to show phone number. I don't want to show the credit limit over here. So I don't want to show those records which are there. So, and that is a restriction which I want to apply for columns. Now imagine that I don't want to show all the customer details. Now the client or the person who is handling my data is handling customers from Las Vegas. So I want to show only those customers who are residing or where the city is Las Vegas. So I just wanted to show that into a view. So when I do select star from customers, it is showing me all the data. Now I want to restrict my data to the user when it is being shared. So what I want over here is customer number. Let's say I want the customer name. I don't want the customer first name and last name because first name and last name is confidential. The customer name is the shop name which is there, and I want the shop name to be shared over here. I don't want the phone numbers to be shared. I don't want the address line of the customers to be shared because this is something confidential. So I want the city to be mentioned, but the city should only be Las Vegas. I want the state of the person to be mentioned. I want the postal code to be mentioned. But let's say in order to maintain the confidentiality, if you don't want postal code, you can restrict over there. So postal code is something which is required. So I've written a postal code. It depends on you how you want to do it. Now country to from which the customer belongs, and the sales representative employee number. That is who was the employee who has handled this customer over here. So this is the data which I wanted to show in the outcome. Now you saw that I am not going to show all the columns over here. I'm going to restrict with respect to certain columns. So column level security is what I have added over here. What amount of security I want to add in the rows, that is the city should be Las Vegas. So I want to show only those customers coming from a city known as Las Vegas. So earlier I have applied a column level security, which means only specific columns are shown in the outcome. Now I'm adding a row level security because a row based condition is what I wanted to show to the data over there. So I'll write where it is there, where I can say city is what, Las Vegas over here. So how many employees are there, or how many customers are there from Las Vegas? 1. So I want to show only this detail to the employee or to the person to whom I'm sharing the data. So this is a security which I have added. Let's say I don't want to show city as Las Vegas, but I want to share the data only for the customers belonging from a country as USA. So I'll apply a row level security again. What is the row level security which I'm adding? That the customer should belong from what? From USA. And this many customers are belonging from what? USA, which is there. So here if you can see the data, it's completely what? It is completely having restrictions. Not all columns are shown, so column level security is added. Not all rows are shown, so row level security is added. So I want this query to be shared with an individual, which means the result of this query to be shared with an individual ahead. So I want this to be stored within a view. So how a view is created? The syntax for view is very easy. Now, how does the syntax for view happens? So let me write the syntax first and let me replicate that syntax into the query, and then let us solve the questions which I have mentioned over here. So what I'll write the syntax. Syntax is a generic representation of your query. What I'm writing, I'm creating something. You all must be knowing DDL commands. Now DDL, data definition language. I'm creating a structure to be shown in the outcome, but I'm not storing that structure. So I'll write something called as create, because there is something created within my database server. So create. I do want to create what? I want to create view. Now, many people, what they do, create view and they will write as over here, and then they will start writing the select statement which they want to store in a view. But definitely this view which is being shared, which means the query which is being shared, will be having certain name. So view name is very important over here. So view name, and then I'll write as a keyword, because this view will be stored as what? This name will be having what? So I'll write as, and then you will write your select statement over here. So select star from table, and then you will write multiple things. Your query will end, and the view is definitely created over here. So this is a generic syntax of creating what? A view. So let me create the view on the query which we have written. So I want to create a view named something. Let us name something over here. So I'll write create view, and I'll write the name as something. Now definitely the view will not be created with something as a name in a real world. I'm just showing it as an example. So I'm writing name as something, and I'll write as. Now what does this as will consist over here? This as will consist of queries. So this as will consist of what? Consist of a query. And this is how a view is created. So can you see the syntax? Create view. I'm written create view. The name of the view is something for me, and this view will be represented as what? It will be represented by the query over here. So when I execute it, it is done. There is no error, which means the view is created. Usually when the views are created, it doesn't give error. But when the views are executed, it does give the error, which is there. So here we have created a view. Now, how do we execute a view? So how do we execute a view? So execute a view, which means I want to see what is being stored in a view. I want to see how the view looks like. So when you see views are not shown, just refresh it. You can see a view is created and I name the view as something. So the view name is something. So how do I call a view or I see the data which is stored within a view? Now, this is also one question which many candidates do fail. Why? Because they think, oh, something different is created. Should I use call as a word? Because stored procedures are called by call. View is what? It's a virtual table. It's your table itself. So you have to call very similar to the table. So the syntax for calling a view would be select star from, but not the table name which you have used within a view, but the name which you have set for the view. So what is the name which I have set? Something. So when I run this, you can see I can get the data which is stored in something as a view. I can then filter it out where, let's say, I know the city is NYC. So I can filter out the view which is there. So definitely I can filter out the view which is being stored over here. So I can get the data from this. So when I want to run this query, execute this query, I didn't have to run this part again and again. I just write something which is representing the query. So the query is stored with a name known as something. So one thing to remember, views does not store the data physically, it will store the data logically. That means that it will store the query, not the actual data over here. So I can filter out the data from my views however I want. So this is a view which we have created so far. Now if I try to update a data in a view, as I said, it will apply a security over here. So let me show you. Let me have this data. If you can see, it is there. Let's say I want to change the customer name where the city is New York and the sales representative number is 1323. So you all must be knowing the query for updating. So update. So I will write update. Which table? Now my table name is something over here. And I'll write set. I want to set the customer name. So customer name from this, I want to set the customer name, let's say Toyland over here, where I definitely have a criteria. What is a where condition? Where the city is NYC and the sales representative employee number is 1323. This is what I have. So sales rep employee number which is there and I execute it. If you can see a view over here, there are changes which are created. So if you can see the data, so if I do select star from something which is there and then I do NYC where city is equals to NYC, the update has happened over here because I have not applied some criteria to not mention or not update the data. So it has updated the views which are there. So now we are going to discuss a new topic of discussion. The topic of discussion which we are going to study today is nothing but CTEs, also known as common table expressions. Now, what are those common table expressions? Why do we use common table expressions? And how do they are different from what we have studied so far? Now remember that we stored the data in the form of views. Now what were views? Views were virtual tables. They were storing queries for us. Do you remember that we wrote something called as subqueries, where we were writing a query within a query, which was there. And just like combination of both of them, but very different from both of them, we have something called as common table expressions. Now what are those common table expressions? Now common table expressions will create tables for us, not one but multiple tables, but those tables are created on the fly. Now what is the meaning of on the fly table? Till the time the query is running, this table is there existing, and once the query ends, the table has no existence. So here nothing is being stored, no memory has been captured, no storage element is captured with them, and they can simplify the logic by cleaning the code and representing it in a better form. That's what a common table expression is. Let's try to see what all common table expression tasks which we can do, how common table expressions can work, and how they can simplify our code logic with terms of writing codes, and how they can be a substitute of subqueries at certain instances. So if I share my screen, can you see that on screen I have written a definition for CT, common table expression. Now common table expressions or CTEs are temporary run process. Now what is the meaning of temporary? That they will be running or executing till the time you are executing the query. Once the query execution is done, the logic of this table which has been created has also been vanished over there from the databases. Nothing has been stored. Now you will say that views were also not storing anything. Views were at least storing the query which was executed n number of times. The query was being stored. Here the query, not even the table, and no information is being stored. Everything is created on the fly. Means everything is created when the approach is running, when the code logic is running, and when the query is in execution. So it can help me to write the complex queries in a very simplified manner, which a subquery can complicate with me, and subqueries can complicate the tasks related to the certain operations. That's when CTs can be useful for us. Now, CTs, also popularly known as with clause. Now, you all must be knowing that whenever I want to fetch some data, we always start the statement with respect to select. But it's not the case at all instances. Certain of the time, your querying or retrieval of the data can also start with. The common table expression has a use case of with clause. So many a times in interviews, it is asked, do you know or do you have understanding related to with clause? That is nothing but they are asking you, are you sure or are you familiar with the concept known as common table expressions? So common table expressions or CTE is a temporary name result set in SQL query, which means it's a temporary name given to the result set which I wanted to use for further queries which are there. That allows you to simplify the complex queries, making them easier to read and understand as well as maintain. Now, CTs are commonly used in working with multiple subqueries. So, it can be used as a substitute for multiple subqueries which you can use. You might recognize them when they are created with a distinctive feature of with keyword. Now, how to know that it's a common table expression or CTE? It starts with a with clause instead of starting directly with select. So that is a distinctive feature which will help you to identify that this is a common table expression being written. And many a times they are definitely asked as with clause. Now, they are also used with select, insert, update, and delete statements. So it's not like they're only used within select statements. You can also write them in insert, update, as well as delete statements over here. Now, the syntax for CTE is as follows. You have to start your query or retrieval with the help of select. Not. You have to start your query retrieval with the help of with clause instead of starting it with the help of select. Now CTE name, as you can see in the syntax which I have written over here, you will start with. As you are starting with, it will understand that you are creating what? A common table expression. And the name of this common table expression, what name you want this query to be stored. Now many a times you can give the outcome, that what outcome do you want this query to be storing, or you can directly write the queries. So column 1, column 2, column 3 and so on, and as. This name will be stored as and the query which you want to store into your CTE. That is a common table expression which is there. If you want to create multiple common tables, you can definitely go further. But only creating common table expression is not the case. You have to write the select statements to use them, to utilize them and show some result set of those common table expressions. So here comes the main query which will be executed, which can take help of the CTE which we have created it so far. So this is how a common table expressions or with clause statements are being created. We'll see with a practical example, but before that, let's try to understand that what are the various advantages of creating a CTE. So if I see the advantages of creating CTE, it helps me to simplify complex queries, which means when my subquery can complicate a logic. I know that many people are very confused upon using subqueries because subqueries looks like something which is very complicated and something which is not understandable. It is not readability, or the readability of the data is too low with subqueries at certain instances. But if you want to simplify that, you can use something called as CTE to simplify the logic of subqueries and the complex queries which are giving you the outcome of the result set. Provides readability to understand. As I said, subqueries or certain times views can provide less readability of the data, but CTs can provide a clean readability of the data or a clear readability of the data. Replacement of a view. Definitely when I create a view will be storing a query. So every time I execute the view or the call the view, the query which is being stored into my database server will be executed n number of times. But here nothing is being stored. No storage has been captured over here. Everything is created on the fly. So instead of storing the data in the form of view, or instead of storing the query in the form of view, when you know that the query needs to be created on the fly, you can use something called as CTE. They are recursive in nature, which means a CTE can be used within and can create certain logics for the same. So this is what a CTE advantages are. Let's try to see certain examples with the same, but let's we first help you to understand that how a CTE would be created with the syntax which was there, and let us solve some questions which I have brought related to the CTE. Now, I have data related to employees, if you must be knowing. So select star from employee details. I have data related to the same. Now, what I wanted to do is, I wanted only the data related to Mumbai as a location, and then I want to perform certain tasks. So, I want, let's say first I'll write the query every time and then I'll create a CTE from the same. So, select star from what? From employee details, which is there, and I want where the location is equals to Mumbai. So I will get only this data which is there. So what I wanted is, I wanted the result of this query to be stored within a CTE. So how will I do it? I have to write with clause before that, with, let's say, Mumbai city. I write the CTE name as Mumbai city, and I'll write as, which is there, and I'll store this query. So the query which is being stored, so the result of this query, that is select star from employee details where location is Mumbai, is what is stored in a name known as Mumbai city. Now it's not a view created, it's just a CTE, only on the fly approach. So when you can see, it's incomplete. It is expecting me to write something over here. So what I write, select star from. Now instead of writing employees where location is Mumbai, I will write something called as Mumbai city, which I have created it. So when I execute this, you can see it will show me data related to the Mumbai city employees which are there. Now if I wanted to say If I wanted to filter out the data over here, let's say where I wanted to find their salaries greater than 50,000. So which employees from Mumbai have salaries greater than 50,000 is this. Now, if I wanted to find which employees from Mumbai have their salaries greater than the average salary of the Mumbai employees. So what I can do is I can write a subquery here, select average of what? Of salary from. Instead of writing that entire table, I will write what? Mumbai city. So which employees from Mumbai city have salaries greater than the average salary? You can see this many employees are there which are having salaries greater than the average salary from the Mumbai based employees. So this logic looks complicated. Let me break it down. Let me first solve the same logic with a subquery for you, and then let me help you to understand that how CTEs were better for us. Now what we did, let me write step by step approach. What I did, step 1. Step 1, I created employees from Mumbai location table. So employees from Mumbai location table was created. Why? Because I wanted that set of records to be used. Then I filtered out the data with respect to their salaries. So I wanted average salary of what? Mumbai based employees. I wanted average salaries of the Mumbai based employees, and then I wanted to find the employees who are having greater than the average salaries of Mumbai based employees. So salaries greater than average salary of Mumbai based employees. So this was my step 2, that I wanted this, and this was my step 3. If you remember that this is what was required. So this is what I have done. Let me first write this query with the help of subquery, and then let me help you to understand how my with clause can simplify the same. So first of all, I had what? I had employee details table. So select star from employee details, which was there, and I wanted the data related to only Mumbai based employees. So where I wanted city, or let's say location is equals to Mumbai. I wanted this data. So I have used this data over here. So I wanted only those employees to be shown. So the table which I am using, as you all must be knowing that in a subquery, I'm using it in from. So you have to write it in parenthesis. So select star from. From what? Select star from employee details where location is equals to Mumbai, and I'll write an alias as Mumbai city. So my table name is what? Mumbai city over here. Now I wanted to find out average, where average, I wanted to find out what? Salaries of an employees which are greater than the average salary of the Mumbai based employees. So if I wanted to find out that, it will give me select average of what? Salary from. Now let's say if I write Mumbai city over here, it will give me an error. What is an error? Imarticus.Mumbai city is not found. Why? Because Mumbai city I gave the name of the query over here. It was not a table created into my databases. So Imarticus.Mumbai city doesn't exist. So what I wanted to do is I wanted if I wanted the average of this data, I need to write this query again. So I need to write this query again as Mumbai city over here, and when I run this, it is giving me the result set over here. Don't you think so? It's too complicated for me. So when I find the average salary of the employee over here, just a second. Yeah. When I find the average salary of the employee over here, just a second. Yes, this. When I find the average salary of the employee, let me write it down and outside. When I find the average salary of the employee in Mumbai location is 59,396. So the salaries which are greater than this salaries would be executed over here. So in order to find out the simplest approach, can you see I have to write a lot of logic, a lot of subquery, and the query which I wrote earlier, I had to write it again and again to write down my code to get my answer for the same. So how I can simplify this same with the help of with clause. So I will write what with, and then I'll write the name as Mumbai city over here, and I'll write the name as. And with respect to this, I'll write select star from employee details where location is equals to Mumbai. So what is this doing? It is creating what? A common table for me. The table name is Mumbai city, which will have this. So till the time this query is not ended, there is a Mumbai table created on the fly. So whatever I wanted to do, I can do it by the Mumbai city table which is there. I don't have to write the query again and again of creating a table, which I did in a subquery. So what I will do is I'll write the main query, that is select star from Mumbai city. So I'll see only those employees from the Mumbai city. Now Mumbai city as a table is what? Is my temporary table. So this is a table which it was there. Now I know the average salary of the employees belonging to Mumbai city is what? Is 59,000 something. So it should be greater than that value. That's what I wanted. So I'll write where salary should be greater than, and you remember that in this code same thing I did, where select average salary from, and I wrote the query again. I would not be needed to write the query again. I can write the name which I have stored the data in the with clause. So it is Mumbai city. So select average salary from. Instead of writing the query again, which I did in subquery, I can write directly as Mumbai city. Because there is an on-the-fly temporary query storing happening within the Mumbai city name. So till the time this query is not ended, Mumbai city as a table or the result set is being named, and you can use it n number of times. So here you can see you got the data with the same. The subquery also resulted the same. The with clause also resulted the same. But this helped me to simplify my logic. Instead of writing the query n number of times, I wrote the query only once and stored it with a name, a temporary name known as Mumbai city. Now, one thing to remember, nothing from this query has been stored into my database server. Not even the Mumbai city name, not even the query, not even the result set, nothing. It was on the fly created for me. So it becomes very easy for me to write down the logics for the same. Now, you can create multiple CTEs as well, that is multiple stored queries as well. So instead of writing Mumbai city, you could have created something called as average salary. So I'll write comma and I'll create one more CTE known as average salary. And in this average salary, I can store as. You can see select average salary as AVG salary from which table? From the Mumbai city table, which was there. So I could have created it. So instead of writing a subquery over here, I could have written directly average salary as a column which I stored. So instead of writing a subquery, what I can do is I can more simplify this logic by creating one more CTE over here. So how to create one more CTE? Just you have to write a comma over here and then write, let's say I create another CTE known as average salary and I write the column over here, that is select average salary, average of salary from Mumbai city as a table. So I am using that table over here and I'll write the alias over here known as average salary. Average salary. And I can say from average salary as a thing, I am getting a column or the outcome known as average salary. I can mention that which columns are being used in the outcome just besides my name of the CTE. So this is what I have provided it. Now, instead of using it like this, I can remove the subquery. So select star from Mumbai city where, or I can use join the table known as average salary and I can say on. I will give them name as Mumbai and I can give this name as average salary and I can say Mumbai dot salary is greater than a dot my average salary, which is there, and this is also giving me the outcome for the same. So this is how I can create multiple CTs over here with respect to the with clause which was there. So I hope you understood the same. Now let's try to see and solve some questions related to the CTEs and how CTEs will help me to solve the logic for the same. Now find employees with above average salary. First of all, what I wanted to do is I wanted to store the average of the salary of the employees and then I have to use that in order to find out which employees are having salaries greater than the average salary. So let us see. Let us find the average salary first. So I'll write select average of salaries from what? From employee details. So what is an overall average salary which you can see over here? It's 61,460 over here. So whichever employees are having salaries greater than 64,460, I want those employees details over here. So instead of using a subquery, I am storing this logic into what? With. So I will write with and I'll give a name known as average salary. And I can write that this is going to return me as salary over here. So I will write salary over here with respect to as. So a CT is being created. So what it is showing me in the outcome, if I don't write this, anyhow it is going to show me all the columns which my CT is going to return. If I write a specific column, only that column output will be shown. So what I want select star from employee details where I can say where my salary is greater than the average salary. If I write like this, you can see it is not showing me anything. So what I can do is I can write join average salary over here, which we did earlier, and then average salary dot sal. So this many employees are having salaries greater than the average salaries it is showing. Now I don't want all the columns from my this table. Can you see salary as a column is also shown in the outcome? I want only the columns which are there in employee details. So I can modify employee details dot star. So only those columns are being shown which are available into my employee details and not all of them. So this is how I can simplify my logic with respect to finding the average employees who are having salaries above the average salary with the help of CTE. Now one thing to remember, nothing from this is being stored over here into my database servers. If you can see, no views are being created, no stored procedures, no functions, nothing will be stored, not even in the employee tables, nothing is being created and stored. So this is how we can solve the first question over here. Now let's see the next question. Can you see that find out the top 3 highest salaries which are there. So find 3 highest salaries or the highest salaries of the employee. Now if I see select star from employee details which is there, if I see this data, can you see the data over here? How will I know that which employees are the top 3 or the 3 highest paying employees? What I can do is order by which was there, and I can say order by with respect to salaries. So it will order the data with respect to salaries in descending order. Yes. And I can then limit 3 which could be possibly there. So limit 3. I want 3 highest paying employees which are there into my organization. I can store this query into CT and get the answer. But let me write it with the help of Windows functions. Now you all must be familiar with what a window function is. Window function will run for each record and it will throw outcome for each row. So let me use something called as ranking. So rank on the basis of salaries which are there. So I'll write over, rank over, and I'll write order by salaries. In which order do I want? I want it in descending order, which was there as salary rank. I give this data over here and this is giving me the ranking over here. So first, second, third, fourth, fifth and so on. So this is the data which is being provided. I want this to be stored into my CTE. So can I store a window function into CTE? The answer is yes. So how will I store it? I'll create, let's say I'll create another with clause. So with highest salary. So I'm creating a table named as highest salary as, and I'll store this as my CTE, a common table expression over here. And how I can simplify this logic over here is just I need to mention select star from highest salary, where now I can use the columns which I had created into my CTE as it is. So where the salary rank is less than or equals to 3, that is the first, second and third. So here you can see the 3 highest paying employees salaries are being shown on the basis of the ranking. If someone says that 5, so I can definitely see the 5 ranking salaries which are there. So 5 highest paid employees or top 5 highest salaries consisting employees, I can find it over here with the help of the CTE which is there. So this is how I have found it out over here. Now, what is the next question? The next question is find employees who earn more than their department's average salary. If you remember the same question which we have solved in my subquery. Now, how my subquery was using, I used a correlated subquery over here in order to find out which employees was having salaries greater than the department's average salary which was there. So how did I do it? You remember that I did select star from employee details, which was there, and I used this as my outer query. So I wrote it as outer over here, if you remember. So outer query, or let's say I write it as O, which was there, and then what we did, where salary, and we used a correlated subquery over here. Salary is greater than the, and we wrote what, select average salary from employee details. Again, I used employee details over here as E. So here I was using where E dot department names is equals to O dot department name. So I wanted to check the departments which were there, and I wanted department wise average salary. So group by what? I was grouping the data on the basis of department. So you might be remembering that this is what we have seen. So on the basis of the department average salary we did. Now it was a correlated subquery. You remember that correlated subquery was running for each row of the outer query for the inner query. So we had 50 records. So inner query was executing 50 number of times. So this can be computationally heavy at certain instances, because the number of records you have in the outer query, the inner query is going to execute that number of records over here. And there is a correlation maintained. So can I simplify the same logic with the help of a with statement? Let's see. So I write with, and let's say department stats. I create something called as department stats as a table, and I write as. And in this, I'll write select department. I want to create groups of departments, so I'll write department, comma, I'll write total number of employees. Let's see. Count star as total employees. Now you can write your query separately and see how it executes, and then directly implement it with a with clause. I'm writing it over here. So average of salary as average salary over here. From which table I'm taking? From employee details table. And I want to group the data on the basis of what? Departments, which was there. So this is what I have created in my CTE, and if I do select star from department stats, so it shows me the query of this table which is being stored over here. That is the total number of employees in each department and the average salary for each department. I wanted to find that which employees are having greater than the average salaries over here. So from department stats, let's say I do join over here with respect to employees. So if you can see that I'm using and joining the employee detail table over here, and I'll write on, where I can take, I'll name it as departments as D and as E, which is there. So on, I can use E dot salary, which should be greater than D dot the department salary, which I wrote it as average salary. So if you can see, this is being shown over here related to the employee details, at which employees are having the same. Now here, as you can see, I am returning all the data from both the tables, the department stats as well as the employee details. I don't want from department stats, so E dot star, which was there. So it is returning all the employees who are earning greater or more than their department's average salary over here. So this is how the data is being shown. This is how the result is being calculated for the same query. I showed you with an approach of a subquery as well as a CTE, which could be used. Now, as I said, now CTEs are not only possible to be useful or used when you have something called as select statements, you can definitely use it into your insert, update, delete kind of approaches as well. So I will be showing you one approach related to using CTEs into your update statements. Now we have to give 10% raise to all the employees who have experience over 5 years. Now, first of all, let me see how many employees do they have experience over 5 years. So if I do select star from employee details, so it will show me all the details of the employees which are there. Now, I wanted to know that which employees are having experiences greater than 5 years. So I'll write where experience is greater than 5 years. So greater than 5 years. So how many employees are having experience greater than 5 years? 3 employees are having experience greater than 5 years. Or if I write greater than equals to, let's see how many employees are there. There are 5 employees who are having experiences greater than 5 years or equals to 5 years which are there. So I wanted to update their salaries which was there. So let me store it into a with clause over here. So with long term employees. So I'll create a name as long term employees and I store this query with the name as long term. And instead of writing select statement, what I'm writing in the main query, I'm writing an update statement over here. So what I'm writing, update. Now what I wanted to update employee details as a table. Now what I wanted to do, I wanted to set their salary which is raised by 10%. So salary, base salary plus salary is 10% into 0.10. So we have done that over here. Not for all the employees. If I don't write a where condition, it is going to do it for all the employees. I wanted to do only for those employees who are having experience greater than 5 years. So I'll write where over here and I will check for experiences which is there. So experience, let's say I write experience which is there, should be within. Obviously, this is giving me multiple values, so I'm writing in. What? Select employee ID from which table? From the long-term experience table. So long-term employee table, which is there. So I write like this, and you can see it has updated. Let us see select star from employee details where the experience of the employee is greater than 5 years. Greater than or equals to 5 years. So here you can see the salaries are being showing over here. So what it is actually doing is it is taking those employee IDs from the long-term employees who are having experience greater than 5 years, and then it is updating their salary from whatever the salary was with respect to the 10% raise which has happened, and it is showing me the data over here. So here if I execute this, you can see this is the data which we have related to the same. So 0 rows match. Let me write here as employee ID. There is no match which is found. Employee ID, employee name, which was there. Let's say the department of the employees, and let's say the salary of the employee. So this is the data which it is having. So 0 rows selected. Why? Experience, yeah, not for the experience is not matching, so I want the employee IDs to match over here. So employee ID in, and when I do here, you can see 5 rows have changed So when I see the employees who are having experiences greater than 5 years, you can see their salaries have shown a hike of what, 10% over here. So the raise of 10% have been added. Earlier I added experience, and that's why the value was not matching and no update was seen over here. So ID should match from the long term employees table. So this is how we saw that we can use a CTE into my update as well. So this was all about CTE, common table expressions, where your query was not stored, the data was not, a table was not created. On the fly, the tables were created, the query result sets were named, and you can use those query result set names into your query, into your single select statements or update statements or your delete statements to update the logics and run the queries according to the convenience which is there. So this is how CTEs or common table expression could be used to simplify the logic for certain type of operations related to the data. So I hope we are clear with CTE. Hello all. As so far we have studied a lot of concepts related to SQL. So now let's study further that what are the new things which we can incorporate in SQL and try to get more understanding with respect to data and understand more logical implementation with the same. So today we are going to study something from the procedural SQL. Now what is a procedural SQL? What is the meaning of procedure? A step-by-step approach. So the procedural SQL is a component of SQL where a processes or a logical statements, looping structure or step-by-step approaches are stored. In this, we write statements such as create, declare, begin, end and so on. So that is what we are going to see over here in the procedural part of SQL. And the topic which we are going to study today is nothing but case when or the case when statements. You all must have heard case when. But if you have not heard, you all obviously must have heard if else into the logical part or into the basics of programming. Now what was an if else statement? If the condition is satisfied, do something. If the condition is not satisfied, do something else. So that's the same thing which we are going to understand today in the case when statement. Now imagine that you have a criteria to check that is it raining or not. Based on that, you are going to make a decision of going to school or not. Imagine today it's raining heavily. So the rain is equals to true as a condition. So when this condition is true, you have to say that you are not going to go to school. So rain as a condition or a criteria is being checked over here. And if this condition is being satisfied, you are stating it in the outcome that you are not going to go to school. But is it true that this condition is always going to be true? No, that this condition will sometime or the other will turn itself to false. So what will happen at that particular instance? We can definitely move into else, that it will say that if it is not raining, that is a rain is equals to false, else you have to go to school. So that's a conditional check which we are doing. That was a very basic example which I wanted you to understand that what does a conditional check means and what will happen with that if else statements. So very similar to those if else statements, we have a logic into a case when which we will understand over here. As you can see on my screen, that there is a data, there is a flow diagram which I have brought into consideration, and we'll understand how does case when works, how do we write, what is the syntactical way of writing the same. We will also understand how does it actually executes. We will see some practical examples for the same, that how case when will be used with multiple approaches such as select, update and so on. So if I go over here, you can see that there is a product table which I have. But first of all, let's understand what is the simplistic meaning of case when. Now, when I talk upon something called as case when, so case when statements helps to check the specified condition or expression is true or not. So case when helps to check a specified condition, or I can call it expression. Many people call it as expression. or many people call it as statements as well. So check a specified condition or expression is true or not. So obviously not always it is going to be true. We have understood with that example that raining was not always a true as a criteria. Some or the other time it is going to go into else. So else will execute when the statement or the condition was not true. And if you don't give else, by default it will give you null over here. So I have this data which I wanted to write with respect to case when. So let's understand that how I am going to create an outcome for the same. So I want to say that case when, check when the unit price is greater than 300, then it's a high price product. And if it is not, then it's a low price product. So I have a condition to check. That check when, that is a case when, a condition when the unit price is greater than 500. Then you have to say, if this condition is ideally true, then you have to say that it's a high price product. And if it is not, then you will say that it's a low price product. So how am I going to write it over here? I'll write case, that is a condition which I wanted to check. Case when I wanted to check when the unit price over here is greater than what? Greater than 500. Now, if this condition or this check will give me answer as true, then I will return. So then you can see it's very simple to the English language which I'm talking or speaking over here. So then what? It's a high price product. So I'll write it's a high price product. And if this condition is not true, because it's not always going to be true, it's not always said that unit price of that product is going to be greater than 500. It can be less than 500 over here. So what I wanted to do is, I wanted to say that if it is less than 300, let me not write 500, 300 based on the data. So if it is less than 300, then I want to say that it's a low price product. So I'll write else. That if this condition is not true, else what do I have to write? That it's a low price product. So if it is not satisfying this condition, it's a low price product which is there. So case, a condition which I am checking, if the condition is satisfied, then what I have to do? So then statement can be anything. It can be a value, it can be a calculation, it can be anything over here. And if this is not satisfied, you can apply multiple case conditions, and if any one amongst them is not satisfied, you'll write else. But if you forget to write else, it will give you blank at the same. So when I do this and execute this over here, it will show me here as high price, and rest all of them are going to be shown as low price over here. So a new column or a new calculation, you can add it into your data. So this is how it works. So a single expression, a check which I am doing, equals to a case constraint. Is it equals to the check which I am doing over here? If yes, then what I have said, high price. If no, what it has to be do? If I am writing one more case statement over here, it will check one more case condition. If it is there, if it is true, then it will perform the then operation. If it is not, it will go to the next case statement if I have written. It will check it. If it is true, it will execute the then statement over there. If it is not, it will do a by default code. That's your else. That none of the condition is mentioned, and by default it's going to be what? Low price. If you don't give else statement, it is going to be null over here, and the statement ends after the same. As I said, in procedural statements or the procedural query part of MySQL, you have to use end, begin, or some procedural part of SQL so that it understands that it's a process, it's a procedure which is going to be followed. Somewhere it needs to be ending, or somewhere it needs to have those procedural elements over here. So in this, it has an element of end, that this process is going to end after the else statement is done. So this is a simplistic example. The case when example which I have written, it's not a foolproof example. We'll see with how a case when would be implemented with select and other operations which we do with respect to our data which I have. So let's go to the code file which I have and as I talk upon SQL case when condition. The SQL case function is a powerful and versatile conditional expression. Now, what's a conditional expression? A conditional check which will happen on your data based on the condition which you will mention, and that allows you to perform conditional logic within SQL queries. So SQL queries can implement conditional logic related outcomes based on the case when statements. It is used to evaluate multiple conditions. As I showed you in the flow diagram, it's not mandatory that I will always check based on the one condition check which needs to be done. I can implement multiple conditions and return different values when each condition is being satisfied over there. So multiple conditions and return different values or perform different actions based on the result sets of this condition. That is based on the outcome of this condition, different operations or the outcomes or the statements will be given out in the outcome. Essentially, it's a way to create conditional statement within your SQL queries. That's a conditional logic. Now, in programming world, we have conditional statements such as if else. If the condition is satisfied, it will do something, else it will do something else. So that kind of conditional approach we can implement into my SQL queries to show the same. Now, what are the common use cases which SQL case when statements will have? First, data transformation. Transforming data values based on a certain condition. I can create multiple groups, records or new columns based on the conditional check which we are doing, like categorizing data into groups or ranges. That's what I said. Now, data filtering. Filtering rows based on a specific condition, such as excluding or including certain records in the result set. I can exclude certain data, I can include certain data into result set based on the conditional statements. Now, custom calculations. Calculating custom values or aggregations based on the multiple condition. I can calculate or customize the calculation logics over here based on the conditional statements so that I can get the defined outcome over here. So the syntax over here is, as I have written, case when, check when the statement, then the result set. Another statement, then the result set. If all the statements are done, I have written else statements. But can you see I have written else in square bracket, which means if I don't write else, it's fine, it's going to work. But if none of the condition is satisfied and when it jumps to else, it will give me null when the else is not being mentioned. And you need not to forget that you have to end the statement. If you don't do it, it is going to be problematic for you because it will give you a syntactical error. So, I have a question related to categorizing employees based on the salaries. So, I have employee details table and I want to categorize the employees based on the salaries which are provided to them. So, let's try to solve with respect to the case when. I'll show you possible ways of writing the case when statements with respect to some practical implementation over here with my data. So, if I can show you over here that I have table related to employees known as select star from employee details. So this is an employees table which I have. Now what is a question that I want to categorize employees based on their salary. Now how I will categorize employees based on their salary? Let me write select star. I want all the columns to be shown, but I want a category of the employees to also be shown over here. Now, what is a category of the employees? First of all, I have to create. Now, if the employee is having salary greater than 1 lakh, so I write salary of the employee is greater than 1 lakh, then it's a high salary range. So, I have to say a high salary range. So, I have to categorize it as high. Now, if the employee is having a salary less than that, then I have to categorize this at low. So, salary less than 1 lakh. I have to categorize it as low over here. So, that is a simplistic approach. Let's see one case statement and let's try to add one multiple over here. So, how will I do it? I'll write select. Now, I want all the rows in the outcome. So, I will write all. So, select star, just select all the rows in the outcome. So, I have written all. Here, I want a case when statement. So I'll write comma. I can directly write case when there is no issue in the same. So I can write case. Now can you see when I've written case, approach have started. So I have started writing some conditional check over here. So I'll write when. When what? If I go on the syntax, case when, check when. Check what? Check the salary. I write salary greater than 1 lakh. So if it is greater than 1 lakh, then I have to say that this is a high salary range which I am giving, which the data consists. And if I don't write anything and I end, I have not written else over here, I end from table, employee details. I do this. Can you see that all of them are shown null and few of them have shown high, but I'm not getting that what is this high and low. I'm not getting other details of my employee tables. It is just showing me the case conditional details. I want all the columns over here, so I can write star and comma. So it will show all the columns from the employee table, and there is a new column created known as case when here, where the salary will be checked that greater than 1 lakh is high and less than 1 lakh is not being given. So only one check is happening that the salary is greater than 1 lakh over here. If it is, then it's a high criteria which is given. So if you can see in my data, this employee has been given high because it's 1,20,000. This employee has been given high because it's greater than 1 lakh over here. So obviously this is how it is there. I have not written else, so it is giving me null if the condition is not satisfied. But what if I write else? Else and I write if this condition is not true, then default give them low instead of giving it null. So what it has given? Low. If you remember that in this way, what I have read, single expression, it will check. If it is true, it will pass something. Not, it will go to another check, another check. And if none of the condition is mentioned, it will give a by default code. So what is my default code over here? That is low. If this condition is not satisfied, instead of throwing null, throw it as low. That if this is not true, else is low. So that is what I have got over here with respect to my data. But can you see a column name? It is having entire case when statement which I have. I don't want this to be given. So I will write end and I can give an alias over here as. That is as what? I can name this case when statement by some name. You know, a temporary name could be created with an alias. So I write as. As what? Let's say I write salary category. So I write it as salary category over here. So when I do this, it is giving me a new column known as salary category based on the check which we are doing. Now it's one case statement or a one case conditional check which I implemented. What if I want to add few more? Let's say I say that if the salary is between what? 1 lakh. If it's greater than 1 lakh, it's high. But if it's between 1 lakh and 50,000, I say then it's a medium salary bracket, moderate salary bracket. Instead of medium, let me write moderate over here. And then if it is less than salary, less than 1 lakh, 50,000 is going to be low for us. So this is what I have to create it over here now. So I'll try to modify my case when statements over here. So I've written case when salary is greater than 1 lakh, then high. I want to write one more check, one more conditional part over here. So I'll write one more when. Many people, what they do, they write a comma. It's not important. Commas are for the column names. Case is one column which we are creating it based on the multiple check. So no need to write a comma over here. So case when I write salary And I write a statement as between. I can use the statements which were there. Between what? 1 lakh and what? 50,000. Then, if it is between 1 lakh and 50,000, then I'll say that it's going to be what? Moderate over here. And this is done. Can you see that if it is greater than 1 lakh, it's going to be high. If it is between 1 lakh and 50,000, it's moderate. And then I'll write else. If none of the condition is satisfied, say that it's a low salary bracket which is there. And when I execute it, you can see the data having low, high, and some or the other. It could be moderate. But salary between 1 lakh and 50,000, then moderate. It's not showing over here. I have to categorize the data into few more groups. Earlier it was high and low. Now I have to categorize it into high, moderate and low over here. So I have one case conditions to be checked. Let me add one more condition to be checked over here and I'll write it just after this. That is when. Now no need to write a comma over here when you're writing one more when condition. Why? Because commas are mentioned to write multiple columns. It's not a new column which is being created. It's the same column condition which I am writing in the column or the case statement. So no need to write a comma over here when another case condition is there. This is a very silly mistake which many people do when they write and execute the case when statements code. Now when I do when the salary, I say that it's between 50,000 and 1 lakh. Then, if it is between 50,000 and 1 lakh, then I have to say that it's going to be what? Moderate over here. Then I say when the salary is less than 50,000, then it's going to be low. And then else means if anyone amongst this range is not being satisfied, I'll give no range over here. That no salary range is being mentioned for the same. So when I execute this, can you see that moderate, high, low is a category which is being created on the basis of the salary, which I'm grouping the data into. So there is a salary category column created over here, which has the categories created based on the conditional check which I did. So this is how case when will work. This is how multiple conditional check would have happened. So if I see with the flow diagram that what has happened, the single expression, my expression was salary greater than 1 lakh as the first condition. Was it equals to, was it greater than, less than? Yes, no. So yes, then it was giving me high. But no, there is one more check which is happening. Salary between 50,000 to 1 lakh, which is there. If it is, then it was giving us moderate. But if it was not, it was going to one more check, that is salary less than 50,000? If it is yes, then it was saying me low. If it is not, then it was giving me else. That was a by default no range. But based on my data, I have categorized it into three salary categories: high, medium and low, or I can call it as high, moderate and low. So this is how I did over here, and this is how Caseman has executed the same. Now let us see the next question over here, that determining employee's bonus based on the department. Now the bonus of the employee which will be provided will be based on the department. So every department wise the bonus criteria is changing. But let me see what are the unique departments which I have into my data first. So I'll go with select star from employee details. As I've said, first always see the data which is there. Do we have a department column? Yes. So I'll write department over here. I just wanted to see the departments which are there. So departments are there. A lot of times it repeated. Let me write distinct. So there is a distinct department which is there. So what it is showing me? Human resources, marketing, finance, sales, and I'll try to modify my code as much as I can. So what it is telling me, determine employee's bonus based on the department. So I'll write select star from employees first. Employee details. Now I want all the columns to be there, and with respect to that column, I want a case condition to implement. So I'll write case. So once I write case, can you see a line which is coming? So this case will have multiple conditionals stored. So this is what it is giving me. So case when this condition. Now what I am going to do when the department which I have is related to, let's say, sales. When the department which I have is related to sales, then the bonus which these guys are going to get is the 15% of their salary. So salary into 0.15. So I'm doing a calculation over here. It's not always that I'll write an outcome or a value to be stored in this. I can definitely write a calculation for the same. So, comma, if I write when, now if you want to beautify it, you can write it like this, or you have a beautify option which you can do once the code is ending. So here, when I say that department is equals to finance, for them, the salaries, 20% is bonus. So 0.20, I'm writing it over here. As I said, a comma is not mandatory over here because it will expect that comma means a new column is being added. It's a not new column, it's the same column where the entries are being repeated based on the conditional check. So I write one more when I say that we have department, which is equals to, let's say, marketing, and these guys are going to get 10% of their salaries as the bonus, so 0.10. Now when I say when the department over here is equals to, let's say I can use like operator over here, like operator, and it has something related to technology. Now it can be at the start, end, or at the beginning. So something related to technology is being checked over here. Then their bonus is going to be salaries 30%. So 30% of their salaries is going to be what? The bonus which is being paid to them. Now if all the conditions, now these are the criteria which the team gave me, that these are the bonuses which are being provided. And for rest of them, the bonus amount is going to be the same. So I'll write else. If any one condition is not mentioned, then salaries 12% is the bonus by default, which is there. And definitely, if I stop it over here, it's going to be an error for me. Why? Because it is expecting me to end over here. The statement is not ended. So end, as I write end, it is done and it's dusted. So end as what? I want to end it as, let's say, bonus, which is being given to the employees. And when I execute it, can you see the bonus is being calculated over here based on the checks which I have done. So if the sales department is there, 15% of their salary would be the bonus amount which will be provided to them. So this is how you can get the calculation over here. Now I can write comma and I can add one more column. Now I can say salary plus bonus. Now if I am doing an addition, salary plus bonus as, and I write as total salary. If I do like this and execute it, it is going to give me an error. Why? But did I create a bonus field? Yes, it is being created. But it's a calculation. It's not an actual column stored into my table. So it cannot be used for creating new records for me on the basis of my data. It should actually store into my table, and then and only then I can use the bonus as a column to be giving out certain calculated values for me. So this is how you can use your case when statements into your select. So we have used case when statements into our select to get the bonus. But if I want to combine an actual column with the case column which I created and generate a new column, it is not possibly available. Why? Because bonus as a column is just created for the outcome purpose. It is not stored into my table. So this was it. Let us go and solve another question over here. Just a second. Yeah. Let us go and solve another question over here related to the data. And let us see how it can work. Now, group the employees based on the salary ranges which are there. Now, I want to have the salary ranges. As you know that we created the salary ranges or the salary categories which were there, high, moderate and low. So this was a data which has been created it over here. Now I want to group and show that how many employees are belonging to low salary range, moderate salary range and high salary range which was there. So I can do group by. Now you all must be knowing that the column which is used in group by should be a part of my select. So I want to group the data based on the salary category, the case when statement which we create, the case when new column which we created it. So when I execute it, it is going to throw me error. What's the error? The error is not related to salary category. This is related to star because as I said, the column which is a part of group by, the same column should be part of my select. So in select, all the other columns are also there respect to the salary category. I have to remove this. Can you see that it is creating 3 salary category groups for me? So can I use it into group by? Yes. The case when column which I created into select, it can be easily used into group by. So after this, what I want count star as employee count. So I create like this. And can you see in low salary bracket, how many employees are there? 21. Moderate salary bracket, 19. And high salary bracket, it's 3. So only this many employees are possibly available into my data with respect to low, moderate and high salary bracket. So I have grouped the employees based on the salary ranges or the salary categories which I have created on the data with respect to my case when statements. So whatever case categorization which I have used, can I use it into my outcome? Yes, I can definitely do it over here. So I hope this is also clear with you all that how a column which I have used in case when or a categorization column which I have used can be used for group by and aggregation of my data. Now the next example is updating. Now we saw using case when statements only into select so far. With all the 3 examples which I showed you, all the 3 examples were showing that how case when could be used only in select. Now many people think that can it be only applicable into select? The answer is no. You can also use it in insert, delete, update. So I'll show you an example of using it into an update statements. So update employee titles based on their experience. So let's say select star from employee details and I go over here. So you can see experience of the employees are there. What is a minimum experience and maximum experience? Let's try to understand over here. So what is a minimum experience which an employee consists? Minimum experience is 1. Let me see the maximum experience an employee consists over here. What is in maximum experience? 10. Now I have to categorize the data based on the minimum experience and maximum experience and I have to give some job titles to them over here. So let me see that what all columns do I have into my table. Do I have a job title? No. So let me categorize it over here. So I write select. So I have to create a column first. So I'll write select star from employee details. Now why I'm writing this code again, I'll explain you. So employee details and I'll write a case when statement. So I'll write case when when the experience of the employees is greater than 8 years. Then I want to give them as senior manager. So want to give them a title as senior manager. Over here, let's say I have an experience when the experience of an individual is between, let's say, between 5 and 8, means it between 5 to 8 years. If it is greater than 8 years, it's a senior manager. If it is between 5 to 8 years, then it is going to be a managerial role. So it's a manager which is there when the experience of an individual is between, let's say, 4 to 3 years or 4 to 2 years. When experience is between 2 to 4 years. So I'll write 2 and 4 years, which is there. Then I'll write an associate manager, which is there. And else means if it is 1, less than 1, or not there over here. So I can write when experience is equals to 1, means it's 1 year, then it's going to be what? Let's say a basic analyst for a company. And then else, if it is not there, the experience is not mentioned, then definitely it will be a fresher. So I'll write it as fresher over here, and I'll end this statement. End as what? As the job titles. So I've written this. So I've written the job titles over here. So if the experience was 1, it was giving me analyst. If it was, let's say it's between 2 and 4, it should give me, let's say I write between experience greater than or equals to 2 years. And if I write experience less than equals to 4 years, then it's an associate manager. Yeah, it's between this. Why it is not giving me for 1.5? Why 1.5 is showing to be as fresher? Let me try it out in single quotes over here. Just a second. Senior manager. Over here for 1.5 and 1.6, it's between this. So let me change it. If the experience is greater than this, if the experience is less than, greater than, equals to 5 years, then it's a manager. And if I write experience greater than or equals to 4 years or 2 years, it's an associate manager. And let me see, for 1.5 it's still showing me fresher. Just a second. As you can see, there is an issue. Let us try, and it's equals to this, and the experience is less than 2 because it's 1. So if 1 is not there, it is giving me for 1.5, it is not giving me 4 here. So let's say then analyst. Let us try it out over here. Experience is equals to 1, and experience is equals to, experience is greater than equals to 1 and less than 2. So it's giving me analyst over here. So this is how we can implement my condition. But my question was updating employee titles based on the experience. So I have to update a title column over here. So if I see my details table, the title column which I gave over here is not being created. This is just showing me the result into my select statement. I want this title as a column to be added, the job title or the profile title of the employee to be added into the column. So first of all, I have to create a column over here. So how do we create a column? With the help of alter. So you all must be knowing that we do employee details, add alter table. Alter table, employee details, add what? I have to add, let's say, profile title as a column. So I'll give profile title as a column and I give a data type as varchar, and let me give varchar as 20 over here, and this is there. So I execute it. Now if I see the employees table, it has profile title as a column which is empty. Now I will try to update this column over here. So I will try to add the data based on the case when statement. So update the column based on case when. So let us use case when with respect to update. So as I said, we are all using it with respect to select, but let's try to use it with respect to update. So I'll write update what? I want to update employees table which are there. What I wanted to do, I wanted to set what? Set the profile title. So set profile title over here is equals to. Now when I'm setting the profile title will not be set by one particular value or a static value. It will be set on the basis of a conditional check which I do. So we will take this code which we have over here, let's say case, and till the end. You don't need to write the as condition over here. So I can write this. So case when the experience is this and the code ends. When the experience is greater than 8, it's senior. If it is greater than or equals to 5, then manager. Greater than or equals to 2, then associate. Experience greater than 1 and it's less than 2, then it is going to be analyst over here. So when I run this, it is successfully executed. And when I see the employees table now, do I have a profile title added over here? Yes. For all the employees based on their experience, a profile title has been added. So this is how you can utilize your case when statement not only into your selects but also with respect to your update statements. Now the last question for the day is with respect to the case when statements, custom sorting based on department. So you all must be knowing sorting. So let's say I do select star from employee details. So you do employee details over here and you see this. If I want to sort the data, let's say I do order by and I want to sort the data based on the departments which are there. So department, and we do ascending. If we don't give any ascending, descending, so it will sort on the basis of the ascending, descending criteria which are there. So by default, it's ascending. If I don't give anything, if I give descending, it is going to sort it into descending. But what if I want to sort the data that is for sure here, but I want to have my customized order? Now, I have n number of departments into this table. Let's say I have n number of departments. I can see distinct departments which are there. So distinct department. And when I execute it, you can see human resources, marketing, finance, sales, information technology, operations, customer service, and many more things. So if I want to sort on a basis where I want the information technology to be shown first, then the operations, then the marketing teams, then the finance. So I have my customized order. It is not going on any alphabetical A to Z or Z to A or any ascending or descending order. I have a customized approach which I wanted to follow. So let's see how my case when can be helpful in terms of my order by. Let's try to see. So I'll do select star from employee details. I'm not going to run this query, but I'm going to write it. So order by, and I'll write case. Now case statements and case expressions, there are two criteria which are there. So or case on the basis of what department. Now, in case statements, which we have seen, we write case and when, and then we write a condition, greater than, less than, any such condition. But expression, what it is, it will take my data, let's say when it is, let's say the first one which I wanted to see, show is information technology. So it is going to search that exact value over here. So when the information technology is there, a department, then you'll have a follow idea of 1. Then let's say you write when the data or the criteria has, let's say after that I wanted to show the marketing team, which is there, then I'll write 2, that is the second order which I wanted to show. When the statement over here is related to finance, that's the third department which I wanted to show, then 3 I write. Then I wanted to show operations as a department, so let's say when I wanted to show operations over here, then 4, and I'll write else. The rest of them will be shown as 5, that is rest of them below in ascending order. And I try to end the statement over here. So what it is showing me, it is first going to show me as per my order. First with respect to information technology, then marketing, then finance, then operation, and then rest of them in the ascending order. But what is this? I didn't write department equals to information technology equals to marketing. So when I did earlier, this was a case statement. So case statement and expressions are almost the same, only the difference is in expression you will write an exact value to match. You cannot write greater than, less than, like and dislike over here. So department should match with information technology, then it will have an order of 1, then 2, then 3, then 4 over here. And when I execute it, you can see first it is showing me the information technology, then it is showing me the marketing, then it is showing me finance and then operations, and then the rest of the departments are being shown with respect to how they were. So as it is, the rest of them are there. So I can customize the order in which I want the outcome of my data to be sorted. We have seen ascending and descending. In Excel, we had an approach of sorting the data based on a custom order approach. So the same thing I can do and implement over here with respect to my SQL, but with the help of case when statements. So this was all about case when statements, that case when statements are going to check a condition or a test statement to be implemented so that a criteria would be satisfied or not. And based on that, it is going to provide some or the other outcome. People say that case when statements are always used with select, but it's not the case. It can be used with select, update, insert, delete, order by, and so on. So lots of operation we can do and implement with respect to the case when statement. So this was all about case when conditions, and I hope we are able to understand that what it is and we are clear with the concept. So today we are going to study a new topic of discussion based on the earlier topic which we have studied. You know that we understood stored procedures. What were stored procedures? Procedures were multiple SQL statements, multiple SQL logics which were being stored at one place so that I can use it for the later purpose for execution for multiple tasks which were there. But can these stored procedures be further modified? Can they be further used? And can they be further utilized by any other operation? The answer is yes. We have a concept which we are going to study today is nothing but triggers. Now what are triggers? Triggers are automated stored procedures. Now what is the meaning of automated? An automated stored procedures which will execute without a lot of human intervention over here. So this is what a trigger is. Triggers are nothing but automated stored procedures which are used to do n number of tasks in the real world scenario. You all must have seen that example of triggers in your day-to-day life. So now let me also help you understand the same with one simplistic example. Imagine that today I am going on any site, and when I go on to the site, it is asking me for login. Imagine that I go on to the site of HackerRank and I wanted to start practice for the same. So when I go over there, I cannot directly start it. It will definitely ask me to what login. So when I create my login ID, I create my sign-in IDs. It can be name, email ID, phone number, LinkedIn profile, many things. I inserted my data and I sign up over there. So when I sign up, let's say it's 12 at night when I wanted to do a practice. When I sign up, definitely my inbox will be having a mail for me. Now, when this mail will be welcome to HackerRank, or HackerRank is a website for something. So there is some auto triggered message given to me by HackerRank once I sign up into their profile, which is there. So imagine if someone was sitting over there and he or she is sitting and waiting for you to sign up and then give you the automated mail. It will definitely take time for that user to understand, okay, you guys have signed up, then take your mail ID and generate an auto generated mail and send it across to you. It will take human intervention somewhat, but that human intervention has been cut down by the professionals. What they have did, as soon as the user sign in up, the auto generated mail will be given to the user, but that will be given once you sign up. It will not be given before you sign up. So this automated processes needs to be maintained, needs to be managed very efficiently. And that's what triggers do. Triggers are automated stored procedures. So the logic for writing this has been stored. Once you insert your data, update your data, or delete your data, this is going to save the changes for you. Imagine that when you are writing and working on your Excel file, you have opened the Excel file, you have made some changes, and when you try to close the file, don't you think so pop-up comes to your screen? Do you want to save the changes which you have made? So the updates are being made. And do you want to save it? The answer would be yes. So when you do save, and that updates would be saved. So there was an auto-generated pop-up which arose over there. Was it an automated trigger? Yes, it was an automated trigger. Imagine that today you're deleting certain files, and before deleting, it deleted and then it is asking you, do you want to delete this file? What is the purpose of asking after deletion? Because the file has been deleted over here. So triggers needs to be carefully used with respect to insert, update and delete, that is a DML statements into the databases. But triggers are also used before and after the DML statements, which means triggers cannot always be executed after the statement. It needs to be sometime executed or sometime popped before the delete has happened so far. So that is the meaning of what? That is the meaning of triggers. Triggers are automated stored procedures over here. Let's try to understand with the code, with the example which I have brought to you, and let me show you how does trigger works before and after with respect to insert, update as well as delete. If you can see on my screen, triggers. Triggers are events or conditions that cause a program or a system to execute a specific action or a set of action. So what it is doing, it is performing some action, some steps, some processes, or a set of action or a set of instruction when some or the other action or the task is being done on the databases. They are commonly used in software development. In the field of software, it is a very common use case and a widely used case. You can see triggers running around you a lot, but you don't know the logic which they are being using. They're using the logic of stored procedures somewhat, because the process of doing those tasks or the actions have been stored within the databases with the help of something called as stored procedures. So they are commonly used in software development and database management to automate processes and respond to specific events. So they respond to definitely specific events and they will work accordingly. As I said, when I as a user enroll on a HackerRank platform, they will respond once I enroll and give me a welcome email kit. If I want to delete a file, a pop-up or a trigger will automate and it will ask me, are you sure do you want to delete the file or not? So that task or that responses are being generated when the triggers are activated on certain operations which we are doing. In software development, triggers can be used to execute code logic when a specific event occurs, such as button click or a certain condition being met. For the example which I showed you. For example, a trigger may be set up to execute a specific function when a user submits a form or certain file is updated. So when I submit a form, you know that there is a pop-up coming, your file is successfully submitted, your file is successfully uploaded. So that is a trigger which is coming when the task is being executed or certain file is uploaded over here. In database management system, triggers are used to automate tasks such as updating data, enforcing business rules, or maintaining data integrity. So in order to maintain all of this in database management system, triggers are very widely used. For example, a trigger may be used to set up update on customer balance in a database when a new transaction is recorded. You remember when there is a trigger which is executed. Let's say today I send some money to some other individual. Definitely a pop-up message will come to me that money has been transferred. It will also show you the account details or the bank related statement that this much amount has been debited or the credited into your account based on whatever transaction has been happened. So you see triggers into daily life a lot, and with respect to the data management system, triggers are very important to automate the task so that the human intervention is avoided as much as possible and the data is maintained with full integrity. So, triggers can be set up to execute response to a variety of events and conditions, especially with respect to insert, update, and delete. So that is your DML statement, such as specific date or time, a change in data, or a specific user. They are powerful tool for automating processes and improving efficiency in software development and the data management tool. So for the same, I'm creating a trigger which I'll show with respect to insert, update, and delete. So I have a table, if you remember a table which we created with respect to the stored procedure, that was students. So I'll show you the table which was there, select star from what? From students. So this is a students table which is there. Now I'm creating triggers, but before creating a trigger, I'm creating a log table. Now what is this log table consisting of? This log table will consist of the messages when my trigger is activated, when my trigger is successfully running or the automative task has been completed successfully. So I don't have to go to the table and see the data. I can definitely go and see to the log table that what changes have happened. So I've created a log table, create table students log. It has log ID, that is an ID, it's an integer. So step by step as the updates happen, the log ID will be created. It's a primary key. So every change is a different change or a unique entity is being stored. Student ID. Which student ID changes have happened over here? Action. What action it is doing? Is it doing insertion, updation, or deletion? That will be stored over here, and timestamp. At what date, at what time this action happened. So I have, if I want to see, okay, what operations happen at that particular time, I can go to the log table instead of going to the main table to see what operations have happened. So I'm creating a trigger. Now the syntax for trigger looks very similar to what stored procedure is. It will have delimiter, it will have begin and end statement. But instead of writing create procedure, you'll write create trigger because triggers are slightly different from what a stored procedure is. It's an adaptive way of stored procedure, I can say. So create trigger. What is a trigger name? After insert student. Definitely imagine in Imarticus, new students are enrolling on a daily basis. Once the student enrollment is done, I want to send a welcome mail to that student that welcome to Imarticus, that what all things you will learn, you will explore, what all things do we have. So there is a welcome message needs to be sent. But definitely this welcome message needs to be sent after the student has enrolled, not before the student has enrolled. I don't know which student is going to come and enroll into my site. So the same type of trigger, I'm creating it over here. I'm giving it a name as after insert trigger. So it will activate after a student entry has been inserted. So after insert on what? On students, which is there. So for each row, definitely this insert will happen row wise. So for each row, this is going to be activated. So after insert, you will write over here. If you want before insert, so before you will write. If you want after insert, it will be activated. So you will write after insert. So here you will write insert, update or delete. It depends on you that what you wanted to do. On which table do you want to activate this trigger? You want to activate this trigger on the students table. So there is a students table. You can see a trigger activated. So far there is no trigger. Once we create, you can see the name of the triggers which are there. So for each row, begin the creation of triggers. Now what it will do? Insert into student log. So once you are inserting data into students table, this trigger will start executing for each row. As you enter each row into your students table, this trigger will be activated for each row. So begin what? Begin insert into which table do you want? It is in students table. I have student ID, I have action and the timestamp. You remember the student log table which we had created? This is a table. Now values, what it is going to store. The new ID, now new is a keyword which will have the new ID stored into the students table. So new dot student ID, the new ID which is added, and what is the message which I want to give? Your record is inserted. So if the action is successfully done, your record is inserted. And then what is the timestamp? Now, that is current date and time when this action happened. And I close the delimiter over here. So when I execute it, you can see a trigger being created known as after. Now the triggers are being created. I cannot call the trigger over here. Triggers are just an automated stored procedure. So it will only execute when the certain task of the trigger are being done. You cannot do select star from after insert students or call after insert student. It is not going to give me any outcome over here. Now students log table. What I have written, just a second, I have created this. Yeah, students log table. So you remember that what is this trigger saying? Ki when a new entry is inserted into students table, I don't have to go and see into students table. I can see the students log table that which entry has been inserted. So that's what I can do over here. So insert into students. Now you can see students table we have. This is a students table which we have. So I'm inserting a student with student roll number 118, name of the student as Sakshi, subject as Hindi, and the marks are 34. So do you think so it is successfully executed? Yes, it has successfully executed. If I see select star from students, do you think so Sakshi has been inserted? Yes. But if I want to see, does student log consist the trigger over here? Can you see this? The first log has been added. Student ID, what has been added? 9. Action, what is an action? Your record is inserted. Timestamp, what is the timestamp over here? When did it inserted? The date and the time when this record has successfully inserted the data into the table. So this is what it is shown over here with respect to after insert. Now if there is any issue, let's say I insert another data. So select star from students. If I do this and let's say I write 119 and let's say I write my name. My name is Jagrati and let's say my subject is physics. So I write like this and let's say I got a score of 45 over here. And when I try to insert, can you see column count does not match value count at row 1. So there was an error. So does this action successfully happen? No. Because I have added which trigger over here? After. So once the action was successfully done on the students, then and only then it will store on the students log table. Unless it is not going to store for me. and you can see that the students log table still doesn't consist of the same. It asks me what if the error was there, then it is not going to add. But if I would have written a before trigger, it would have successfully added that student ID, whatever it was, has been successfully added. Your action is inserted. So it is very important to use a before or an after trigger for the same. So here, you remember students table. Let me show that first ID is student ID. So let me give the student ID as 10. Student roll number is this, the name of the student is this, subject is this, and marks is this. Now when I execute it, can you see one row has been affected? So execution in the students table have happened, but I'll not go and see the students table. I'll go and see in which table, students log table. So can you see in students log table 2.student ID. Which new ID has been added over here? 10. So I wrote what? New dot student ID. So whatever was the newest recent ID has been added over here. So your record has been inserted. So I hope we are clear upon how does a trigger works on an insert. Let me try to create a trigger with respect to update over here as well as delete. So this trigger which I am using over here is going to be used after update. So same syntax. There is no difference over here. The same syntax I have used. So create trigger. Which trigger? After update student. So I have changed the name. After insert students, I have changed the name to after update students. And instead of before, I am still using what? After. Because I want the trigger to be activated only when the update has happened. I don't want to be activated before the update has happened. So after update on what? On the students table. Where I want to go and check for each row. Definitely the update will happen row wise. So I want to check all the rows with respect to the updation. Begin. Insert into students. Student ID, action, timestamp, same code. Values, now update. Obviously a new data would be added, a new modified value would be there. So new dot what? Student ID. So which student ID update was happening over here? So I'll get this. And what is a message which I want to pass into the student log table? Your record has been updated. And when it did update it? Now. So let me create this trigger over here for you. And you can see I have one more trigger after update students. So if I go to select star from students, let me see select star from students, which are there. So can you see the students table? Yes. I have what? I have to change the name of a student. I have to change the name of the student where the student ID is 5. What is the 5 student ID? Prachi. Now I want to change her name to what? Rashi, subject to what? Science, and the marks to what? 39. So I'm updating 3 values at once. So set student name as Rashi, subject as science, marks as 39 for what? For the student ID 5. So if the action is successfully done, can you see there was no error? So it's done. So if I see student ID 5, can you see earlier it was Prachi with Hindi as a subject. Now it's what? It's Rashi. So it has been updated. So can I see student log table over here? Can you see log ID 3, the third change which has happened? Student ID, which is a student ID which has happened the change? 5. What has happened? Student record is updated. And when did it happen? So you can see, instead of going to the main table where changes have happened, I can see the log table where the trigger has been activated and the information has been stored. Now let's try to create another trigger related to delete. Now what will delete do over here for us? Obviously, when I'm deleting certain records, I want the trigger to be activated. So after the delete, the trigger should activate. So create trigger after delete student, the name has been changed. After delete, I can write before delete as well. So before deleting, if you want to the trigger to be activated, you can do it. delete on students. For each row, definitely I want to do for each row. I can do for each column as well, but we mostly preferably do it for each row. Begin. Insert into student log. Obviously, when the data is deleted, student log needs to be inserted with some message. Student ID, action, timestamp. Now values. Now instead of new, I am writing old. Now remember, when I am deleting certain data, it's an old data, it's a past data which has been deleted. It's not a new entry which has been added or updated. So in insert and update, you will write new. But in your delete, you'll write old because it has been something which is removed. It's a past. So old student ID, your record has been deleted. And when did it delete it? Now. So I execute this and you can see there is a after delete student created. So when I run the students table, it's there. Let's say wherever the student name is Rashi, I'm deleting it. It was student ID 5 where I made the changes from Prachi to Rashi, and this data is now being eliminated. Instead of going to students table and checking, I'll see the log table because log table would have updated. What is the log table saying? Yes, 5 as a student ID has been deleted over here. And when did it deleted? This. So this is what a trigger is. I didn't go and put the message manually over here. When the actions related to insert, update and delete were happening within my databases, these actions were automatically stored into my log table so that I can get to see, okay, what has happened into my data and how the actions have happened. So my triggers can activate automatically before and after insert. It depends on you that you want it to execute before, do you want it to execute after. The example which I showed were purely having the detailness related to the after trigger execution because I don't want the trigger to be executed and giving me the message before the insert has happened. Imagine a scenario when you have not even signed up and that it is giving you congratulations, welcome for the sign up, hello, hi, this is your welcome kit for the employees who have added into the organization. The employee is not even a part of organization and before that only welcome kit is shared. It will be problematic for the same. So after trigger is a better choice over here instead of before. Now imagine that I am updating a file and without update it says the file has been updated. I didn't even do any update. What is the possibility that I have updated it? So I want the trigger to be activated before, not after, or after, not before. It also depends on me. Let's say I want the trigger to be activated after the update has happened. That is an ideal scenario. So my trigger would be updated over here. Let's say delete. I want the trigger to show once an outcome is deleted. Let's say there was an error when the delete happened, but the trigger said the record has been deleted. But my data still has that record because there was an error. If I use before trigger at that particular time, it would have shown me error in terms of the log table outcome which was being stored by the trigger approach. So this was all about triggers. That this is how a triggers are created, this is how a triggers are maintained, and this is how the triggers can be automatically stored. Now, this were very simple example related to how a trigger can be created. Definitely in the real world scenario, the procedures for creating triggers are a lot complicated. The logics for creating triggers are a lot complicated. And in the field of software development, triggers are something which is very vividly used. So, triggers can be used to automate your task and remove the human intervention as much as possible. And it is working with insert, update and delete most of the times with respect with before execution as well as after execution. So this was all about triggers and I hope we are able to understand what are triggers with the simplistic example which we saw today. So we are done with triggers.